false statement, and this is a true statement. So if even one of them is a true statement, the output should be true. And again, we can do this even with strings. So we can do vanilla and chocolate. There we go. And vanilla is actually greater than chocolate because V is a higher number in the alphabetical order. So V is like 20 something, whereas chocolate is 3, right? So it actually looks at the spelling for this. So if we say or here, it will come out true. And if we say and here, it should also be true because V is greater than C and 50 is greater than 10. So this should also be true. Now let's copy this right here and we're going to say not. So what we had before is 50 is greater than 10, that returned true. But now all we're doing is putting not in front of it. So instead of returning true, it's going to return false. So now let's take a look at membership operators. And we use this to check if something, whether it's a value or a string or something like that, is within another value or string or sequence. Our operators are in and not in, so it's pretty simple. If it's in, it's going to return true if the sequence with a specified value is present in the object, just like we were talking about. And for not in, it's basically the exact same thing if it's not in that object. So let's start out by taking a look at a string. We're going to say ice underscore cream is equal to I love chocolate ice cream. And then we're going to say love in ice underscore cream. And that will return true. So all we're doing is searching if the word love or that string is in this larger string. We could also just do that by literally copying this and putting this where this is. So we can check, is this string part of this string? And it'll say true. We can also make a list. So we'll say scoops is equal to, and then we'll do a bracket and we'll say 1, 2, 3, 4, 5. And then we'll say 2 in scoops. So all we're doing is searching to see if 2 is within this list, and that should return true. Now, if we put a 6 here and we said not in, it will also return true because 6 is not in scoops, and that is true. And just like we did, we could also say wanted underscore scoops, and we'll say 8. So I wanted 8 scoops, so we can say wanted scoops in scoops, and this should return true because there's not an 8 within the scoops that we wanted. And if we said in, and we said we wanted 8, is that within our list that we created? And that's going to return a false. So that is a quick breakdown of comparison, logical, and membership operators. I hope that this was helpful. Thank you guys so much for watching. If you like this video, be sure to like and subscribe, and I will see you in the next video. Hello everybody. Today we're going to be taking a look at the if statement within Python. Now it's actually the if else statement, but that's a mouthful, so I'm just going to call it the if else statement. Now we have this flowchart, and I apologize for it being blurry, but this is the absolute best one that I could find. Right up top, we have our if condition. Now, if this if condition is true, we're going to run a body of code. But if that condition is false, we're going to go over here and go to the elif condition. The elif condition or statement is basically saying, if the first if statement doesn't work, let's try this if statement. If this elif statement is true, it goes to this body of code. If it's false, it'll come over here to the else. And the else is basically, if all of these things don't work, then run this body of code. Now you can have as many elif statements as you want, but you can only have one if statement and one else statement. So let's write out some code and see how this actually looks. Let's first start off by writing if. That is our if statement, and now we have to write our condition, which is about to be either met or not met. So we'll say if 25 is greater than 10, which is true, we'll say colon, and then we're going to hit enter. And it's going to automatically indent that line of code for us. And this is our body of code. So if 25 is greater than 10, our body of code will execute. So for us, we're just going to write print and we'll say it worked. Now, if we run this, it's going to check, is 25 greater than 10? If that is true, print this. So let's hit shift enter and it worked. Now let's take this exact code, we'll paste it right down here and we'll say is less than. And right now, this if statement is not true. So it's not actually going to work. As you can see, there's no output. There's nothing that happened really, but it did check to see if 25 was less than 10, but it just wasn't true. Now we can use our else statement. So we're going to come right down here and we're going to say else, and we'll do a colon, and we'll hit enter again, automatically indenting. And we're going to say print And we're going to say it did not work, ... So what it's going to do is it's going to come up here and check, is 25 less than 10? No, it's not. So this body of code is not going to be executed. It's going to go right down to this else statement. Now this else statement is going to be printed. There's no condition on this. So the if statement has a condition, 25 is less than 10. This has no condition. So if this doesn't work, if this is false, it's going to come down here and it will run this body of code. Let's run this by clicking Shift Enter. And as you can see, our output is it did not work. Now let's go back up here and put greater than, because this is now true. It's going to say if 25 is greater than 10, print it worked, and then it's going to stop. It's not going to go to this else statement at all. So let's run this, and our output is it worked. So what if we have a lot of different conditions that we want to try? Let's come right down here. This is where the elif comes in. So really quickly, let's change this to a not true, a false statement. We're going to go down and say elif, and we're going to say if it is, and let's say 30, we'll say elif worked. So now it's going to check, is 25 less than 10? No, it's not. Let's look at the next condition. Is 25 less than 30? And if it is, we'll print elif worked. So let's try running this, and elif worked. Now we can do as many of these elif statements as we want. We can do, let's just try a few of them right here. So we'll say if 25 is less than 20, is less than 21, and let's do 40, and let's do 50. So we'll say elif, elif2, elif3, and elif4. Now, if you look at this, the first one that is actually going to work is this 25 to 40 right here. Once this one is checked and it comes out as true, none of the other elif or else statements will work. So let's try this one. It should be elif3, and this one ran properly. Now within our condition so far, we've only used a comparison operator. We can also use a logical operator like and or. So we can say if 25 is less than 10, which it's not, and let's say or actually, and we'll say or 1 is less than 3, which is true. If we run this, now it will actually work. So we can use several different types of operators within our if statement to see if a condition is true or not, or several conditions are true. There's also a way to write an if else statement in one line if you want to do that. So we can write print, we'll say it worked. And then we'll come over here and say if 10 is greater than 30. And then we'll write else print, and we'll say it did not work. Just like we had before, except now it's all occurring on one line. So let's just try this and see if it works. So it's saying print it worked if 10 is greater than 30, which it wasn't. So it went to the else statement, and then it printed out our body right here. Although we didn't have any indentation or multiple lines, it was all done in one line. Now there's one other thing that we haven't looked at yet, and I'm going to show it to you really quickly, and that's a nested if statement. So when we run this, it's going to say it worked. It works because it says 25 is less than 10 or 1 is less than 3. Since this is true, it's going to print out it worked. But we can also do a nested if statement. So we can do multiple if statements as well. So we're going to hit enter and we'll say if, and we'll do a true statement here. So we'll say if 10 is greater than 5. Let's do a colon, hit enter, and then we'll say print. And then we'll type a string saying this nested if statement, worked. Now let's try this out and see what we get. So it went through the first if statement. It said it was true and it prints out it worked. This is still the body of code. So it goes down to this next if statement. And it says if 10 is greater than 5, we're going to print this out. And you could do this on and on and on. It can basically go on forever, and you can create a really in-depth logic. And that actually happens a lot when you start writing more advanced code. So I hope that this was helpful. I hope that you understand the if-else statement better. And I hope that you understand how nested if statements work as well. Thank you guys so much for watching. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. Hello everybody. Today we're going to be learning about for loops in Python. The for loop is used to iterate over a sequence, which could be a list, a tuple, an array, a string, or even a dictionary. Here's the list that we'll be working with throughout this video. And I have this little diagram right here, which kind of explains how a for loop works. The for loop is going to start by looking at the very first item in our sequence or our list. And that's going to be our one right here. It's going to ask, is this the last element in our list? And it is not. So it's going to go down to this body of the for loop. Now we can have 1,000 different things that can happen in the body of the for loop, as we're about to look at in just a second. Then it's going to go up to the next element and ask, is this the last element reached? So it'll be no again, because we'll be going to the 2, and then the 3, and then the 4, and the 5. Once it reaches the 5, it'll go to the body of the for loop. And then when it asks if that's the last element, the answer would be yes, because it's iterated through all the items within the list, and then we would exit the loop and the for loop would be over. Now that may not have made perfect sense, but let's actually start writing out the syntax of a for loop so we can understand this better. To start our for loop, we're going to say for, and then we're going to give it a temporary variable for this for loop. So it's a variable as it iterates through these numbers, it's going to assign the variable to that number. So for this one, we're just going to say number because it's pretty appropriate because these are all numbers. And then we're going to say in integers. Now, right here, you can put just about anything. This could be the list, this could be a tuple, this could be a string even. But that is what we're going to iterate through. So we're saying for the variables, each of these numbers, within this list of integers, and then we're going to write a colon. This is the body of code that's going to actually be executed when we run through and iterate through our list. So for our first example, we're going to start off super simple, and all we're going to do is say print, open parentheses, and say number. As it iterates through the 1, 2, 3, 4, and 5, number becomes our variable that is going to be printed. So during that first loop, our 1 will be printed because that will be assigned right here. Then through the next iteration, the 2 will be assigned, and it'll be put right here in each loop until the very end. So let's hit Shift Enter. And as you can see, it did exactly that. Now in this body, and I'll copy and paste this down here, in this body, we really can do just about anything we want. We don't even have to use this variable number right here. We can just print yep if we wanted to. And what it's going to do is for each iteration, all 5 of those, every time it loops through, it's going to print off yep. So let's hit Shift Enter, and it printed it off for us. So really, we weren't even using the numbers within the list. We were really just using it as almost a counter. Now let's copy this integers once again. Let's go right up here, and let's go copy this for loop that we wrote. Now, we do not have to call this number. This can be anything you want, any variable name that you'd like to name it. We could call it jelly, and we can do jelly plus jelly. I think you're getting the picture, right? When it loops through that 1, it's doing 1 plus 1. When it loops through the 2, it's doing 2 plus 2. That is basically how a for loop works. Now for a dictionary, it's going to handle it a little bit differently. So let's create a dictionary really quickly. So we'll say ice cream dictionary is equal to, we're going to do a squiggly brackets. So we're going to say name, and we're going to say colon. We need to assign our value for that item. So we're going to say Alex Freeberg. We'll do our next one separated by a comma, and we'll say weekly intake. And I'll say 5 scoops per week. The next one we will do is favorite ice creams. And for this one, we're going to do something a little bit different. For this, we're going to have a list within this dictionary. So we'll say within our list of my favorite ice creams, we'll say mint chocolate chip, and I'll just do MCC for that. And we'll separate that out by a comma, and we'll say chocolate. So now we have this dictionary, ice cream dict, and within it we have my name, my weekly intake, and my favorite ice creams with a list in there as well. Let's hit Shift Enter. And now we're going to start writing our for loop. Now the for loop is going to look very similar, but to call a dictionary, it's just a little bit different. So we're going to say for the cream in ice underscore cream underscore dictionary dot values, and then we're going to do parentheses and then a colon. Now we're going to print the cream. So in order to indicate what we actually want to pull, we have to specify within the dictionary what we want. Are we pulling the item? Are we pulling the value? We need to specify this. So that's why we have this dot values right here. So let's run this and see what we get. So as you can see, we are pulling in the values right here. That's why we're pulling in Alex Freeberg, 5, and mint chocolate chip / chocolate. Now we are able to call both of those, both the key and the value. So let's go right down here and we can do both the key and the value. So we can pull two things at one time. And we're going to do this by saying dot items. So we could also do dot key if we just wanted to do a key, but we want to do items, so we're going to do both of them. So we're going to go right down here and say for key and value in ice cream dictionary dot items, print, and let's write key, and then we'll do a comma, and then let's give it a little arrow or something like that, something like this. And then we'll do a comma and we'll say value. And let's print this off and see what we get. So it's looping through, and for each key and value, it's saying here is the key. So that's the name. Then we have weekly intake. Then we have favorite ice creams. It's giving us a little arrow, and then we're also printing off the value. So we have name, Alex Freeberg, weekly intake 5, favorite ice creams, mint chocolate chip, and chocolate. So now let's talk about nested for loops. We've looked at for loops. We understand how they work and why they do what they do, but what about a nested for loop, a for loop within a for loop? For this example, let's create two separate lists. Let's create flavors, and let's make that a list by making it a bracket. And we'll do vanilla, the classic, chocolate, and then cookie dough. All great flavors. So that's our first list. And then we're going to say toppings. And we'll do a bracket for that as well. And we'll say hot fudge. And then we'll do Oreos. And then we'll do marshmallows. Is that how you spell marshmallows? I think it's an E. That looks wrong. I might be spelling it wrong, but that's okay. So let's save this by clicking Shift Enter. And now we have our flavors and our toppings. So now let's write our first for loop. So we're going to say for 1, as in our number 1 for loop. We're going to say in flavors, and we'll do a colon. We'll click Enter. Now we can write our second for loop. So we're going to say for 2 in toppings, and then we'll do a colon and Enter. And then we're going to say print, and we'll do an open parentheses, and then we're going to say 1. So we're printing the 1 in flavors, and then we're going to say 1, comma, I'm going to say topped with, comma, 2. So what this is essentially going to do is we're going to say for 1, we're going to take the very first 1 in flavors, and then we're going to loop through all of 2 as well. So we're going to loop through hot fudge, Oreos, and marshmallows. And once we print that off, then we will loop all the way back to flavors and look at the next iteration or the next sequence within the first for loop. So let's run this really quickly and see what we get. So as you can see, it goes vanilla, vanilla, vanilla. And vanilla is topped with the hot fudge, the Oreos, and the marshmallows. And then we start iterating through our second one in our first for loop. So there's that hierarchy. So we're iterating completely through this one before we actually go to the very first for loop and start iterating through that one again. Now that is essentially how a nested for loop works. These nested for loops can get very complicated. In fact, for loops in general can get very complicated the more you add to it and the more you're wanting to do with it. But that is basically how a for loop and a nested for loop works. Thank you guys so much for watching. Be sure to like and subscribe below, and I'll see you in the next video. Hello everybody! Today we're going to be taking a look at while loops in Python. The while loop in Python is used to iterate over a block of code as long as the test condition is true. Now the difference between a for loop and a while loop is that a for loop is going to iterate over the entire sequence regardless of a condition, but the while loop is only going to iterate over that sequence as long as a specific condition is met. Once that condition is not met, the code is going to stop and it's not going to iterate through the rest of the sequence. So if we take a look at this flowchart right here, we're going to enter this while loop and we have a test condition right here. The first time that this test condition comes back false, it's going to exit the while loop. So let's start actually writing out the code and see how this while loop works. So let's create a variable. We're just going to say number is equal to 1. And then we'll say while. And now we need to write our condition that needs to be met in order for our block of code beneath this to run. So we're going to say while number is less than 5. And then we'll do colon, enter. And now this is our block of code. We're going to say print, and then we'll say number. Now what we need to do is basically create a counter. We're going to say number equals number plus 1. If you've never done something like this, it's kind of like a counter. Most people start it at 0. In fact, let's start it at 0. And then each time it runs through this while loop, it's going to add 1 to this number up here. And then it's going to become a 1, a 2, a 3 each time it iterates through this while loop. Now, once this number is no longer less than 5, it'll break out of the while loop and it will no longer run. So let's run this really quick by hitting Shift Enter. So it starts at 0, and it's going to say while the number is less than 5, print number. So the first time that it runs through, it is 0, and so it prints 0, and then it adds 1 to number, and then it continues that while loop right here, and it keeps looping through this portion. It never goes back up here to this line of code. This is just our variable that we start with. And then once this condition is no longer met, once it is false, then it's going to break out of that code. Now that we basically know how a while loop works, let's look at something called a break statement. So let's copy this right down here. And what we're going to say is if number is equal to 3, we're going to break. Now with the break statement, we can basically stop the loop even if the while condition is true. So while this number is less than 5, it's going to continue to loop through, but now we have this break statement. So it's going to say if the number equals 3, we're going to break out of this while loop. But if this is false, we're going to continue adding to that number just like normal. So let's execute this. So as you can see, it only went to 3 instead of 4 like before, because each time it was running through this while loop, it was checking if the number was equal to 3. And once it got to 3, this became true, and then we broke out of this while loop. The next thing that I want to look at, and we'll copy this right down here, is an else statement, much like an if statement, but we can use the else statement with a while loop, which runs the block of code, and when that condition is no longer true, then it activates the else statement. So we'll go right down here, and we'll say else, and we'll do a colon, and enter, and then we'll say print, and we'll say no longer less than 5. Now, because this if statement is still in there, it will break. So let's say 6, and then we'll run this. And so it's going to iterate through this block of code. And once this statement is no longer true, once we break out of it, we're going to go to our else statement. Now, as long as this statement is true, it's going to continue to iterate through. But once this condition is not met, then it will go to our else statement and we'll run that line of code. Now the else statement is only going to trigger if the while loop no longer is true. If we have something like this if statement that causes it to break out of the while loop, the else statement will no longer work. So let's say if the number is 3 and we run this, the else statement is no longer going to trigger, so this body of code will not be run. Now, the next thing that I want to look at is the continue statement. If the continue statement is triggered, it basically rejects all remaining statements in the current iteration of the loop, and then we'll go to the next iteration. Now, to demonstrate this, I'm going to change this break into a continue. So before, when we had the break, if the number was equal to 3, it would stop all the code completely. But when we change this to continue, which we'll do right now, what it's going to do is it's no longer going to run through any of the subsequent code in this block of code. It's just going to go straight up to the beginning and restart our while loop. So what's going to happen when we run this is it's going to come to 3, it's going to become 3, and it's going to continue back into the while loop, but it's never going to have that number change to be added to 1 to continue with the while loop. This will basically create an infinite loop. Let's try this really quickly. And as you can see, it's going to stay 3 forever. Eventually this would time out, but I'm just going to stop the code really quick. So if we just change up the order of which we're doing things, we're going to say there, and we're going to put this down here. So what it's going to do now, instead of printing the number immediately and then adding the number later, we're going to add the number right away. And then we're going to say, if it is 3, we're going to continue and it's going to print the number. So let's try executing this and see what happens. So as you can see, we no longer have the 3 in our output. What it did was when we got to the number 3, it continued and didn't execute this right here, which prints off that number. So that really is the basics of the while loop. I hope that this was helpful. I hope that you learned something in this video. If you did, be sure to like and subscribe below, and I'll see you in the next video. Hello everybody. Today we're going to be taking a look at functions in Python. A function is a block of code which is only run when you call it. So right here we're defining our function, and then this is our body of code that when we actually call it is going to be ran. So right here we have our function call, and all we're doing is putting the function with the parentheses. That is basically us calling that function, and then we have our output. Throughout this video, I'm going to show you how to write a function as well as pass arguments to that function, and then a few other things like arbitrary arguments, keyword arguments, and arbitrary keyword arguments. All of these things are really important to know when you are using functions. So let's get started by writing our very first function together. We're going to start off by saying def. That is the keyword for defining a function. Then we can actually name our function. And for this one, we're just going to do first underscore function, and then we do an open parentheses. And then we'll put a colon, we'll hit enter, and it'll automatically indent for us. And this is where our body of code is going to go. Now within our body of code, we can write just about anything. And in this video, I'm not going to get super advanced. We're just going to walk through the basics to make sure that you understand how to use functions. So for right now, all we're going to say is print, we'll do an open parentheses, we'll do an apostrophe, and we'll say, we did it. And now we're going to hit shift enter. And this is not going to do anything. At least you won't see any output from this. If we want to see the output, or we actually want to run that function, and some functions don't have outputs, but if we want to run that function, what we have to do is just copy this. I'm going to put it right down here. And now we're going to actually call our function. So let's go ahead and click shift enter. And now we've successfully called our first function. This function is about as simple as it could possibly be, but now let's take it up a notch and start looking at arguments. So let's go right down here, and we're going to say define number underscore squared, and we'll do a parentheses and our colon as well. Now really quickly, when you're naming your function, it's kind of like naming a variable. You can use something like X or Y, but I tend to like to be a little bit more descriptive. But now let's take a look at passing an argument into a function. The argument is going to be passed right here in the parentheses. So for us, I'm just going to call it a number. And then we're going to hit enter, and now we'll write our body of code. And all we're going to do for this is type print and open parentheses, and we'll say number, and we'll do 2 stars, at least that's what I call it, a star, and a 2. And what this is going to do is it's going to take the number that we pass into our function. It's going to put it right here in our body of code. And then for what we're doing, it's going to put it to the power of 2. And so when the user or you run this and call this function, this number is something that you can specify. It's an argument that you can input that will then be run in this body of code. So let's copy this right here, and then we'll put it right down here into this next cell, and we'll say 5. And so this 5 is going to be passed through into this function and be called right here for this print statement. Let's run it, and it should come out as, I believe, 25. That is my fault. I forgot to actually run this block of code. So I'm going to hit shift enter. So now we've defined our function up here, and now we can actually call it. So now we'll hit shift enter, and we got our output of 25. Now in this function, we only called one argument, but you can basically call as many arguments as you want. You just have to separate them by commas. So let's copy this, and we'll put it right down here. Now we'll say number squared underscore custom, and then we'll do number, and then we'll do power. So now we can specify our number as well as the power that we want to raise it to. So instead of having 2, which is what you call hard-coded, we can now customize that, and we'll have power. And now when we call this function, we can specify the number and the power, and both of those will go into this body of code and be run, and we can customize those numbers. So let's copy this, and we'll say 5 to the power of 3. And let's make sure I ran this. So let's do shift enter. And now we will call our function, and let's hit shift enter. And we got 5 to the power of 3, which is 125. And just one last thing to mention is if you have 2 arguments within your function and you are calling it right here, you have to pass in 2 arguments. You can't just have one. So if we have a 5 right here, it's going to error out. We have to specify both arguments for it to work. Now let's take a look at arbitrary arguments. Now, arbitrary arguments are really interesting because if you don't know how many arguments you want to pass through, if you don't know if it's a 1, a 2, or a 3, you can specify that later when you're calling the argument, so you don't have to do it up front and know that information ahead of time. So let's define our function. So we're going to say define, and then we're going to say number underscore args, and we'll do an open parentheses and a colon. Now within our argument right here, typically we would just specify, here's what our argument will be. It will be number, or it will be a word, right? But what we're gonna do is something called an arbitrary argument, so it's unknown. So we're gonna put star, and then we'll say args. Now you will see something exactly like this. Typically, if you're looking at tutorials, they'll have star args in there, or if you're looking at just a generic piece of code, this is what it will look like. But for us, we're gonna actually put number. So again, we have the star, and then we have our arbitrary argument right here. And then we'll hit enter, and we're gonna say print, open parentheses, and this is where it's gonna get a little bit different. So we're gonna say number, and then we're gonna do an open bracket, and let's say 0, and then we'll do that times, and then we'll say number again with a bracket of 1. So in a little bit, once we run this and then we call this number args function right here, we're going to need to specify the number 0 and the number 1 that's going to be called. So let's go ahead and run this. And then we are going to call it. And let's say 5, 6, 1, 2, 8. So right up here, we did not know how many arguments we were going to pass through. It could be 5, it could be 1,000. We could also call in a tuple, and that's what this is right here. We're calling in a tuple. So what it's going to do now is when it calls this number, it's going to call the very first within that tuple, which will be that 5. And then it'll also call in this number, which will be the first position, which is the 6. So let's hit Shift Enter, and it's going to multiply these numbers together. So 5 times 6 is equal to 30. Now, like I just said, this is a tuple. So we don't actually have to write out these numbers like we just did. We can pass through a tuple when we are actually calling this function. Let's do that right up here. Let's just create, let's call it args underscore tuple, and we'll do open parentheses, and we'll do the same numbers. Let's just copy it to make it easier. And now we've created this tuple right here, which we can then pass in. And this is a lot more handy, a lot more specific, and this is most likely how someone would do something like this. But let's now create this. And now we can copy args tuple and pass it through. Now, really quickly, this is going to fail, and I'm doing that on purpose, but I want to show you what you need to do in order to pass through this tuple. So right now it's going to say tuple index is out of range. All you have to do in order to use this is you have to specify a star before it, just like you did when you were creating your argument up here. You have to put a star in front of our tuple that we just passed through. And now let's try running this. And now it works properly. Now, the last two things that we're going to look at are keyword arguments and arbitrary keyword arguments. There are more things that you can learn and do within functions, but again, I'm just trying to teach you the basics to make sure that you understand how they work. So let's go right up here. And a keyword argument is kind of similar to this right here. And let's actually copy this and put it right down here. Now, a keyword argument is very similar in that you're going to specify your arguments right here. But what we did up here, let me bring this down. When we actually called the function, what we did was we just put in a 5 and a 3. And when we did that, it automatically assigned number to 5 and power to 3. And that's totally fine, and you can do that. But if you want a little bit more control, you can use a keyword argument. So right here, we could say power is equal to 5 and number is equal to 3. So I just switched it around, right? Number was assigned to 5 and power was assigned to 3, but I just switched it to show you how this might work. So let's run both of these. And now it's 3 to the power of 5, which is 243. So that essentially is a keyword argument. Again, it just gives you a little bit more control. You don't have to put them in specific positions, like if you're just calling multiple arguments. Now let's come right down here. We're going to create basically another custom function. So for this one, we're going to write define number underscore arg. And then we'll do an open parentheses, a colon, and enter. And what this one is this one is a keyword argument or an arbitrary keyword argument. Now to specify an arbitrary argument, all we did was a star, and then we input number. But if we're doing a keyword argument, we actually have to have 2 stars right here. So let's start taking a look. And again, if you're doing arbitrary, it means we don't really know how many keyword arguments we want to pass into our function. So we're just going to put star star number, and then later within our body of code, and when we're calling it, we'll be able to specify it. And just like the arbitrary argument before, the arbitrary keyword argument means we really just don't know how many keyword arguments we're going to need to pass into our function. So to demonstrate this, let's write print, do an open parentheses, and we'll say my, need to do an apostrophe. My number is, and we'll do just like that, little space, and we'll say plus. And this is kind of where it gets a little interesting or a little bit more tricky. So what we're going to say is number. So this is us calling our number. And then we're going to do a bracket. And then I'm actually going to go to calling the function. It's a little bit backward or a little bit different than what you might think. But when we're calling it, what I'm going to do is I'm going to say integer is equal to, and let's just do some random number. Now, when we're calling that keyword within our body of code, what we're going to do is we're going to actually type out integer, just like this. And this looks a little bit different. But what this allows us to do is we can put as many keyword arguments in here as we want later, and I'll show you in just a second. But for us, we're just creating this key and this value when we are calling it within the function. So now when we create this and we run this, oh, whoops, I forgot. This has to be a string. So let's run this again. Now what we'll say, my number is 2309. Then we're going to add, we'll say plus, and this isn't going to look great, but we'll say my other number, because this will all be in the same line. That's okay. My other number, and then we'll say number, and we can specify again what we want in there. So now we can go down here to where we're calling it. We'll just put a comma, and we'll say integer, integer 2 is equal to, we'll do a random number. And then we'll put integer 2 right here. And then we'll add plus right here so we don't error out. We'll create this, we'll run this. And as you can see, both numbers were passed through. Again, the syntax is terrible, but now you can see that you have this arbitrary keyword argument right here. And all we have to do is put number, and we can pass through as many of these arbitrary keyword arguments as we want, as long as we just specify it within our function when we're calling it. So that's all we're going to look at in today's video on functions. There are, of course, other things that you can do within functions, and it can get a little bit more advanced, but I wanted to show you the basics, the meat and potatoes of things that I definitely think you should know in order to get started using functions. I hope that you were able to understand functions better because of this video. If you did, be sure to like and subscribe below, and I will see you in the next video. Hello everybody. Today we're going to be talking about converting data types in Python. In this video, I'm going to show you how to convert several different data types, including strings, numbers, sets, tuples, and even dictionaries. So let's start off by creating a variable. We'll say num_int is equal to 7. And we can check that data type by saying type, and then inserting our variable num_int. And that will tell us that our data type for this variable is an integer. Let's go ahead and create another one. We're going to say num_string is equal to, and for this one, we'll also do a 7, but let's check the type, and we'll do an open parentheses, and we'll say the type of num string, and that one is a string. Now let's say we wanted to add those. We'll say num_sum, so the sum of num_int plus num_string. Now, when we're adding these two values, it is not going to work. It's going to give us an error, and it's going to say unsupported operand for int and string. So it cannot add both an integer and a string. What we need to do in order to add these two numbers is to convert that string into an integer. So let's go right up here. Let's add another cell, and let's say num_string_converted is equal to, and we want to convert it into an integer. So all we have to do to convert it into an integer is type int, and then we're going to say num_string. And that is as easy as it's going to get. All we have to do is say integer with our num string inside of it, and then it's going to convert it. And we can even check it right after by saying type num string converted, and let's run this. And now we can see that it was converted into an integer. So now let's add that num string converted right here. Let's copy and replace that string with the string converted. And let's actually print out that num_sum. And it worked properly. Now we did not specify what type of value this num sum was going to be, but because it was two integers in here, it's going to automatically apply that data type of integer to that num sum. Let's go right down here. And now let's look at how we can convert lists, sets, and tuples. So now let's say we have a list underscore type, and that's equal to 1, 2, 3. And we can check it again by saying type, and that is a list. Let's say we want to convert it to a tuple. It's fairly easy. All we're going to do is write tuple, say list underscore type. And that list underscore type is now going to be a tuple. And we can check that by saying type and wrapping it around this tuple. And it shows us that it is converting that list into a tuple. Now we can also convert a list into a set, but it may change the actual values within it. And let's check that out really quickly. So let's say we have this list and let's add a few more values to this, just like that. Now let's say we want to convert it to a set. So we're going to run this and we'll say set of list underscore type. And let's try running this and see what the output is. So this is something that you really need to be aware of when you are converting data types, because set does not act the same as a list. A set is basically going to take the unique values in the list and convert it to a set, and it fundamentally changes the data that was in that original list. And just to check the data type, we can say type. I'm just doing this for all of them. And as you can see, that is now a set. Now let's go down here and take a look at dictionaries. Now let's say we have a dictionary called dictionary underscore type. And we'll do a squiggly bracket and we'll say name and we'll do a colon and we'll say Alex. Then we'll do age and a colon and we'll say 28. And then we'll do hair, colon, and so really quickly, let's take that dictionary type and just confirm that it is a dictionary, and it is. And now what we're going to do is take a look at all of the items within that dictionary. So we're going to do dictionary type dot items, open parentheses, and this is going to show us all the items within it. Now we can also take this and look at something like the values. And when we run that, these are our values. So within our dictionary, we have items, and that's what this is right here. This is one item. And then within that, we have our values, which are right here. So Alex, 28, and NA. And then we have something called a key. And this is the key. The name, age, and hair are all keys. And we can look at that by saying dot keys. So let's say we want to take all of the keys and put that into a list. What we're going to do is we're going to take this right here. We're going to say list. We'll do an open parentheses. We'll type that in right there. So it says a list, and we're converting these keys into a list. And let's run that. And now this is a list. And let's just check the type as well, just to confirm. And as you can see, it was converted properly into a list. And we can do the exact same thing with values. And the values can also be converted into a list. Now we can also convert longer strings that aren't just numbers like we did above in our very first example. So let's do long underscore string, and we'll say, I like to party. Now we're going to take this string and we're going to say list long string. So we're going to convert this string into a list. And let's see what happens. So it took every single character in that string and put it into a list. And we could also do a set as well. That one's a lot shorter because it's only looking at unique values. So that is how you convert data types in Python. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. Hello everybody. Today we're going to be working on building a BMI calculator in Python. Now, before we get started, I want to show you this BMI calculator that I found online, and it shows you the basic calculation that they use, and that's the one we're going to use in this video. And they also have this calculator right down here and some ranges that we can use for our calculator as well. So for reference, I weigh about 170, I'm about 5'9". Let's calculate this. So I'm about a 25.1 BMI, which falls into the overweight category. That's unfortunate. But we can see exactly how this works and how ours should work when we actually build it. So we're going to kind of reference this throughout the video. So let's go right over here to our BMI calculator. We need to calculate weight and height and then run this calculation right here. So let's go ahead and copy this. And we're going to put it right down here. And so now we have our calculation. So what we need is we need input from a user, and there is an input function within Python that we're going to be using. So let's actually give me a few more cells. So the first thing that we need to calculate is their weight. Let's type out weight right here. We'll say weight is equal to, and this is where we'll use our input function. So we'll say input. And when we actually run this, it's just going to give us this blank square where a user can input something. We'll say Alex. So this is our output, is what the actual user input. And it does save it to this variable. So if we say print weight, it will still print out Alex. Now this is where we want the user to, just like we did before, where they'll input their weight. So we want to kind of give them a prompt for this. We'll put a string in here. So I'll do a double quote, and then I'll say enter your weight in, and we're using pounds. Say pounds, colon, space. So now when we do this, it'll say enter your weight in pounds. I'll say 170. And then when we run this, it does store that. Now let's do print. I should have saved it. Weight again. Oops. Now it's only storing the value of 170. It's not actually storing this string right here. So that's really important for when we do our calculations later. I'm gonna save this right down here because I'm sure I'm gonna use that later. So we have that, it's working. Now we need to also do our height. So let's copy this and we'll put it right here, and we'll do height and enter your height in inches. So now for this one, if we hit enter, that's actually running. Let's stop it really quick and interrupt it. Let's try running this. So it's going to say enter your weight in pounds. That's the first input, say 170. And then when I hit enter, it's going to prompt me for that second input. And so in inches, 5'9" is 69 inches. And then I can hit enter again. And now we have both of our inputs. Now we need this calculation right down here. And just like that. So now we have weight in pounds times 703 divided by height in inches by height in inches. So we actually have weight, and it's already written in there, but I'm just going to do it like this. We'll do weight times 703. So that's pounds. There are weight in pounds times 703 divided by, now we have our height in inches times the height in inches. So this is our calculation right here. So let's do this exact same thing. Let's run this. And this times, of course, is not going to work. Whoops. We need to do our star for both of these. All right, now this is our calculation. So let's run this. So we have 170, and that's pounds, and inches was 69. We hit enter. And it says cannot multiply the sequence of non-integer type of string. That's because these are being stored in strings. So right down here, I do, and we'll do type of height. When we run that, this is actually a string. So we want to change that because we don't need that anymore. Get rid of that. So we don't want it to be a string. We need those to be integers or floats or really anything besides a string. It just needs to be numerical. So integer or float really. So let's do integer, and then we'll wrap that input in it. And we'll do the same thing for this one. Now we have an integer for our weight, an integer for our height. So now when we're running this calculation, it should work properly. Let's run this again. Our pounds are 70. Our height is 69 inches. And it's not giving us our output because we're not printing anything. Okay, so I just need to do print BMI. So let's try this again. 170, 69, and there is our BMI, 25.1. So it worked the exact same as this one. So they input, well, we input our height, we inputted our weight, we inputted our height, and then it calculated our BMI. The next thing that we need to do is we need to kind of give the user some context. Is that good? Is their BMI within a good range, a bad range? We don't know. So let's go ahead and I'm going to see if I can copy this. I don't know if this will work or not. Let's go ahead and copy this right down here. Perfect. So what we now need to do is we need to say, okay, if the user has given us this input, we want to give them or tell them if they are a normal weight, overweight, obese, severely obese, anything like that. And we have these ranges, so that should help us out quite a bit. So let's just write our if statement and then we'll include it up here. But let's go down here and we'll say if, and then we'll do BMI. And let's just say BMI is greater than 0. So if it's greater than 0, if they had any input where the BMI was not 0, which should be every time if they do it properly and they don't, put a string in there or something or type out 40, which maybe we should make a prompt for that if that happens. Then we can say if, we'll do BMI, and now we need to give that first range. So this range right here. So if it's under 18.5, so we need to do a less than. So if it's less than 18.5, and it just says under, it doesn't say under or equal to, so I'll keep it at 18.5. So if it's under 18.5, then let's give kind of the output. We'll say print, and the output or basically the prompt is underweight. So we'll just say you are undercase, underweight, and just like that. And then we're going to pass several elif statements through here. Well, let's just say else. So I guess this would be like if they don't input something properly or something messes up, maybe we could write something like print. Oops. I'm thinking all this through. We can write print, enter valid inputs or something like this, or we can always change that. But let's really quickly, let's run this. Okay, so I'm not in that range. Let's make the next one. So then I can be within a certain range. Oops. And we should need one more at a minimum. So we'll say elif and elif. These next two are this 24.9. So it's going to check this one first. So if it's 18.5 or below 18.5, it's automatically going to print this one. So this next one, we don't have to do like a range or anything. We can just say if it's between 25 and 29.9. So this one actually should be less than or equal to. This one is normal. Oh, whoops. 24.9. So this one is 24.9. This one is going to say you are normal weight. So let's run this now. Let's see. BMI was 25.1. Oh, guys, I'm just messing up here. I apologize. All right. This is the one that I was part of. So now it's going to be part of the overweight crowd. Now let's run this. And now our prompt is you are overweight. Because remember, the BMI was saved right here as 25.1. Down here, if we run through this, it's saying, no, you're not in, oops. Get rid of that. No, you're not in under 18.5. You're not under 24.9. If you're under 29.9, you are overweight. So that did work properly. So that's really good. And I don't think I want this to be our output for the person because we're going to add this up here. It's just going to give us the BMI. And then the output is going to say you are overweight. Let's make it a little bit more customized. I'm going to say name is equal to input. And then we'll say enter your name. So it'll be enter your name. We'll do Alex, 70, 69. There's our BMI. Now it's going to run through this logic, or it will run through this logic in just a second when we actually finish this. So then we have 34.9. And let's do one more. Oops. And then this one's going to be for 39.9. So this one was overweight. This one is obese. severely obese. So we'll say severely, is that how you spell it? Severely obese. And then anything that's over that, 40 and over. So if it's not this one, anything else should be morbidly obese. So actually this else statement right here should say, you are severely obese. And this is going to say morbidly obese. Now I added that name up here because I wanted to add that down below actually. So we're going to say name plus, and then we'll do like, comma, you are underweight. So it'll be a little bit more personalized. I think it'll be a nice touch. I really do. We'll do it like this, and we'll say you. And let's go back and do that to all of them. And let me see how quickly I can do this. Oops. Oh, whoops, what did I do? Get rid of that. Name plus you, like that. Jeez, you guys are seeing me mess up a ton. Name plus you, and then name plus you. So now let's run this. And now it's a little more personalized. It says, Alex, you are overweight. So this is all really good. Now, this is an if statement. What we had done before, I think, is actually what we should put right down here. So we'll say else. And then if that doesn't work, we'll say, what do we say? Enter valid input. We'll just put that. And let me see if I can test this out. I don't know if this will error out or if this will even work. Let me just see if I can mess with it and see if I can get it to work. Actually, let's copy this. We're going to copy this whole thing. We're going to include it right here. And now we have basically our entire calculator. So let's run this. Enter your name. We'll say Alex. Enter your pounds, 170. Enter your inches, 69. And then it's going to say 25.1. Alex, you are overweight. And that's perfect. We could even go as far as adding like some feedback. We could say you are overweight, and then it would be a period. And we could say you need to exercise more. Stop sitting and writing so many Python tutorials. So now if we run this, we'll do Alex, 170, 69. It says, Alex, you are overweight. You need to exercise more and stop sitting and writing so many Python tutorials, period. And that's it. This is the entire project. You can go a ton farther. You can include much more complex logic. You could even build out a UI to create your own, app just like this, where it has this input and this UI. You can build that out in Jupyter Notebooks with Python, but that's not really what this tutorial is for. This is just to kind of help you think through some of the logic of creating something like this. So, I hope that this was helpful. I hope that this was fun. I like creating stuff like this. We have 2 other projects that we're going to do, and maybe I'll include more, but we have 2 right now that I have planned. And I hope those are helpful. This is probably our easiest one, and they'll get a little bit more difficult in the next projects. So I hope that this was fun. I hope that this was helpful and that you can now kind of utilize those Python skills that you've been working on. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. Hello everybody. Today we're going to be creating an automatic file sorter for your files in File Explorer. Now, out of all the projects that we've done in this series so far, I think this one might be the most difficult, but I also think this one is the most cool because it has some real life applications. So without further ado, let's take a look at some files that we have right down here in my File Explorer. So I have this beautiful picture of Rosie right here. This is a PNG file. I have a CSV file and a text file. And I want to sort all of them into their own folders, depending on what kind of file it is. So if I go right in here and I click on this one, I go to properties, I can see that this is a PNG file. If I go into this one, I don't need to, but if I go into this one, it's a CSV file. And of course, this one is a text file. So I want 3 separate folders in here. And I want them to automatically go into those folders without me having to drag and drop and going and clicking. Now, we only have 4 files here, but imagine if we have thousands of files, how much time that could save us. So let's get out of here and let's start writing our code. So we're going to say import OS, comma, and then we're going to say shut IL. Now, OS obviously stands for operating system. Shut IL, I don't know what it's actually supposed to stand for, but what it will allow us to do is do some high level operations on our files in File Explorer. So we're going to go ahead and import those. And now that we have those imported, something that's going to be very important for us to have throughout this whole thing, and this is anytime I'm working with like directories or something like this, we want to get this path down. So I'm going to go ahead and copy this path. And we're just going to say path is equal to, and we'll do this right here. So let's run this. And I need to put an R right here to make this a raw text. So when you don't have the R, it's going to read in these, these backslashes and these colons and different stuff. If we do R, it's just going to read it in as the raw string, and that's what we want. So here's what we need to do. There's a few different things that have to happen when we are writing this out. One thing is we need to go in here and we need to see this path and we need to see, are there folders in here already? If not, we need to create a folder. So that's one of the first things that we need to do. The next thing that we need is it needs to check each of these files individually, identify what kind of file it is, and then put it into the correct folder. So we have to create the folder, then check these, and then place it into the correct folder. So let's go right out of here. So what we're going to start doing is we're going to start working with these paths and these directories. And some of these things you may never have seen before, but that's okay. I'll try to explain it as I go through. So the first thing that we're going to write is os.list directories. And what this is actually going to do is show us all the files in there. We're going to say path. And so it should show us all the files within path. And so here are our results. So we have the data professional results, fake text file, our image, and our other image. So this is actually showing us what files are in that path. And that's super important because we're probably going to have to loop through this in some way later. I wrote this all out before, so I kind of remember, but I'm doing this all off the top of my head. So I guarantee you throughout this, I'll make some mistakes. But what we now need to do is we need to create folders or check if there's a folder and create it if it isn't there. That's the next step that we need to take. So let's go right down here. And we want to check if this path exists already. So if that folder already exists. So we're going to say os.path.exists. So this is going to check, does this path, just like this path up here, does it already exist? And then we're going to do an open parentheses. We'll say path. So that's our path. Now we need to add a folder name to this. We could hard code it. So we could do plus, we could say CSV files. And that could work. So it would say, does this path already exist? And we can try running this. And it's going to say false. So this doesn't already exist. But the thing is we need to create 3 separate paths. So we could do this by just hard coding it in by saying CSV files, image files, and text files. Or we can just put this all in a list and loop through it. I think it's just going to be easier to do that. Or I don't know, visually it's going to be easier. So we'll do folder underscore names, and then we'll say is equal to, and we'll create a list. So I think I want to call it CSV files, comma, image files or PNG files, whatever you want to write. And then we'll do text files, And then we can go right down here, a little for loop. I think what we'll do, well, actually, let's write folder underscore names. Then we can put something like, let's write loop. Why not? So a little trick for the for loop is going to say for, and we'll say loop. And we'll just do a range because we want it to basically go through here. We don't want it to actually give us these file names. We just want it to count 0, 1, and 2. So if we do range from 0 to 2, 0, 1, 2, that should work. If we do this, then when it loops through, it's going to call folder name and say 0, which would be CSV files, image files, and text files. So let's, I need a colon. let's run through this really quickly. Shouldn't do anything. But what we can do now is we can say, okay, if this does not exist, what we can do is actually create it. So we'll say if not, so if this does not exist, then what we're going to do is take this and we'll say os.make directory, and then we'll do just like that. I think it's make directory s. I think that's correct. So let's test this out really quickly. Let's see if this works. And invalid syntax, I need a colon. Okay, so I just ran this. Let's see if it did actually make those folders. Let's refresh it. And it didn't. So let's just print this off. So if not, let's just print. So let's see, does this actually work? Let's do if. Okay. Okay, so I think I know what might be happening. I think it's giving us, it may actually be, let's check this really quick. Go to Python tutorials. Oh, no. I think it's creating, yeah, it's creating these Python tutorial images right here. Whoops. Okay, so I just figured it out. Let's go back into Python tutorials. Don't take a look at any of those notebooks. Those are secret. We were creating them in the wrong place. And that's because of this right here. We need a backslash, so we need to actually include a backslash right here in this path. We didn't have that. EOL, why scanning string literal? Okay, so this backslash could cause an issue. Let's see if I can do forward slashes on all these. Just stick with me, guys. I might cut this out, I might not. We'll see if this is important. Just gonna keep talking while we're doing it. Let's run this. Okay, so now that we're doing these forward slashes, we're still checking. Let's make sure we can still check those files. Good. Now when we loop through this, I'm not going to, well, yeah, I can print it off. Doesn't matter. I'm going to print it and we'll see if that name works. And then we're also going to, well, I said if. So if it exists, then make it. No. So if not, I think the not did make sense. We just weren't sure. We had to do some checking. So if it exists, then we're going to create it. And we'll keep the print in there because it doesn't really matter. So it's going to create the CSV and image, but didn't create the text. Let's see. Okay, let's, I don't know why this would work, but let's run it. Okay, so I think I just had the wrong range. So now we have our images, or we have our folders, all three folders. Now we need to write a script that will read in these and check and see what kind of file it is and place it into the correct folder. So let's come right down here and let's see what we need to do. So now I think we need to use this right here. I think we need to loop through this to be able to check each one. So we need to name this. So we'll just do file underscore name is equal to, run that. So now we have this file name. And what we can do is loop through this. So let's say for file in file name. So we're going to loop through this. Now, when it goes through, it needs to check it's going to check the file path. And in the file path, it'll say .txt, .csv. So let's say if, I think it should be .csv. Let's test it on this one. But if CSV is in file name, or actually it's file. So if it's in file and not in, and not in, but if it's also not in this, I believe, because we're going to check each of those folders. So we're going to loop through and it's going to check and see if the CSV, so if that string is in the file, then what we want to do is check that it's also not in here. That's actually just the folder. We also need, also we're not doing that for loop anymore. Okay, I'm sorry, I'm talking this through. I'm figuring it out as I go because I may have forgotten some of this. So we're going to say that's the CSV files. So we need to check this one. Let's do it like this. Oops. Okay. So it's going to check to see if CSV files, and I think it needs that in between it. So it's going to say the path. So there's our path plus /CSV files. Actually, no, it needs to be like this because we're going to check that. Then I got it. All right, I figured it out now. Then we're going to check if this file is in there. Yeah, so that's right. So it says if the CSV is in the file, which is right, where am I looking? Oh, file name. So if it's in that list of the actual files, which is all of these, if we find CSV in any of these files and it's not already in here, so it's going to say path plus CSV files. Did I say files? Yeah, CSV files plus file. Okay, that all looks correct. So if it's not in there, we're going to use shuttle.move. Now this is how we actually move the file. It gives us the ability to move what we want. Then we'll say move. We need to take it from our initial path to our new path. So we're going to specify, we'll separate by a comma. We need to specify its original path, which it should just be this without this, I think. It should be file path, because this is where it is now. It's in the this path with that file name. Then we need to say, we want to move it to here. That is what we want to do. Yeah, so let's check it with just this one and see if it works. Okay, it ran through it. Let's go check. Aha, now that CSV file is gone. Perfect. That is exactly what we want it to happen. Now we can just recreate this for both our PNG files, our image files, and our text files. So we'll say elif and elif. And let's do PNG. Then we'll do image files and image files, because again, we're just doing the exact same thing. I can do text files. The next one's going to be text files. So this one's going to check for TXT. Now, do we need anything else? We'll just say else, and we'll print this file type is not included. Or if there's multiple files, we'll say there are files in this path that were not moved. Okay, so if we run through this, it's going to catch our CSV, catch our PNG, catch our text, and if not, it'll say there are files in this path that were not moved. Exclamation point. All right, now let's run through this. That's because if elif, and then it's gonna this else statement. I don't know. Let's circle back around to that in a second. All of them were moved properly. That's really good. Really quickly, I'll check and see. I'm gonna take that out for now. So I'm just gonna run it. We may or may not go back to that, but let's check and see if everything works properly. So let's go into the CSV file, and we have our CSV file. Let's go into our image files, and we have our images. And let's go into our text file, and there are our text files. Now, is there anything else that we need to do? I don't believe so, but what I can do is I can take all this, I can include it in here, and I'm going to basically restart it just to see if it works properly from scratch, right? I just want to make sure that I didn't miss anything, and we'll delete these. So we have our, I'm just going to rerun everything. We imported, we created our path. These are our file names. And then when we run this, it should take our folder names, check through them. If they aren't already created, it's going to create it. Don't need it to print, so let's get rid of that. Then for the file within our file names, and it checks each one, we check if there's a CSV, and if it's already in that file, if it's already in that folder, if it's in that folder, then it doesn't do anything. But if it isn't, it's not in there, it is going to move it to that location. So it's going to check CSV, PNG, and text. I think everything should work properly. Let's run this. And it looks like it's working. Good, good, good. And perfect. It worked exactly how I had hoped. That's great. So this is the automatic file sorter in File Explorer project. You can go even a step further. So I had to come in here and manually run this. You can go a step further and put a timer on this where it automatically does this maybe every hour, every day, every 30 minutes. You can run this in your background, especially if you create an execution for this. You can run this in your background. If you are curious on how to do that, I think I did something similar to that in my web scraping project, my Amazon web scraping project, if you want to go check that one out. But we're not going to do it in this project. This is all I wanted to show you how to do. So I hope that this was helpful. I hope that this project was, interesting and that you liked it. And I hope that you learned something. And so if you did, be sure to like and subscribe below, and I will see you in the next video. What's going on, everybody? Welcome back to another video. Today, we're going to be starting our Python web scraping tutorial series. Now, this is more of a continuation of the Python tutorial series, but because we're going to be focusing on web scraping for 3 or 4 videos, I wanted to just make it its own little mini series. In this series, I'm going to show you the basics of web scraping, how to actually look at HTML, how to inspect a web page, how to pull that data in, and then even put it into a CSV file so you can save it and use it. Now in this series, we're just covering the basics, which is a fantastic place to start, but in future series, I'll be going into some of the more advanced web scraping topics as well. So without further ado, let's jump on my screen and get started with web scraping. Now the first thing that we need to learn is HTML. HTML stands for Hypertext Markup Language, and it's used to describe all of the elements on a web page. Now, when we actually go to a website and start pulling data and information, we need to know HTML so we can specify exactly what we want to take off of that website. So that's where HTML comes in, and we're going to look at the basics, understanding just the basic structure of HTML. Then we'll go look at a real website, and you'll kind of see that it's a little bit more difficult than what we just have right here. But this is the basic building blocks to get to what the HTML actually looks like on a website. Now, this is basically what HTML looks like. We have these angle brackets with things like HTML, head, title, body, and then you'll notice that at the end, we'll have a body, and then we'll have a body at the bottom. This / body denotes that this is the end of the body section in HTML. So everything inside of this is within this body. And so there is this hierarchy within HTML. We have HTML and HTML at the bottom, which encapsulates all the HTML on the website. Then we have things like head, body, and body. Now within these sections, we usually have things like classes, tags, attributes, text, and all these other things that we'll get to in different lessons. But one of the easiest ones to notice and look at are tags, things like a p tag or a title tag. Now within these tags, because this is a super simple example, we have these strings here, my first web page, and this is what's called a variable string. And this is actual text that we could take out of this web page. Now that you understand the super basics of HTML, let's actually go to our website, and I'm going to have a link down below, but it's going to be this one right here. This is basically just a website that you can, practice web scraping on. It's called scrapethissite.com. And what we're going to do is look at the HTML behind this web page, and you can do this on any website that you go on. So we're going to right click. We're going to go down to inspect. Now, right off the bat, this looks a lot more complicated and a lot more complex than the very simple illustration that we're looking at. But let's kind of roll this up just a little bit. You'll notice we have HTML and HTML at the bottom. We have a head, and there is the end of the head, and then a body and the end of the body. So in a super simple sense, it is similar, but just the information that's within it is a lot more difficult. Now, if we look at this title right here, this is our title tag. If we click this little arrow, this is our drop down, you'll notice that here we have this string, hockey teams, forms, searching, and pagination. Now, let's say we didn't want to click on that and go find it. There's something that's super helpful within this inspection page that you can click on right here. It says select an element in the page to inspect it. So we're going to click on that. And as we go through our page, and let's click on this title, it's going to take us to exactly where this is in our HTML. This is extremely helpful, extremely useful. For example, let's say the data I want is down here. I want to take in the Boston Bruins. I can click on it. And it's going to take me to where that is exactly in the HTML. This is where we can start writing our web scraping script to specify, okay, I'm looking for a TR tag. I'm looking for a TD tag. I'm looking for the class called team. This is all information and things that we can use to specify exactly what we want to pull out of our web page. Now, there are other things that we didn't really look at as well in just our simple illustration. Let's come right over here. There's things like hrefs. Now, these are hyperlinks. So if we went and then clicked on this, this is just regular text, but inside of it is this hyperlink, where if we clicked on it, it would take us to another website. And typically that's denoted by this href right here. Then you'll typically see things like a p tag, which usually stands for a paragraph. Now, the last thing that I want to show you while we're here, and we're going to learn a lot more in the next several lessons, but if we come right down here, there is this actual entire table here. And let's try to find this table. And I'm having trouble selecting the entire thing, but let's select this team name. And if we look at this team name, you can see that this is encapsulating the table. So this table tag. Now, these are super helpful because it takes in the entire table. Now, if we wrap this up and we look just at this, it says class table, and then we have the end of this table tag. Now, when we open it, it's going to have all of this information. So as you can see, as I'm highlighting over it, we have these TH tags, then we have these TD tags, and even these TR tags, which is the individual data. And this is something that we'll look at when we're actually scraping all of the data from this table in a future lesson. So this is how we can use HTML, how we can inspect the web page and see exactly what's going on kind of under the hood. And then in future lessons, we'll see how we can use this HTML to specify exactly what data we want to pull out. Thank you guys so much for watching. If you like this video, be sure to like and subscribe below. I will see you in the next lesson. Hello everybody, in this lesson, we're going to be taking a look at beautiful soup and requests. Now these packages in Python are really useful. These are the two main ones that I used when I was first starting out with web scraping. It can get a lot of what you want done in order to get that information out. Now, of course, there are other packages that you can use that may be a little bit more advanced, but again, this is just the beginner series. In a future series, we'll look at other packages as well that have some more advanced functionality. So what we're going to be doing is we're going to import these packages, and then we're going to get all of the HTML from our website and make sure that it's in a usable state. And then in the next lesson, we're going to kind of query around in the HTML, kind of pick and choose exactly what we want. We'll look at things like tags, variable strings, classes, attributes, and more. So let's get started by importing our packages. What we're going to say is from BS4, this is the module that we're taking it from. We're going to say import, and then we'll do beautiful soup. Then we're going to come down and we're going to say import requests. Now let's go ahead and run this. I'm going to hit Shift Enter, and it works well for me. Now, if this does not work for you, you may potentially need to actually install BS4. So you may have to go to your terminal window and say pip install BS4. I'll just let you Google how to do that if you need to do that, because it's pretty easy. But if you're using Jupyter Notebooks through Anaconda, like how we set it up at the beginning of this Python series, then you should be totally fine. It should be there for you. The next thing that we need to do is specify where we're taking this HTML from. So what we need to actually do is come right over here to our web page, and we need to get the URL. So we're going to go here, we're going to copy this URL, and I'm just going to put it right here for a second. And what we're going to do is we're going to be using this URL quite a bit. So we just want to assign it to a variable. So we'll just say URL is equal to, and then we'll put it right in here. Now we can get rid of that. So now this is our URL going forward. This is where we're going to be pulling data from. Let's go ahead and run this. Now we're going to use requests, and what we're going to do is we're going to say requests.get, and then we're going to put in URL. Now this get function is going to use the request library. It's going to send a get request to that URL, and it's going to return a response object. Let's go ahead and run this. As you can see here, I got a response of 200. If you got something like a 204 or a 400 or 401 or 404, all of these things are potentially bad. Something like a 204 would mean there was no content in the actual web page. 400 means a bad request. So it was invalid, the server couldn't process it, and you don't get any response. If you got a 404, that might be one that you're familiar with. That's an error that means the server cannot be found. The next thing that we're going to do is take the HTML. Now, if you remember, if we come right back here and we inspect this, we have all of this HTML right here. Now on this web page specifically, right now, it's completely static. It's not a bunch of moving stuff or anything like that. But usually when you're looking at HTML, if you're looking at something like Amazon, and those web pages can update, but when you actually pull that into Python, you're basically getting a snapshot of the HTML at that time. So what we're going to do is bring in all of this HTML, which is our snapshot of our website, and then we can take a look at it. So we're going to come right down here, and now we're going to say beautiful soup. So now we'll use the beautiful soup package or library. So when you say beautiful soup, then we're going to do an open parentheses. We're going to do two things. There's two parameters that we need to put in here. First, we need to put in this get request. We actually need to name this, and we'll call this page. We'll say page is equal to, and let's run this. And now we're going to put that page in here. And what we're going to say is .text. So the page is what's sending that request. And then the .text is what's retrieving the actual raw HTML that we're going to be using. Then we're going to put a comma here. And what we need to specify is how we're going to parse this information. Now, this is an HTML. So what we're going to do is HTML, just like this. This is a standard. This is already built into this library, so we don't need to go any further, but it's basically going to parse the information in an HTML format. Now let's go ahead and run this. Let's see what we get. And as you can see, we have a lot of information. And as we scroll down, I'll try to point out some things that we've already looked at in previous lessons. Something like this TH tag. That should be very similar. That's the title. Then we have these TD tags. And then of course, if we scroll down even further, we'll have things like a TR tag. So these are all things that we looked at in that first lesson when learning about HTML. Now, again, we want to assign this to a variable. So we're going to say soup. That's going to say equal to this information right here. Now, I'm not going to go into all the history behind Beautiful Soup, but what I will say is the guy who created this Beautiful Soup library, what he said was that it takes this really messy HTML or XML, which you can also use it for, and it makes it into this kind of beautiful soup. So I just thought that was kind of funny, but that's why we're calling it soup right here. And we're going to go ahead and run this, and we'll come right down here and we'll say print soup. And let's run it. And now we have everything in here. So we have our HTML, our head, we have some href and some links in here. And let's scroll down a little bit more. And then we have our body right there. And of course, we have a bunch of information in here. Now, in the next lesson, what we're going to be doing is learning how to kind of query all of this to take specific information out and basically understand a lot of what's going on in this HTML to make sure we can actually get what we need. Now, if this looks really kind of messy to you and it just doesn't make a lot of sense, there is one more thing that I'm going to show you. And we'll come right down here. So we'll say soup.prettify. And if you've ever used a different type of programming languages, Prettify is very common in a lot of them, where it'll just make it a little bit more easy to visualize and see. You'll notice that it kind of has this hierarchy built in, whereas if we scroll up, there's no hierarchy built in. It's all just down this left-hand side. So if you kind of want to view it and just kind of visually see the differences, this does help a lot. But it doesn't actually help a lot when you're, querying it or using, find and find all, which is what we're going to look at in the next lesson. So that is our lesson on Beautiful Soup and requests. In the next two lessons, we're going to be looking at find and find all, as well as really diving into things like variable strings and tags and classes and all those things. And then in the last lesson, we're going to do kind of this mini project where we try to get all the data from this web page that we've been using from that table and put it into a pandas data frame. So thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I will see you in the next lesson. Hello, everybody. In this lesson, we're going to be taking a look at find and find all. Really, we're going to be looking at a ton of different things in this lesson. This is where we really start digging in, seeing how we can extract specific information from our web page. But in order to do that, let's set everything up where we actually bring in the HTML like we did in the last lesson. And we're just going to write all this out one more time just for practice, if nothing else. And then we'll get into actually getting that information from the HTML. So we're going to start by saying from VS4 import beautiful soup, there we go, and import requests. We'll go ahead and run this. Then we're going to come up here, grab our HTML, our URLs. We'll say URL is equal to, and we'll have that right here. Now we need to say page is equal to, and then we'll do requests.get, and then we'll put in our URL right here. And we're going to come over here and run this. And lastly, we need to say soup. So we'll say soup is equal to beautiful soup. There we go. And then within our parentheses, we need to specify the page.text because we need that, and our parser, which is HTML. And there we go. And let's go ahead and run this. Let's print it out, make sure it's working. And there we go. So we have our soup right here. All this should look really similar to our last lesson. And so now we've brought in our HTML from our page. So we have a lot of information in here. Now, really quickly, let's come over and let's inspect our web page. Now in here, we have a ton of information, right? We have a bunch of different tags and classes and all these other things, but how do we actually use these? Well, that's where the find and find all is going to come into play, and they're pretty similar, and you'll see that in just a little bit. But let's say we want to take one of these tags, and let's come down. Let's say we just want to take this div tag. Now, there's going to be a lot of different div tags in our HTML, but let's just come right here. Let's go down and let's say, we're going to call soup. We're going to say soup. That's all of our information. We're going to say dot find. Now within our parentheses, we can specify a lot of different things, but we're going to keep it really simple right now. We're just going to say div. Let's go ahead and run this. What this is going to bring up is the very first div tag in our HTML, and that's going to be this information right here. Now let's copy this, and we're going to do the exact same thing, except we're going to say find underscore all. Now let's run this. Now we're going to have a ton more information. Really all find and find all do is that they find the information. Now find is only going to find the first response in our HTML at least. That's the div class container. Let's go back up to the top. That's our div class container, but find all is going to find all of them. So it'll put it in this list for you. So it's going to have this first one, and it goes down to this /div, which should be right here. And then we have a comma, which separates our next div tag. So that is how we can use it. Now, what if we want to specify one of these div tags? We pulled in a ton of them, but we want to just look for one of them. Well, this is something where the class comes in handy, because right now we have class is equal to container, class is equal to colmd-12. I don't know what these are off the top of my head, but usually they'll be somewhat unique, and we can use these to help us specify what we're looking for. For example, just kind of glancing at this, we could also use this a tag if we wanted to look at this. So we could say, oh, we're looking for these hrefs. So we have an href here, and in this right down here, we have this href as well, which again, if you remember from a previous lesson, that stands for a hyperlink. Now, something like the class or the href or these IDs, these are all attributes. So we can specify or kind of filter down based off of these. Now let's try it. So what we can do is we can do class first, and this is kind of the default within something like find all, is you can even do class underscore. We can come right back up. We have this div, and then here's our class. So again, we have to have the div and the class. If we took this a tag, this is an a tag, which would go right here with the class of something like navlink or something like navlink again down here. We need to specify that more. But we have our div, so we'll say colmd12 right here. And let's go ahead and run this. And now it's going to pull in just that information. Now we're still getting a list because we have multiple of these. So this div class colmd-12 doesn't just happen once. If we scroll down, we'll see it multiple times, something like right here. Or actually, let me see right here. So here's this comma, then here's our next one. So we have two of these div tags with a class of col-md-12. And in each of these, we have different information. This looks like a paragraph with this p tag right here. And let's scroll back up. So I also think we should try out doing something like this p tag. Typically, these p tags stand for paragraphs or they have text information in them. Let's try to p tag really quickly and let's just see what we get. And let's run this. And it looks like we get multiple p tags. Now, if we come back here, you can see that there's this information and it's this information that we're pulling in. And I'm just noticing that from right here. And then we have this information right here. And it looks like there's one more, which is this href, which looks like this open source. So data via, and then that hyperlink or that link right there. So we have 3 different p tags. Now, just to verify and make sure that that's correct, what we could do is come over here. We're going to click on this paragraph. And it's going to take us to that p tag where the class is equal to lead. Let's come over here and look at this paragraph. Now we have another p tag right over here where the class is equal to glyphicon/education. I have no idea what that means. And then we'll go to our last one, which is right here, where the p tag is equal to, we have a tag, href, class, and a bunch of other information. So let's say we just wanted to pull in this paragraph right here. Let's go here and see how we can specify this information. So it looks like p, where the class is equal to lead, that looks like it's going to be unique to just that one. So if we come down here, we're going to say comma, and it was class. So you can do class underscore is equal to, and then we're going to say lead. Let's try running this. And we're just pulling in that information. Now let's say we actually want to pull in this paragraph. We actually want this text right here. And this is a very real use case. You know, let's say I'm trying to pull in some information or a paragraph of text. Well, let's copy this. And what we're going to then do is say dot text. And let's run this. Now we're going to get an error right here. And this is a very common error because we're trying to use find all. Unfortunately, find all does not have a text attribute. We actually need to change this to find. Typically, when I'm working with these find and find alls, I'm using find all most of the time until I want to start extracting text. Then when I specify it, I'll change this back to find just like this. Now let's try this. And now we're getting in parentheses this information. Now, this is all wonky. It needs to definitely be cleaned up a little bit. But if we go back up, it's no longer in a list. And we no longer have things like these p tags in here or this class attribute. So we're really just trying to pull out this information. Now, again, this does not look perfect. We could even try to do something like dot strip. Look like there's some white space. That cleans it up a little bit. This definitely looks a little better. And we could definitely go in here and clean this up more. But just for, an example, this is how we can then extract that information. Now let's look at one more example. This is some information, and this is what we're going to do kind of our little mini project in the next lesson on. Let's say we wanted to take all this information. Well, what if we wanted to pull in something like the team name? Well, that's going to be in right here in this TR tag. And each of these TR tags have TH tags underneath them. So if we scroll down, you'll notice that each row is this TR tag. So let's go ahead and search for, let's do TH. Let's just search for that first. So let's come right back up here. Let's use this find all. And we'll get rid of this text for right now. And let's just say we want to look for the TR. Is that what we said we were looking for? No, TH. So let's say we're looking for TH. Let's go ahead and run this. So we're going to have underneath this TH, we have team name, year, wins, losses. And notice these are all the titles. So these titles are the only ones with these TH tags. If we go down, you'll notice that the data is actually TD tags. So now let's go back and look for TD. We'll say D, and this is going to be a lot longer. We have a lot of information, but these are all the rows of data. Let's see if we can just get one piece of this data. We're going to get back. We want just this team name. That's all we're trying to pull in for now. And then we'll try to get this row. And then in the next lesson, we're going to try to get all of this information, make it look really nice, and then we'll put it into a pandas data frame. So let's just get this team name right now. Let's go ahead. We're going to say TH. Let's run this. And we have this TH. And now that we know we're getting this information in, we can do find. Let's run this. So there's our team name. I'm just going to say dot text. And again, we can do dot strip just like that. And bam, we have our team name. So you can kind of start getting the idea of how we're pulling this information out. We're really just specifying exactly what we're seeing in this HTML. And what's really, really helpful, and it's something that I do all the time, is I'm inspecting it. I'm just kind of searching like, what do I want? What piece of information do I want? Then I go ahead and click on it. And then I'm looking, where is this sitting in the hierarchy? It's within the body. It's within this table with the class of table. Then it's down here where this TR tag and then this TD tag. So I'm looking kind of at the hierarchy and I'm specifying exactly what I'm looking for. So that is what we're going to look at in today's lesson. That's how we can use find and find all. We were able to look at classes and tags and attributes and variable strings, which is this right here, getting that text, and variable strings. And we will look at find and find all and how it's pulling that information in and how we can specify exactly what we're looking for. Now in the next lesson, which is definitely going to be the most exciting one, we're going to try to pull in all of this information. So every single thing, because we'll be able to put all this information into a data frame, which then we can use pandas to really search and manipulate that data within that data frame. So with that being said, that is the end of this lesson. If you like this video, be sure to like and subscribe. I will see you in the next lesson. Hello everybody, in this lesson, we are going to be scraping data from a real website and putting it into a pandas data frame and maybe even exporting it to CSV if we're feeling a bit spicy. Now, in the last several lessons, we've been looking at this page right here. And I even promised that we were going to be pulling this data, but as I was building out the project, I honestly thought it was a little bit too easy since in the last lesson, we kind of already pulled out some information from this table and I want to kind of throw you guys off. So we're going to be pulling from a different table. We're going to be going onto Wikipedia and looking at the list of the largest companies in the United States by revenue. And we're going to be pulling all of this information. So if you thought this was going to be easy and a little mini project, it's now a full project because why not? So let's get started. What we're going to do is we're going to import Beautiful Soup and requests. We're going to get this information and we're going to see how we can do this. And it's going to get a little bit more complicated, a little bit more tricky. We're going to have to, format things properly to get it into our pandas data frame to make it looking good and making it more usable. So let's go ahead and get rid of this easy table. We don't want that one. And we're going to come in here and we're just going to start off. This should look really familiar by now. We're going to say from BS4 import Beautiful Soup. I don't know if you've noticed, but I've messed up spelling Beautiful Soup in every single video. I've noticed. Let's run this. And now we need to go ahead and get our URL. So let's come up here. Let's get our URL. Let's say URL is equal to, and we'll just keep it all in the same thing really quickly because we know this by heart by now, right? We'll say request.get and then URL to make sure that we're getting that information. It'd give us a response object. Hopefully it'll be 200. That'll mean a good response. And then we'll say soup is equal to, and then we'll say beautiful soup, and we'll do our page.text. Now we're pulling in the information from this URL. And then we use our parser, which will be, HTML. And let's go ahead and run this. Looks like everything went well. Let's print our soup. Now this is completely new to you. It's completely new to me. I don't know what I'm doing, but it looks like we're pulling in the information. Am I right? So we got a lot of things going for us. The stuff was imported properly. We got our URL. We got our soup, which is not beautiful in my opinion, but let's keep on rolling. Let's come right down here. Now what we need to do is we need to specify what data we're looking for. So let's come and let's inspect this web page. Now, the only information that we're going to want is right in here. We're going to want these titles or these headers. Whoops. So we're going to want rank, name, industry, etc. And then we are for sure going to want all of this information. Let's just scroll down, see if there's anything tricky in here. All right, that looks pretty good. And then there is another table. So there's not just one table in here. There are two tables in this page. So that might change things for us, but let's come right back and let's inspect our page by using this little button right here. And let's specify let's see if I can highlight just this page. Oh, it's not gonna, let's do that right there. So now we have this wiki table sorter. Now I'm going to actually come right here. I'm going to copy, and I'm just going to say copy the outer HTML. I'm just going to paste it in here real quick. And that's a ton of information. I didn't think it was going to copy all of it. And we're just going to delete that. I just wanted to keep that class because I wanted to then come right down here at the bottom and just see what this table looks like. I don't know if it's part of it or if it's its own table. I can't tell. Let's look at this rank and let's come up. So it says it's under this table. And it looks like it's its own table, but it says wiki table sortable jQuery table sorter. Wikipedia sortable jQuery table sorter. So it looks like there are two tables with the same class, which shouldn't be a problem if we're using find to get our text, because we should be taking the first one, which will be this table. And this is the table we want. And if we wanted this one, we could just use find all, and since it's a list, we could use indexing to pull this table, right? But I think we're going to be okay with just pulling in this one. So let's go ahead and let's do our find. So we'll do soup.find, and we could find all, or we could just do find table. Let's just try this and see what we get. And if it pulls in the right one that we're looking for, that'd be great. Now this does not look correct at all. I don't know what table it's pulling in. Oh, maybe it's this right here. This might be a table. Yeah, it is. So we have this box more citations. So actually we are going to have to do exactly like what I was talking about. Let's pull this, and we could do comma class right here, and let's do both. You know what? This is a learning opportunity. Let's do both. So let me go back up to the top because I need these. And what we're going to do is come right down here. I want to add in another thing. Actually, I'll just push this one up. There we go. So we're going to say find underscore all. Let's run this. So now we have multiple. And again, we got that weird one first, but if we scroll down, here's our comma. And then here's our wiki table sortable. And then we have rank, name, industry, all the ones that we were hoping to see. And I guarantee you, if we scroll all the way to the bottom, we're going to see potentially Wells Fargo, Goldman Sachs. I'm pretty sure those are, let's see. Yeah, here we go. Like Ford Motor, Wells Fargo, Goldman Sachs. That's this table right here. So now we're looking at the third table. But again, this is a list. So we can use indexing on this. And we'll just choose not position 0, because that's this one right here, which we did not like. Well, now we'll take position 1. Let's run this. Let's go back up to the top. And this is our table right here. Rank, name, industry. This is the information that we were actually wanting. Just to confirm, rank, name, industry, etc. So this is the information we're wanting, and we're able to specify that with our find all. And this is the information we want. So we now want to make this the only information that we're looking at. So I'm just going to copy this. We didn't need to use our class for this one. You probably could have, but we could. So let's actually put this right down here. This will be our table. We'll say equal to, but then I'll come right here and I'm going to say soup.find. And this is just for demonstration purposes. We'll do table, comma, class underscore is equal to, and then we'll look at this right here. Whoops, let me do this. And let's see if we get the correct output. And let's run this. And it looks like we're getting a none type object. If I remember, it looks like the actual class is this right here. So let's run this instead. And I got to get rid of the index. There we go. Okay, so we were able to pull it in just using the find. So the find table class, and it says wiki table sortable. At least that's the HTML that we're pulling in right here. Let me go back because I don't know if that's what I was seeing earlier. Let's just get this rank. Let's go back up. Oh, where's the rank? There we go, rank. There we go. So here's our rank. And let's go up to the table. And there's our class. Yeah, and that's just, to me, that's a little bit odd. So it says wiki table sortable jQuery dash table sorter right here. But in our actual Python script that we're running, it was only pulling in the wiki table sortable. So it wasn't pulling in the jQuery table sorter. Why? I'm not 100% sure, but all things that we're working through and we were able to figure out. So we're going to make this our table. We're going to say tables equal to soup.findAll. And let's run this. And if we print out our table, we have this table. Now this is our only data that we are looking at. Now the first thing that I want to get is I want to get these titles or these headers right here. That's what we're going to get first. So let's go in here. We can just look in this information. You can see that these are with these TH tags, and we can pull out those TH tags really easily. Let's come right down here. We're just going to say TH, and we can get rid of this. And let's run this. Now these are our only TH tags because everything else is a TR tag for these rows of data. So these TH tags are pretty unique, which makes it really easy, which is really great because then we can just do world underscore titles is equal to. Now we have these titles, but they're not perfect. But what we're going to do is we're going to loop through it. So I'm going to say world underscore titles, and I'll kind of walk through what I'm talking about. This is in a list, and each one is within these TH tags. So TH, and then there's our string that we're trying to get. So we can easily take this list and use list comprehension, and we can do that right down here. So I'm going to keep this where we can see it. We'll do world underscore table underscore titles. That's equal to, now we'll do our list comprehension. It should be super easy. We'll just say for title in world underscore titles. And then what do we want? We want title dot text. That's it. Because we're just taking the text from each of these. We're just looping through and we're getting rank. Then we're looping through, getting name, looping through, getting industry. That's it. So let's go and print our world table titles and see if it worked. And it did. This looks like it needs to be cleaned up just a little bit. So let's go ahead and do that while we're here before we actually put it into the pandas data frame. Oops, I just wanted this actually. So what we're going to do is try to get rid of those \ns. If we do dot strip, that may actually not work. Yeah, because this is a list. What we need to do is we can actually do it dot text dot strip right here. Let's try to do it in there. There we go. So now we have this, and now this world tables is good to go. Now I'm actually noticing one thing that may be odd. Yeah, so we have rank name industry, it goes to headquarters, but then in here we're getting rank name industry and then the profits, which is from this table right here, which we don't want. Let's scroll back up. Now let's kind of backtrack this and see where this happened. We did find all table. We're looking at the first one, right? And then we're doing headquarters. So we're doing print table. Okay. I think I found the issue here. And let's backtrack again. We're working through this together. We're going to make mistakes. The table is what we actually wanted to do. We just did soup.findAllTH, which is going to pull in that secondary table. Geez, we were not thinking here. So now we need to do find all on the table, not the soup, because now we were looking at all of them. Oh, what a rookie mistake. Okay, let's go back. Now let's look at this. Now it's just down to headquarters. Okay, let's go ahead and run this. Let's run this. Now we just have headquarters. Now let's run this. Now we are sitting pretty. Okay, excuse my mistakes. Hey, listen, if it happens to me, it happens to you. I promise you. This is a project. This is a little project we're creating here. So we're gonna run into issues, and that's okay. We're figuring it out as we go. Now, what I want to do before we start pulling in all the data is I want to put this into our pandas data frame. We'll have the headers there for us to go, so we won't have to get that later. And it just makes it easier in general, trust me. So we're going to import pandas as PD. Let's go ahead and run this. And now we're going to create our data frame. So we'll say PD dot. Now we have these world table titles. So what we're going to do is PD dot data frame. And then in here for our columns, we'll say that's equal to the world table titles. And let's just go ahead and say that's our data frame and call our data frame right here. Let's run it. There we go. So we were able to pull out and extract those headers and those titles of these columns. We're able to put it into our data frame. So we're set up and we're ready to go. We're rocking and rolling. The next thing we need, let's go back up. Next thing we need is to start pulling in this data right here. So we have to see how we can pull this data in. Now, if you remember that we had those TH tags, those were our titles. As you can see, I'm highlighting over it. But down here, now we have these TD tags, and those are all encapsulated within a TR tag. So these TR represent the rows, right? Then the D represents the data within those rows. So R for rows, D for data. So let's see how we can use that in order to get the information that we want. So let's go back up here. Just going to take this because again, we're only pulling from table, not soup, not soup. What were we thinking? And let's go ahead and let's look at TR. Let's run this. Now, when we're doing this TR, these do come in with the headers. So we're going to have to later on, we're going to have to get rid of these. We don't want to pull those in and have that as part of our data. But if we scroll down, there's our Walmart. We have the location. These are all with these TD tags. And then, of course, it's separated by a comma. Then we have our TD2. So above, we had our TD1. So row 1, row 2, row 3, all the way down. Now, we will easily be able to use this, right? Because this is our column data. And we can even call it that. Column underscore data is equal to, well, we'll run that. And what we're going to do is we're going to loop through that because it was all in a list. So we're going to loop through that information, but instead of looking at the TR tag, we're going to look at the TD tag. So let's come right down here. We'll say for the row in column row, and we'll do a colon. Now we need to loop through this. We'll do something like row.find underscore all. And then what are we looking for? We're not looking for the TR, we're looking for the TD. And just for now, let's print this off, see what this looks like. Apparently I didn't run this. Column data, that's why. And let's run this. And what we actually need to do is something almost exactly like this. And I'm going to put it right below it. Instead of printing this off, because again, this is all in a list, we're using find all. So we're printing off another list, which isn't actually super helpful. For each of all these data that we're pulling in, what we can do is we can call this the row underscore data. And then we'll put the row data in here. So we'll say for, and we'll say in row data. So we'll just say for the data in row data. And then we'll take the data, we'll exchange that. And now instead of world table titles, we can change this into individual row data, right? And now let's print off the individual row data. So it's the exact same process that we were doing up here. And that's how we cleaned it up and got this. And we may not need to strip, but let's just run this and see what we get. There we go. In strip, I'm sure was helpful. Let's actually get rid of this. Yeah, strip was helpful. It's the exact same thing that happened on the last one. So let's keep that actually. Let's run this. And now let's just kind of glance at this information. Let's look through it. This looks exactly like the information that's in the table. Let's just confirm with this first one. 572 754 2.4 2300 572 2.4 2300. So this looks exactly correct. Now we have to figure out a way to get this into our table because again, these are all individual lists. It's not like we're just, putting all of this in at one time. We can't just take the entire table and plop it into the data frame. We need a way to kind of put this in one at a time. Now, if you're just here for web scraping and you haven't taken like my Panda series, that's totally fine. That's not what we're here for anyways. But what we can do, we'll have our individual row data and we're going to put it in kind of one at a time. Now, the reason we have to do that is because when we had it like this, and let's go back, when we had it like this, it's printing out all of it. But what it's really doing, and let's get rid of it. What it's really doing is it's kind of doing it like this. It's printing it off one at a time, and it's only going to save that current row of data, this last one, it's only going to save that as it's looping through. So what we actually want to do is every time it loops through, we append this information onto the data frame. So as it goes through, and eventually it's going to end up with this one, but as it goes through, let's run this. As it goes through, it puts this one in. And then the next time it loops through, it puts this one in. And the next time it loops through, et cetera, all the way down. So let's see how we can do this. So we have our data frame right here. Let's get rid of this. Let's bring our data frame in. Now, again, like I just mentioned, if you don't know pandas and you haven't learned that, go take my series on that. It's really good. And we do something very similar to this in that series. So I'm not going to kind of walk through the entire logic, but there is something called LOC, which stands for location when you're looking at the index on a data frame. And we're going to use that to our advantage. So we're going to say the length of the data frame. So we're looking at how many rows are in this data frame. And then we're going to say that's our length. Then we're going to take that length and use it when we're actually putting in this new information. Pretty cool. So we're going to say df.loc and then a bracket, and we're putting in that length. So we're checking the length of our data frame each time it's looping through. And then we're going to put the information in the next position. That's exactly what we're doing. Let's go ahead and put in the individual row data. So let's just recap. We're looping through this TR. This is our column data. So these TR, that's our row of data. Then as we're looping through it, we're doing find all and looking for TD tags. That's our individual data. So that's our row data. Then we're taking that data, each piece of data, and we're getting out the text and we're stripping it to kind of clean it. And now it's in a list for each individual row. Then we're looking at our current data frame, which has nothing in it right now. We're looking at the length of it, and we're appending each row of this information into the next position. So let's go ahead and run this. It's working, it's thinking, and it looks like we got an issue. And not set a row with mismatched columns. Now we're encountering an issue, not one that I got earlier, but we're gonna cancel this out. We're gonna figure this out together. So let's print off our individual row data. Let's look at this. This one is empty. This is, I'm almost certain, is probably the issue. I didn't encounter this issue when I wrote these, when I wrote this lesson, but I'm almost certain that this is the issue right here. So let's do the column data, but let's start at position. Let's try 1 and not parentheses. I need brackets because this is a list, right? So it should work. And there we go. So now that first one's gone. So now we just have the information. I didn't even think about that just a second ago, but I'm glad we're running into it in case you ran into that issue. Let's go ahead and try this again. And it looked like it worked. So let's pull our data frame down. I could have just wrote DF. Let's pull our data frame down. And now this is looking fantastic. Now, these 3 dots just mean there's information in there, just doesn't want to display it. But it looks like we have our rank, we have our name, we have the industry, revenue growth, employees, and headquarters for every single one. So this is perfect. Now, this is exactly what I was hoping to get. Now you can go in and use pandas and manipulate this and change it and dive into all the information in there. But we can also export this into a CSV if that's what you're wanting. So we could easily do that by saying, we'll do df.to_CSV. And then within here, we're just going to do R and specify our file path. So let's come down here to our file path. Then we'll go to our folder for our output. So we're just going to take this path and let me do it like that. So I have this path in my OneDrive documents, Python web scraping folder for output. So, I already made this. And I'm just going to put this right down here. Now I do have to specify what we're going to call this. We'll just call this companies. And then we have to say .csv. That is very important. Now, if we run this, I already know just because we have this rank and this index here, we're going to keep this index in the output. Not great, but let's run it. Let's look at our output. There's our companies. And when we pull this up, as you can see, this is not what we want because we have this extra thing right here. Now, if we're automating this, this would get super annoying. So what we're going to do is go back and just say index equals false. Let's go out of here. And now we're just going to come right down here. We're going to say comma index equals false. And so it's going to take this index and it's not going to import or actually export it into the CSV. Now let's go ahead and run this. Let's pull up our folder one more time. And let's refresh just to make sure. Should be good. And now this looks a lot better. So we were able to take all of that information and put it into a CSV and it's all there. So this is the whole project. So if we scroll all the way back up, let's just kind of glance at what we did here. Scroll down. We brought in our libraries and packages. We specified our URL. We brought in our soup. And then we tried to find our table. Now that took a little bit of testing out, but we knew that the table was the second one. So in position 1, so we took that table. We were also able to specify it using find, but then we used the class. And of course, we just wanted to work with that table. That's all the data we wanted. So we specified this is our table and we worked with just our table going forward. Of course, we encountered some small issues, user errors on my end, but we were able to get our world titles and we put those into our data frame right here using pandas. Then next, we went back and we got all the row data and the individual data from those rows, and we put it into our pandas data frame. Then we came below and we exported this into an actual CSV file. So that is how we can use web scraping to get data from something like a table and put it into a pandas data frame. I hope that this lesson was helpful. I know we encountered some issues. That's on my end and I apologize, but if you run into the same issues, hopefully that helped. But I hope this was helpful. And if you like this, be sure to like and subscribe below. I appreciate you. I love you. And I will see you in the next lesson. So the first thing that we need to do is import our pandas library. So we're going to say import and we're going to say pandas. Now this will import the pandas library, but it's pretty commonplace to give it an alias. And as a standard when using pandas, people will say as PD. So this is just a quick alias that you can use. That's what I always use and I've always used it because that's how I learned it. And I want to teach it to you the right way. So that's how we're going to do it in this video. So let's hit Shift Enter. Now that that is imported, we can start reading in our files. Now, right down here, I'm going to open up my File Explorer, and we have several different types of files in here. We have CSV files, text files, JSON files, and an Excel worksheet, which is a little bit different than a CSV. So we're going to import all of those. I'm going to show you how to import it, as well as some of the different things that you need to be aware of when you're importing. So we're going to import some of those different file types, and I'll show you how to do that within pandas. So the first thing that we need to say is PD dot, and let's read it in a CSV because that's a pretty common one. We'll say read underscore CSV. And this is literally all you have to write in order to call that in. Now, it's not going to call it in as a string like it would in one of our previous videos if you're just using the regular operating system of Python. When you're using pandas, it calls it in as a data frame, and I'll talk about some of the nuances of that. So let's go down to our File Explorer. We have this countries of the world CSV. You just need to click on it and right click and copy as path. And that's literally going to copy that file path for us. So you don't have to type it out manually. You can if you'd like. And we're just going to paste it in between these parentheses. Now, if we run it right now, it will not work. I'll do that for you. It's saying we have this Unicode error. Basically what's happening is it's reading in these backslashes and this colon and all those backslashes in there and this period at the end. What we need to do is read this in as a raw text. So we're just going to say R, and now it's going to read this as a literal string or a literal value and not as, with all these backslashes, which does make a big difference. When we run this, it's going to populate our very first data frame. So let's go ahead and run it. And now we have this CSV in here with our country and our region. Now, if we go and pull up this file, and let's do that really quickly, let's bring up this countries of the world. It automatically populated those headers for us in the data frame, but we don't have any column for those 0, 1, 2, 3. So if we go back, as you can see right here, there's this index, and that's really important in a data frame. It's really what makes a data frame, and we use index a lot in pandas. We're able to filter on the index, search on the index, and a lot of other things, which I'll show you in future videos. But this is basically how you read in a file. Now, if we go right up here in between these parentheses and we hit Shift Tab, this is going to come up for us. Let's hit this plus button. And what this is these are all of the arguments or all the things that we can specify when we're reading in a file. And there are a lot of different options. So let's go ahead and take a look really quickly. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. The first thing is obviously the file path. We can specify a separator, which there is no default. So when we're pulling in the CSV, when we're reading in the CSV, it's automatically going to assume it's a comma because it's a comma separated file. You can choose delimiters, headers, names, index columns, and a lot of other things, as you can see right here. Now, I will say that I don't use almost any of these. The few that I'm going to show you really quickly in just a second are up the very top. But you can do a ton of different things, and I'm just gonna slowly go through them. So that's what those are. You can also go down here. This is our docstring, and you can see exactly how these parameters work. It'll show you and give you a text and walk you through how to do this. Again, most of these you'll probably never use, but things like a separator could actually be useful, and things like a header could be useful because it is possible that you want to either rename your headers or you don't have a header in your CSV and you don't want it to auto-populate that header. So that is something that you can specify. So for example, this header one, and I'll show you how to do this, the default behavior is to infer that there are column names. If no names are passed, this behavior is identical to header equals 0. So it's saying that first row or that first index, which is like right here, that 0 is going to be read in as a header. But we can come right over here and we'll do comma, header is equal to, and we could say none. And as you can see, there are no headers now. Instead, it's another index. So we have indexes on both the x-axis and the y-axis. And so right now we have the 0 and 1 index indicating the first column and the second column. If we want to specify those names, we can say the header equals none. Then we can say names is equal to, and we'll give it a list. And so the first one was country. And what's that second one? Oh, region. So they're right here. That's the first row, but we'll rename it and we'll just say country and region. And when we run that, we've now populated the country and the region. We're just pretending that our CSV does not have these values in it and we have to name it ourselves. That's how you do it. But let's get rid of all that because we actually do want those in there. So we're just going to get rid of those and read it in as normal. And there we go. Now, typically when you're reading in a file, what you need to do is you want to assign that to a variable. Almost always when you see any tutorial or anybody online, or even when you're actually working, people will say df is equal to. df stands for data frame. Again, this is a data frame. In the next video in this series, I'm going to walk through what a series is, as well as what a data frame is, because that's pretty important to know when you're working with these data frames. But we'll assign it to this value. And then we'll call it by saying df and we'll run it. And that's typically how you'll do things because you want to save this data frame. So later on you can do things like data frame dot, and you can pass in different modules, but you can't really do that. It's not as easy to do it if you're calling this entire CSV and importing it every time. So let's copy this because now we're going to import a different type of file. So now we've been doing read CSV, but we can also import text files. Now you can do that with the read CSV. We can import text files. Let's look at this one. We have the same one. It's countries of the world, except now it's a text file because I just converted it for this video. I'll copy that as a path. And so now when we do this, oops, let me get those quotes in there. It'll say world.txt. It will still work. As you can see, this did not import properly. We have this country \t region. And then all of our values are the exact same with this \t. That's because we need to use a separator. And I'll show you in just a little bit how we can do this in a different way. But with that read CSV, this is how we can do it. We'll just say SEP is equal to, we need to do \t. Now let's try running this. And as you can see, it now has it broken out into country and region. We could also do it the more proper way, and this is the way you should do it. And I'll get rid of these really quickly, but just want to keep them there in case you want to see that. But you can also do read underscore table. And let's get rid of this separator. And now we have no separator. It's just reading it in as a table. Let's run this. And it reads it in properly the first time. This read table can be used for tons of different data types, but typically I've been using it for like text files. We can also read in that CSV. So let's change this right here to CSV. We can read it in as a CSV, but just like we did in the last one, when we read in the text file using read CSV, this read table, you're going to need to specify the separator. So I'll just copy this and we'll say comma, and now it reads it in properly. Again, you can use that for a ton of different file types, but you just need to specify a few more things if you don't want to use the more specific read underscore function when you're using pandas. Now let's copy this again. We're going to go right down here. And now let's do JSON files. JSON files usually hold semi-structured data, which is definitely different than very structured data like a CSV where it has columns and rows. So let's go to our File Explorer. We have this JSON sample. We will copy this in as the path. Let's paste it right here. And we'll do read underscore JSON. Again, these different functions were built out specifically for these file types. That's why, each one has a different name. So now we're reading this in as the JSON. Let's read it in, and it read it in properly. Now let's go ahead and copy this and take a look at Excel files, because Excel files are a little bit different than other ones that we've looked at. So let's just do read underscore Excel. And let's go down to our File Explorer, and let's actually open up this workbook. As you can see, we have sheet 1 right here, but we also have this world population, which has a lot more data. Let's say we just wanted to read in sheet 1. We can do that, or by default, it's going to read in this world population because it's the first sheet in the Excel file. Well, let's go ahead and take a look at that. Let's get out of here. And let's say, oops, I forgot to copy the file path. Let's go ahead and copy as path, and we'll put it right here. And let's just read it in with no arguments or anything in there, or no parameters. When we read it in, it's reading in that very first sheet. So this is the one that has all of the data. Now let's say we wanted to read in that extra sheet name or the second sheet name. We'll just go comma, sheet underscore name, say is equal to, and then we can specify sheet. Was it sheet 1 like this? Yes, it was. So we just had to specify the sheet name right here. And then it brought in that sheet instead of the default, which is the very first sheet in that Excel. Now that definitely covers a lot of how you read in those files. Again, you can come in here and hit Shift Tab and this plus sign and take a look at all the documentation. And you can specify a lot of different things that I didn't think were very important for you guys to know, especially if you're just starting out. The ones that we looked at today are what I would say are like the ones that I use almost all the time. So I wanted to show you those. But if you're interested in any of these other ones or you have very unique data and you need to do that, it's worth really getting in here and figuring things out. A few other things that I wanted to show you just in this kind of first video or this intro video on how to read in files. One thing that you may have noticed, especially in this file right here, is we're only looking at the first 5 and then the last 5. So if we wanted to see all the data is in these like little 3 dots right here, right? We want to be able to see that data, but right now we can't. And that's because of some settings that are already within Pandas. And all we need to do is change that. So this one has 234 rows and 4 columns. So obviously we can see all the columns. Well, let's just change the rows. All we'll say is pd.set underscore option. Now, what we need to do is we're going to change the rows. We're not going to change the columns, at least not on this one. So we'll say, quote, display.max.rows. Now, if we just run this, for whatever data we bring in, it's going to be able to show the max rows. And then we'll say 235, although there's 234 rows, I'm just going to be safe. Let's run this. And now it has changed it. So let's read in this file again, and you'll see how it's changed. Now we have all of the numbers, and we have this little bar on the right that allows us to go down all the way to the bottom and all the way to the top. So now we can actually look and kind of skim and see our values. I like that better than just having that, shorter version. We can do the exact same thing on columns as well. So if we look at this one, this is our JSON file. It has the same thing right here. We have, what was it, 38 columns, but we can only see, I think maybe it's 20 or something like that. I can't remember. But we have 38. We can only see like, let's say 15 of them or 20 of them. We'll do the exact same thing. And we'll just say pd.setOptions.max.columns. And we'll set that to 40 for that one. When we run this, oops, let's get over here. When we run this one again, we can now scroll over and see every single one of our columns. Now that one is in my opinion, a lot more useful. I like being able to see every single column. So definitely something that you should be using, especially when you have these really large files. You want to be able to see a lot of the data and a lot of the columns. So when you're slicing and dicing and doing all the things that we're about to learn in this Pandas series, you know what you're looking at. I also want to show you just how to kind of look at your data in these data frames as well. So that's also pretty important. So let's go right down here. And the very last one that we imported was this one right here, this read Excel. So this data frame is the only one that's going to read in. Let's run it. This is the last one to be run. So this variable right here, df, it won't be applied to all these other ones, which we can always go back and change those. Typically, you'll do something like data frame 2. You want to do something like that. So let's keep data frame 2. Oops. So what we're going to do is we're going to bring data frame 2 right down here. And we want to take a look at some of this data. We want to know a little bit more about it. Something that you can do is data frame 2.info, and we'll do an open parentheses. And when we run this, it's going to give us a really quick breakdown of a little bit of our data. So we have our columns right here, rank, CCA3, country, and capital. It's saying we have 234 values in those columns. Because there's 234, scroll up here, because there's 234 rows, that tells me that there's no missing data in here, at least not, completely missing like null values. There is something in each of those rows. The count tells me it's non-null, so there's no null values, and it tells me the data type. So it's reading in as an integer, an object, and an object. And it also tells us how much memory it's using, which is also pretty neat because when you get really, really large data types, memory usage and knowing how to work around that stuff does become more important than when you're working at these really small, sample sizes that we're looking at. We can also do, oops, let me get rid of that. We can also do data frame 2. And we'll do shape. And for this one, we do not need the parentheses. And all this is going to tell us is we have 234 rows and 4 columns. We're also able to look at the first few values or rows in each of these data frames. So we can just say data frame 2.head. And if we do that, it's going to give us the first 5 values, but we can specify how many we want. We can say head 10. It'll give us the first 10 rows right here. We can do the exact same thing. And let's go right down here and we'll say tail. So they'll give us the last 10 rows within our data frame. Now let's copy this. And let's say we don't want to actually look at all of these values or all these columns. We can specify that by saying df2 and oops, let's get rid of all of this. And we'll say with a quote, we'll say rank. And now we can take just a look at the rank data. Now we can't do that by doing the index, or at least not like this. If we want to use this index that is right here, we can, but there's a very special function called loc and iloc for that. And I'm going to have an entire video on this because it does get a little bit more complex. But there's df2.loc and there's loc and iloc, stands for location and ilocation. That's only for the indexes, whether it's the x-axis or the y-axis, those are the indexes. And for location, it's looking for the actual text, the actual string of the index. So if we come up here, that data frame 2, we can specify 224, and it'll give us this information right here in a little different format. So let's go bracket, and we'll say 224. And when we run this, it gives us our rank, CCA, country, capital with our values over here, kind of like a dictionary almost. Now let's copy this, and we'll say df2.iloc. And right now these look the exact same, but we haven't really talked a lot about changing the index, and you can change the index to a string or a different column or something like that. And we'll look at that in future videos. The iloc looks at the integer location. So even if these let's go right up here. Even if this index had changed to, let's say, this rank or the CCA3 or country or whatever you make this index, the iLoc will still look at the integer location. So that 224 would still be 224, even if it was Uzbekistan. So then when we look at this, it's going to be the exact same. But if we had changed that index, this LOC is the one that we could search on, and we could search Uzbekistan. Is that how you spell Uzbekistan? Hey, I nailed it. So that is how you use loc and iLoc. Again, I just wanted to show you a little bit about how you can look at your data frame or search within your data frame. Now in future videos, I'm going to dive a lot deeper into a lot of the concepts that we just looked at, because I just kind of touched on them. I wanted you to have a brief introduction to them so that in future videos, I'm not just dropping everything on you all at once. So hopefully this was a good quick introduction to those topics. You should be able to read in a file now, see your data frame, and kind of look at it in a few different ways that we just looked at. And I hope that that was helpful. And if it was, be sure to check out all my other videos on Python and pandas. And if you like this video, be sure to like and subscribe below, and I'll see you in the next video. Hello everybody. Today we're going to be looking at filtering and ordering data frames in pandas. There are a lot of different ways you can filter and order your data in pandas, and I'm going to try to show you all of the main ways that you can do that. So let's kick it off by importing our data set. So we're going to say data frame is equal to, and we'll say pandas, and I need to import my pandas. So we'll say import pandas as PD. That's pretty important, I think. So pd.read_CSV, and we'll do R, and then we'll say the world population CSV. So let's run this. Call our data frame right here. And this is the data frame that we're going to be filtering through and ordering in pandas. So let's kick it off. The first thing that we can do is filter based off of the columns. So the data within our columns. So Asia, Europe, Africa, or whatever data we may have in that column. Let's go right down here. We're going to say df. And then within it, we're going to specify what column we're going to be filtering on. So we're going to say df with another bracket, and we'll say rank. So we're going to be looking at this rank column right here. And then we'll say in that rank column, we want to do greater than 10. And that's actually going to be a lot of them. Let's do less than. So when we run this, it's only going to return these values that are less than 10. We can also do less than or equal to, all of these comparison operators. So less than or equal to. So now we have all of the ranks 1 through 10. Now, if we look at these countries, we can specify by specific values, almost exactly like we did here. But instead of doing a comparison operator like we did right here and including those names, let's say Bangladesh and Brazil, we can use the is_in function, almost like an in function in SQL if you know SQL. So let's go right down here, and we're going to say specific underscore countries. So right now we're just going to make a list of the countries that we want. And then we'll say Bangladesh and Brazil. So let's go right down here. Then we'll say, okay, for these specific countries from the data frame, let's do our bracket. We'll say in this country column, so we'll do data frame and then another bracket for country. So in this country column, we can do .is_in and then an open parentheses, and then look for our specific countries. So we're looking at just this column and we're saying is_in. So we're looking at, are these values within this column? And we're getting this error, and this looks very, very odd. Let me, this doesn't look right. There we go. I just had some syntax errors. I apologize. Made it way more complicated than it needs to be, but here's how you use this is_in function. So we're looking at Bangladesh and Brazil, and we return those rows with Bangladesh and Brazil. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. We can also do a contains function, kind of similar to is_in, except it's more like the like in SQL as well. I'm comparing a lot of this to SQL because when you're filtering things, my brain always goes to SQL.
But in pandas, it's called the contains. So let's actually copy this because I don't want to make the same mistake again. Let's do that, and we'll do the bracket. But instead of dot is in, we're going to do dot string dot contains, and then an open parentheses. So we're going to be looking for a string. If it contains, let's do united, almost like United States or any other United. So let's run this. And as you can see, we have United Arab Emirates, United Kingdom, United States, Virgin Islands. So we can kind of search for a specific string or a number or a value within our data or within that column of country. Now, so far, we've only been looking at how you can filter on these columns. We can also filter based off of the index as well. And there's two different ways you can do it, or two of the main ways. There's filter, and then there's loc and iloc. Loc stands for location, and iloc stands for integer location. And if you've seen other previous videos, I've kind of mentioned those, so we can take a quick look at all of those. So really quickly, we need to set an index because the index right now is not the best. We'll set our index to country. So let's say df2 is equal to df.set underscore index, and we'll say country. Now I'm just doing df2 because later on I want to use that data frame again. So I'm just going to assign it to another data frame so that we can just easily switch back and forth. So now we have this index as the country, and what we can do is use the filter function. So let's go down here. We'll say df2.filter, and we'll do an open parentheses. And now we can specify our items. So these are actually going to be specifying which columns we want to keep. So we're going to say items is equal to, then we'll make a list. We'll say continent. Hope that's how we spell continent. I'm always messing up with my my stuff here, my spelling. Then we'll do CCA3 because why not? You can specify whichever ones you want. When we run this, it's going to only bring in those two columns. Now by default, it's choosing the axis for us, but we can also specify which axis we want to search on. So if we say axis is equal to 0, it's actually going to search this axis. This is the 0 axis. This is the 1 axis. So where our columns are is 1. So if we go back and do 1, we're searching on that 1 axis or those header axes again. And this is the default, but you can specify that. So if you just want to search on, filtering right here, you can do that. And let's actually copy this and do that right down here just so you can see what it looks like. But let's search for Zimbabwe, and we'll do Zimbabwe, and we'll be looking at the 0 axis, which is the up and down on the left-hand side. And when we filter on that, we can filter by Zimbabwe by looking just at the country index. We can also use the like, just like we did before. And I'll show you the exact same demonstration that we did, which you can say like is equal to, and instead of having to put in a concrete text, you can just say united, just like we did before. And we're searching where the axis is equal to 0, which again is this left-handed axis. So now we're looking for united, and it's going to give us all of the countries or all the indexed values that have united in it. Like we were talking about before, we also have loc and iloc. So we can say dataframe2.loc. Now this is a specific value. So we'll do United States. So location is just looking at the actual name or the value of it, not its position. So if we search for United States, it's going to give us this right here, where it gives us all of the columns for United States and then all of the values for United States. Or we can do the iloc, which is the integer location, which is not the exact same because we're looking at the string for the loc. We're looking at this string, but underneath it, there still is a position. That's that integer location. Let's do a completely random one. Let's just say 3. If we look at the third position, it's going to give us ASM, which I'm not exactly sure what it is, but it still gives us basically the same kind of output, which is the columns and the values. So that's another way that you can search within your index when you're actually trying to filter down that data. Now let's go look at the order by. And let's start with the very first one that we looked at. Let's do data frame. That's why I kept it, because I wanted to use it later. Now we can sort and order these values instead of it just being kind of a jumbled mess in here. We can sort these columns however we would like, ascending, descending, multiple columns, single columns, and let's look at how to do that. So we'll say data frame, and then we'll do data frame, look at rank again, just like we were doing above. And let's do data frame where it's less than 10. I should have just gone and copied this. I apologize. So now we have this data frame that is greater than 10. Now we can do dot sort underscore values. And this is the function that's going to allow us to sort everything that we want to sort. So we can do by is equal to, and we'll just order it by the exact same thing that we were doing or calling it on. So we'll do rank. So now what this is going to do, it's going to order our rank column. And as you can see, it did that 1, 2, 3, 4, 5. We can also do it with ascending or descending. So if you want to, you can look in here and see what you can do. So we'll do ascending. We'll say that's equal to true. And so that's the automatic default. So that didn't change anything. But if we say false, it's going to be descending from highest to lowest. So now we have it in the opposite direction. Now we don't have to just order or sort this on one single column. We can do multiple columns. And we can do that by making a list right here. Whoops. Make a list just like that. And we'll input different ones as well. So now let's input our country. And when we run this, it will give us rank of 9876, as well as the country of Russia, Bangladesh, Brazil. Now, if you noticed, the country really didn't change because the rank stayed the exact same. That's because there's an order of importance here, and it starts with the very first one. If we change this around and we look at this one, and put a comma right here, now the country is going to be descended and the rank would come second. So it's not going, the rank isn't going to really have any effect here. So now we have the country, United States, Russia, Pakistan, and the rank really didn't get ordered at all. Now, if we want to see how that can actually work, let's do continent right here and actually put it right here and do country here. So if we run this, it's first going to come and it's going to organize or sort the continent. Then it's going to come back and go to the country, and then it's going to sort the country. So keep your eye right here in this Asia area, because we're going to sort this differently than ascending. So we have ascending false, and that applies to both of these. It's false and false, but we can specify which one we want to do. We can do a false here and a true here. So we'll do false, comma, true. And what this is going to do is it's going to say false for the continent. So the continent right here is going to stay the exact same. And so that is a lot of how you can filter and order your data within Pandas. I hope that this was helpful. I hope that you enjoyed this video. If you liked it, be sure to like and subscribe below. Check out all my other videos on Python and Pandas, and I will see you in the next video. Hello everybody. Today we're going to be looking at indexing in Pandas. If you remember from previous videos, the index is an object that stores the access labels for all Pandas objects. The index in a data frame is extremely useful because it's customizable, and you can also search and filter based off of that index. In this video, we're going to talk all about indexing, how you can change the index and customize that, as well as how you can search and filter on that index. And then we're also going to be looking at something a little bit more advanced called multi-indexing. And you won't always use it, but it's really good to know in case you come across a data frame that has that in it. So let's get started by importing pandas. Import pandas as PD. Now we'll get our first data frame. We'll say df is equal to pd.read_csv. And I've already copied this, but we're going to do r, and we're going to put this file path. So I have this world population CSV. I will have that in the description, just like I do in all of my other videos. Let's run df, and let's take a look at this data frame. So we have a lot of information here. We have rank, country, continent, population, as well as the default index from 0 all the way up to 233. Now, if you haven't watched any of my previous videos on pandas, the index is pretty important, and it's basically just a number or a label for each row. It doesn't even necessarily have to be a unique number. You can create or add an index yourself if you want to, and it doesn't have to be unique, but it really should be unique, especially if you want to use it appropriately. For what we're doing, the country is actually going to be a pretty great index because the country is going to be all unique because we're looking at every single row as a different country as well as the population. So let's go ahead and create this country or add this country as our index. Now we can do this in a lot of different ways, but the first way that you can do this, if you already know what you are going to create that index on, is we can just go right in here when we're reading in this file and we'll say comma index underscore, oops, I spelled that completely wrong, index underscore column, and we'll say that is equal to, and then we're going to say quote country. So we're taking this country and we're going to assign it as the index. Now let's read this in. And as you can see, this is our index. Now it looks a little bit different. We didn't have this country header right here, which is specifying that this is still the country, but you can tell that this is the index based off the bold letters, as well as it being on the far left, and all the regular columns for the data is over here, while the country header is right here, and it's lower than all the others. Just a quick way that you can see that that is the index. Now, before we move on, I want to show you some other ways that you can do this as well, but I'm going to show you how to reverse this index before we move on, and we'll say data frame. So we had our data frame right here. So we have data frame dot, and we'll say reset underscore index. And then we'll say in place is equal to true, which means we don't have to assign this to another variable and all that stuff. It'll just be true. So now when we run that data frame again, the index was reset to the default numbers. So now let's go down here and I'll show you how to do this in a different way. You can do df dot, we'll say set underscore index, and then we'll just say country. So very similar to when we were reading in that file and we said set the index or that index column, we said index column equals country. If we do this and we run it in, it works. But if we say data frame right down here, it's not going to save that. If we want to save it, just like we did above, we're going to say in place is equal to true. That is going to save it to where we don't have to assign it another variable. So now when we run this, the data frame right here, which is going to populate this, the data frame is going to say in place is equal to true. So that country will now be our index again. Let's run this. And there we go. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. Now, what's really great about this index is we're able to search based off just this index. And so we can filter on it and basically look through our data with it. And there are two different ways that you can do that. At least this is a very common way that people who use Pandas will do to kind of search through that index. The first one is called lock, and there's lock and iLock, and that stands for location or integer location. Let's look at lock first. Let's say df.lock, and then we'll do a bracket. Now we're able to specify the actual string, the label. So let's go right up here and let's say Albania. So we'll say Albania. So again, this is just looking at the location. Let's run this. Now it's going to bring up all the Albania data, just like here, where it kind of looks like a column in a column. And we can get this exact same data, but using iLock right here. And when we ran lock, we were searching based off Albania, which is in the 0, 1 position. So if we actually pull the 1 position for that integer, the iLock, we can look at the 1 position, and this should give us the exact same data. Now let's take a look at multi-indexing, and we'll come back to a little bit of this in a second. So multi-indexing is creating multiple indexes. We're not just going to create the country as the index. Now we're going to add an additional index on top of that. So let's pull up our data frame. Right now we have the country, but let's do dot reset index, and we'll say in place equals true. Oops. Let's run it. So now we have our data frame. Now let's set our index, but this time when we set our index, we're going to add the country as the index, as well as the continent as an index. So we'll say data frame dot set underscore index. Then we'll do a parentheses. And instead of just doing country like we did before, we're going to create a list. Oops. And we'll do it like that. And then we'll say continent, and separate it by a comma. So we have continent and country. Let's just say in place is equal to true. Now, when we run this, we're going to have two indexes. Let's see what this looks like. And let's run this. So now we have country as well as continent as our index. Now you may notice that these indexes are repeating themselves on this continent index. We have Europe right here and Europe right here, as well as Asia and Asia. And it looks a little bit funky, but we are able to sort these values and make it look a lot better. So let's go ahead and try this. We'll do df.sort_index. And when we run this, it should sort our index alphabetically. And we can also look in here and see what kind of things we can, specify. We can specify the axis, but it's automatically going to be looking at the 0. This is 0 and this is 1. So we have two axes within our data frame. You can choose the level, whether it's ascending or not ascending, in place, kind, string, sort remaining, all of these different things. The only one that I really, think is worth looking at is the ascending. We already know some of these other ones. But if we look at ascending, let's run it. Now it's sorted these. And so now it's kind of grouped together. So we have Africa and all the African ones, as well as South America and all the South American ones. Let's really quickly say pd.set_option, and we'll say display.max.columns. And just like this, let's run it. And I need to specify right here. Let's see how many rows we have. 235. So let's do 235. Let's run this. And now when we run this, you can see that Africa is all grouped together and all the countries are in alphabetical order under it. And then we go all the way down to Asia. And again, just all in alphabetical order. If we wanted to, we could say ascending equals true. And then when we run this, I meant to say false. And then when we run this, it's the exact opposite. So it starts with South America, the last one, and then goes in reverse alphabetical order. We could also say false, make it a list and do comma true. And just like this. And then it would sort this first column as false and this next column as true. So you can really customize it, but for what we're doing, we don't need any of that. We just need to be able to see this right here. So now when we try to search by our index like we did before, we did dataframe.loc. Now when we did that and we said, let's say Angola, when we specified Angola, it's not going to work properly because it's searching in this first index for the first string that we have. We can search Africa. And let's search for Africa. And now we have all of the African countries. And if we want to specify to Angola, we can also go down another level, by doing Angola. And now we have what we were looking at before, where we're calling all of the data within those, but we couldn't do it just based off Africa because we had an additional index right here. So once we called both indexes, now we get this view. But let's look at that iloc really quick. When we run this, let's just say 1, because right up here, we have Angola 0 and then 1. So you think it may pull up Angola. Let's go ahead and run this. And it's still pulling up Albania. Let's go right up here. If you remember, when we didn't have the multiple indexes, it was pulling up Albania. The difference when you're doing these multi-indexes is that the loc is able to specify this, whereas this one does not go based off that multi-indexing. It's going to go based off the initial index or the integer-based index. So that's a lot about indexing in pandas. We'll cover even a few more things in future videos as we get more and more into pandas. But this is a lot of what indexing looks like within pandas. And again, super important to learn how to do and know how to do because it's a pretty important building block as we go through this pandas series. So I hope you enjoyed this video on indexing. If you did, be sure to like and subscribe below, and I will see you in the next video. Hello everybody. Today we're going to be taking a look at the group by function and aggregating within pandas. Group by is going to group together the values in a column and display them all on the same row. And this allows you to perform aggregate functions on those groupings. So let's start reading in our data and take a look. So we're going to do import pandas as PD. And then we're going to say our data frame is equal to, and we'll say pd.read_CSV. We'll do an open parentheses, R, and our file path. And we're going to be looking at the flavors CSV right here. So right here, we have our flavor of ice cream. We have our base flavor, whether it was vanilla or chocolate, whether I liked it or not, the flavor rating, texture rating, and its overall or its total rating. Now, these are all my own personal scores. So, I've spent years researching this. So these are all very accurate, but this should be a low stress environment to learn group by and the aggregate functions. So the first thing that we can do is look at our group by. Now you can't group by, well, you can group by flavor, but as you can see, these are all unique values. What we need is something that has duplicate values or similar values on different rows that I'll group together. So this base flavor is actually a perfect one to group it on. And we'll do that by saying df.group by, do an open parentheses, and we'll just specify base flavor. And this will then group together those values. And I need to make sure I can spell properly. This will group those flavors together. So let's run this. And as you can see, it actually is its own object. So it has a group by, data frame group by object. So now that we've grouped them, let's give it a variable. So we'll say group underscore by underscore frame. Let's say that's equal to, let's copy this. We'll run it. And now what we need to do is run our aggregations in order to get an output. So we're going to say dot mean, and that's all we're going to put just for now, just to get an output that we can take a look off, and then we'll build from there. So let's go ahead and run this. And right here, we have our base flavor, which is now saying is the index of chocolate or vanilla. And then it's taking the mean or the average of all the columns that have integers. Notice that it did not take the liked column and it did not take the flavor column because those are strings and they cannot aggregate those. And we'll take a look at that later. But it took all the values that have integers and then it gave us the average of those ratings. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. So right off the bat, as averages, with chocolate, I have a much higher rating overall than the ones with vanilla bases. Now we can actually combine all of this together into one line, and we can do something like this. So we'll say df.groupby, and we'll say dot mean, just like this. And this will actually run it. Before, we didn't have any aggregating function on there, so it didn't run. But now that we combine it all into one, it will run properly. Now there are a lot of different aggregate functions, but I'm going to show you some of the most popular ones and the most common ones that you will see. So let's copy this right here. So we can do dot count. And when we run this, we can look at the count. And this will show us the actual count of the rows that were aggregated. So for chocolate, we had 3. So there's going to be 3 all the way across. And for vanilla, we had 6. So we're looking at a higher count of vanilla, which if you're comparing it to this mean up here, that could be a big skew towards the chocolate, because if you have 1 or 2 good chocolates, it could really pull the numbers up. Whereas if you had 2 good vanillas, but all the other ones were bad, it pulls that average down. So knowing the count of something is really good. Let's take a look at the next one. And we can do min and max, and I'll just run these really quickly. We can do min. And when we run this, the first thing that you should notice is that it now has a flavor and a liked column. And that's because min and max will actually look at the first letter in this string, or the first set of letters if there are, chocolate something. It'll look at the first and then it'll actually populate it. So chocolate with the CH chocolate is the very first or the minimum value for that string. And for cake batter, that is the minimum value in vanilla as well. Now with the liked, it's interesting because apparently I liked all the chocolate ones. I'm gonna go take a look. So chocolate, I liked, chocolate, I liked, chocolate, I liked. So there is no option in this liked column. So yes was the only option. And now let's look at max. Whoops. and it should do the exact opposite, which is going to take the highest value, even if it's a string. So Rocky Road, the letter R comes later in the alphabet. So that's what it's looking at. And so does vanilla. And then we have yes as well. And then of course, right here, it's taking the max value. So before when we were looking at min, I just focused on those, but it still does the exact same thing to these integer columns as well. So for the max value for vanilla, it was mint chocolate chip. That was our base. So I had a rating of 10 for this vanilla row or grouping. And then we can also look at the sum. And there are all the sums for these. And again, it only does integer because we can't add the strings. But here are the sum or the total values for all of them. And for the total values, since we had 6 rows that we're grouping into this vanilla, we now have a lot or a much higher score for vanilla. Now that's a really simple way to do your aggregations, but there is actually an aggregation function. And let's take a look at this because this is a little bit more complex, although when I write it out or show you, hopefully it makes a lot of sense. We can do .agg. So this is our aggregate function. And what we need to pass into our aggregate function is actually a dictionary. So let's do an open parentheses, and we're going to do a squiggly bracket. And then we need to specify what we're going to be aggregating on, or what column. So let's do this flavor rating. Let's copy this. We'll do flavor rating, and I need to put that as a string. And then we'll do a colon. And now we can specify what aggregate functions we want. So we've done sum, count, mean, min and max, all of those. And we can actually put all of those into here and perform all of those aggregations on just one column. So let's make a list. And then let's say mean, max, count, and what's another one? Sum. So let's do all 4 of those only on this flavor rating column. And when we run this, we have our base flavor right here, chocolate and vanilla. But now we don't have multiple columns. We have one column with multiple columns of our aggregations. And it is possible to pass in multiple columns like that. So we'll do texture rating. And we'll just come right here and do a comma. Then we'll say texture rating. And then a colon. I don't know why I spelled it out when I copied it, but I did. And then we'll do the exact same ones. And now when we run it, we're getting the exact same columns, mean, max, count, and sum for flavor rating, then mean, max, count, and sum for our texture rating. Now, so far, we've only grouped on one column, but we can actually group on multiple columns. Let's go back up here to our data. And I should have just copied this down here. Let's go back down and just look at this. So really, we only grouped it on this base flavor. But you can do multiple groupings or group by multiple columns. So let's do our base flavor, which we did already, as well as the liked column. So we're going to say df.group by, then we'll do an open parentheses. And then instead of just passing through one string, we're going to do a list, and we'll say base flavor, comma, and then we'll do liked. So now when it groups this, it should put 2 groupings, and let's run this and just see. I gotta say, let's just do .mean. So now we have our chocolate and a vanilla. And remember, chocolate only had yes, so that's the only one that it's gonna group on, but vanilla had a no and a yes. So if we look at the vanilla, we have our base flavor vanilla, and then within liked, we have no and a yes, which can show us that within our vanilla, when we group on these, our no's were really low, but our yeses were really high. We actually had a pretty similar rating or very close to the same rating as the ones we really liked in chocolate. And just like we did above, we can take this .ag, and I'm going to copy this, and it'll perform it on each of those rows. Let me close that. And what did I do wrong? Oh, I need the squiggly bracket. And it'll show us each of those, so the mean, max, count, and sum for all of the chocolate and vanilla, as well as the groupings of liked, yes, and no. Now, after we've looked at all that, and that's how I usually do it, there is one shortcut function that can give you some of these things just really quickly. And so let's go back up here and take this. It's just called describe. And if you've ever done it, it's just going to give you some high level overview of some of those different aggregations. So let's run this. and it's going to give us our chocolate and vanilla. And within each column, it's going to give us our count, our mean, our standard deviation, I believe is what that is, our minimum, 25%, 50, 75, and 100, which is our max, then our count and our mean. So a lot of those aggregate functions, but the describe is, a very generalized function. We can't get as specific as we were with the previous ones that we were looking at. But I just wanted to throw this out there in case this is something that you'd be interested in, because it, technically is showing a lot of those aggregate functions just, all at one time. So that is our group by and aggregate functions within pandas. I hope that was helpful. I hope that you understood, everything that we were working on. If you like this video, be sure to like and subscribe and check out all my other videos on Python as well as pandas. And I will see you in the next video. Hello everybody. Today we're going to be talking about merging, joining, and concatenating data frames in pandas. This whole video is basically around being able to combine two separate data frames together into one data frame. These are really important to understand when we're actually using the merge and the join. Right here we have what's called an inner join, and the shaded part is what's going to be returned. It's only the things that are in both the left and the right data frames. Then we have an outer join or a full outer join. And this will take all the data from the left data frame and the right data frame and everything that is similar. So basically it just takes everything. We also have a left join, which is going to take everything from the left. And then if there's anything that's similar, it'll also include that. And then the exact opposite of that is the right join, which is going to give us everything from the right data frame. And it's going to give us everything that is similar, but it's not going to give us anything that is just unique to the left data frame. So this is just for reference, because in a little bit, when we start merging these become very important. So I just wanted to kind of show you how that works visually. So let's get started by pulling in our files. So first we're going to say import pandas as PD. We'll run this, and then we'll say data frame 1, and we'll also have a data frame 2. And these are the different data frames, the left and the right data frame, that we'll be using to join, merge, and concatenate. So we'll say data frame 1 is equal to pd.csv_read, and we'll do R. And here is our file path. So we have this lotr.csv, that's our Lord of the Rings CSV. And let's call that really quickly so we can see what's in there. And I'm having a dyslexic moment because it's supposed to be read_CSV. I apologize for that, but this is our data frame. This is our data frame 1. We have 3 columns. It's their fellowship ID, 1001, 2, 3, and 4. Their first name, Frodo, Samwise, Gandalf, and Pippin, and their skills, hiding, gardening, spells, and fireworks. So this is our very first data frame that we're going to be working with. Let's go down a little bit. Let's pull this down here, and we're just going to say data frame 2, and this is the Lord of the Rings 2. So let's pull this one in now. As you can see, it's very similar. We have fellowship ID, 1, 2, 6, 7, 8. So we have 3 different IDs here. We don't have 6, 7, and 8 in this first data frame. We also have the first name. So Frodo and Sam, or Samwise, are in the very first and the second data frame. But now we have 3 new people, Boromir, Elrond, and Legolas. And now we have this age column, which again is unique to just this second data frame.
Really quickly, I want to give a huge shout out to the sponsor of this video, and that is Zendesk. I've been using Zendesk for my company's customer analytics, and it has been absolutely phenomenal. They're going to be hosting a conference called Zendesk Relate on May 10th, and they're going to talk all about customer analytics, chatbots, and AI in this space. You can attend in person in San Francisco, or you can attend virtually, but space is limited, so be sure to apply if you want to attend. So if you are a business leader and you want to make the most out of your customer data, or you want to learn customer data analytics, I will leave links in the description. Again, huge shout out to Zendesk for sponsoring this video.
Now, the first one that I want to look at is merge. And I want to look at merge first because I think this one is the most important. I use this one more than any of the ones that we're going to talk about today. The merge is just like the joins that we were just looking at, the outer, the inner, the left, and the right. And there's also one called cross, and I'll show you that one, although if I'm being honest, I don't really use that one that much, but it's worth showing just in case you come into a scenario where you do want to do that. So let's go right down here, and I want to be able to see these while we do it. So we're going to say data frame 1, and when we specify data frame 1 as the very first data frame, we say data frame.merge, this is automatically going to be our left data frame. Then if we do our parentheses right here, and we say data frame 2, this is our right data frame. And let's see what happens when we do this. So what it's going to do, and this, we didn't specify this, it's just a default, it's going to do an inner join. So it's only going to give us an output where specific values or the keys are the same. Now you can't see this, but what is happening is it's taking this fellowship ID and saying, I have 1001 here, a 1002 here. This is the exact same as up here with this fellowship ID and fellowship ID of 1001 and 2. But when we look at 1003 and 4, those aren't in this right data frame, and 6, 7, 8 is not in this left data frame. So the only ones that match are this 1001 and 2, and that's why they get pulled in down here. But because we didn't explicitly say, here's what I want to join or merge between these two data frames, it actually is looking at the fellowship ID and the first name. So it's taking in these unique values of Frodo and Samwise, which are the same in both, which is why it pulled it over. But really quickly, let's just check and make sure that we did it on the inner join, because again, we didn't specify anything, that was just the default. So we're gonna say how is equal to, and then we'll say inner. And if we run this, it's gonna be the exact same, because again, the inner is the default. But now just to show you how it's kind of joining these two data frames together, I'm gonna say on is equal to, and then I'm only gonna put fellowship ID. So let's run this. Now, the first thing that you may have noticed is this first name underscore X and this first name underscore Y. What the merge does as kind of a default is when you are only joining on a fellowship ID, we have this right data frame with fellowship ID, the left data frame with the fellowship ID. If you're just joining on these and you're not joining on the first name and the first name, then it's going to separate those into an underscore X and an underscore Y. And even though they have the exact same values, since we are not merging on that column, it automatically separates that into two separate columns so we can see the values within each of those columns. If we went into this on and we make a list, and let's do it like that, and we say comma, and then we write first name, first name, and then we run this, it's going to look exactly like it did before. Again, it automatically pulled in both of these columns when it was merging it the first time, even though we didn't write anything. But if we actually write this, it's doing exactly what it was doing when we just had df2. We're just now writing it out. Now, there are other arguments that we can pass into this merge function. Let's hit Shift Tab, and let's scroll down here. So within this merge function, we have a lot of different arguments that you can pass into it. First, we have this right, which is the right data frame, which is this data frame 2. Then we have the how and the on, which we've already shown how to do. There's a left on, left index, right index. Not something you'll probably use that much, but you definitely can if you want to look into that. And there's all these doc strings which show you exactly how to use all of these. So if you're interested in looking at the left and the right and the left index, it's all in here. But one that is really good is the sort, and you can sort it saying either it's false or true. Then we have these suffixes. Now, if you remember, when we took these out, what it automatically did was it put in these underscore X and underscore Y. You can customize that, and you can put in whatever you'd like. Instead of the underscore X and underscore Y, you can put in some custom string for that. We also have an indicator and a validate. Again, all things that you can go in here and look at. I'm just going to show you the stuff that I use the most. So these things right here are things that I definitely use the most. So now that we've looked at the inner join, let's copy this right down here. And let's look at the outer join. And these get a little bit more tricky. I think the inner join is probably the easiest one to understand. Let's look at the outer. It's spelled O-U-T-E-R. I don't know why I always want to say O-U-T-T-E-R. But let's run this and see what we get. So now this looks quite different. The inner join only gave us the values that are the exact same. This one is going to give us all of the values regardless of if they are the same. So we have 1, 2, 3, 4, 6, 7, and 8. So let's scroll back up here. So we have 1, 2, 3, 4, 1, 2, and 6, 7, and 8. So we don't have a 1005. And then if you notice in this data frame right here, if the value doesn't have, so if we can't join on the fellowship ID or the first name, like Legolas wasn't one that we joined on, or that has a similar value in the left data frame, it just gives us an NaN, which is not a number. And it's going to do that for any value where it couldn't find that join or it couldn't match something within that either ID or first name. So in age, we also have that for the ones that weren't in the right data frame. We only had 1001 and 1002. So we'll have the age for both Frodo and Sam. But for Gandalf and Pippin, we don't have their corresponding IDs. And so it's just going to be blank for Gandalf and Pippin. And you can see that right here. So again, outer joins are kind of the opposite of inner joins. They're going to return everything from both. If there is overlapping data, it won't be duplicated. Now let's go on to the left join. And I'm going to pull this down right here. And now we're just going to say how is equal to left. And let's run this. So what this is going to do is it's going to take everything from the left table or the left data frame right here. So everything from data frame 1. Then if there is any overlap, it'll also pull the overlapped or the, whatever we're able to merge on from data frame 2. So let's go back up to our data frame 1 and 2. So it's going to pull everything from this left data frame because we're specifying we're doing a left join. So everything from the left data frame will be in there. We're also going to try to bring in everything from the right, but only if it matches or is able to merge. So just this information right here will come over. We weren't able to join on 1006, 1007, or 1008. So really none of that information is going to come over. So let's go down and check on this. So again, we have 1, 2, 3, 4, all of the data with this first name and skills, everything is in here. But then we are trying to bring over the age, but we only have matches with 1001 and 1002. So only these two values will come in. Let's look at the right join because it's basically the exact opposite. Let's look at the right. And this is basically the exact opposite of the left in the fact that now we're only looking at the right hand. And then if there's something that matches in data frame 1, then we will pull that in. So this is basically just looking like data frame 2, except we're pulling in that skills column. And since only 1001 and 1002 are the same, that's why the skills values are here. Now, those are the main types of merges that I will use when I'm using a data frame or when I'm trying to merge a data frame. But there also is one called a cross or a cross join. And let's look at this one. And this one is quite a bit different. Here we go. Let's run this. So this one is different in that it takes each value from the left data frame and compares it to each value in the right data frame. So for Frodo in this left data frame, it looks at the Frodo in the right data frame, Samwise in the right data frame, Legolas, Elrond, and Boromir all in the right data frame. Then it goes to the next value, Samwise, and does the exact same thing. Frodo, Samwise, Legolas, Elrond, Boromir. And it does that for every single value. So let's go right back up here. So it's taking this 1001, and it's comparing it to 1, 2, 3, 4, 5. Then it's taking Samwise, and it's comparing it to 1, 2, 3, 4, 5. Gandalf, 1, 2, 3, 4, 5, Pippin, and then you kind of see that pattern. And that's what a cross join is. There are very few, in my opinion, reasons for a cross join. Although if you ever do like an interview where you're being interviewed on Python, you will sometimes be asked on cross joins. But there aren't a lot of instances in actual work where you really use or need a cross join. Now let's take a look at joins. And joins are pretty similar to the merge function, and it can do a lot of the same thing, except in my opinion, the join function isn't as easily understood as the merge function. It's a little bit more complicated, but let's take a look and see how we can join together these data frames using the join function. So let's go right up here. We're going to say data frame 1 dot join, and then we'll do data frame 2. Very similar to how we did it before. And let's try running this. And it's not going to work. When we did the merge function, it had a lot of defaults for us. Let's go down and see what this error is. It says the columns overlap, but no suffix was specified. So it's telling us that it's trying to use the fellowship ID and the first name, just like the join did, except it's not able to distinguish which is which. And so we need to go in there and kind of help it out a little bit. Again, a little bit more hands-on than the merge, but let's see what we can do to make this work. Let's do comma, and we'll say on, and let's open this up and kind of see what we have. So this one has less options than the merge does. We have other, and that's our other data frame. We can do on, and we're going to specify what column do we want to join on? And then we can look at how do we want it to be a left, an inner, and outer, the same kind of types of joins as the merge. Then we have that left suffix, right suffix. And that's right here is kind of part of the issue that we were just facing, is that those columns are the same. But if we say left suffix, it'll give us an underscore, whatever we want to specify, any string. 4 columns that are both in the left and the right, we can give it a unique name, so we'll no longer have that issue. And then we can also sort it like we did on the other one. But anyways, let's go back to our on. We'll say on is equal to, and then we'll say fellowship ID. Let's try running this. And we're still getting an error. It's just not as simple as the merge. So let's keep going. So now let's specify the type. So we'll say how is equal to, and we'll do an outer. And if we run this, it still doesn't work. We're still getting the exact same issue as the left suffix and the right suffix. So now let's finally resolve it. I just wanted to show you how a little bit more frustrating it was. But now let's say L suffix is equal to, and now it automatically, when we did the merge, did an underscore X, but we can do, let's do underscore left, and then we can do a comma. We'll do right suffix, and we'll say is equal to, and we'll do underscore right. Now, when we run this, it should work properly. Let's run this. So this is our output, and obviously it looks quite a bit different. Over here, we have this fellowship ID, but then we also have fellowship ID left, first name left, fellowship ID right, and first name right. So it just doesn't look right. Now, something I didn't specify when I first started this, because I kind of wanted to show you, is that the join usually is better for when you're working with indexes. Before, when we were using the merge, we were using the column names, and that worked really well and is pretty easy to do. But as you can see right here, when we're trying to use these column names, it's not working exceptionally well. Let's go ahead and create our index, and then I can show you how this actually works and how it works a little bit better when we're working with just the index. Although you can get it to work just the same as the merge, it's just a lot more work. So let's go right down here, and let's go and say df4, so we'll create a new data frame. We'll say df1 dot set underscore index, and we'll do an open parentheses, and we'll say we want to do this index on the fellowship ID, and then we're going to do the join. So now we're going to say join, so we're setting an index, so we're setting that index on the fellowship ID. Now we're going to join it on df2 dot set underscore index, and then we're also going to do that on the fellowship ID, and I'll just copy this. Oh, geez. I hate it when I do that. Okay. Now we also want to do and specify the left and the right index. So I'll just copy this because we do need to specify this. Now let's try running the data frame 4. So really quickly, just to recap, we were setting the indexes. We were doing the same thing above, right? We have this join. We were joining data frame 1 with data frame 2. Now we're joining data frame 1 with data frame 2, except in both instances, we're setting the index as fellowship ID. So we're joining now on that index. So now let's run this. And this should look a lot more similar to the merge than the join that we did above, except now the fellowship ID right here is actually an index. So it's just a little bit different, but we can still go in here and do how is equal to outer. Oops, let's say outer. So we can still specify our different types of joins, or the different way that we can merge or join these data frames together. We can still specify that. Again, it's just a little bit different. And that's why for most instances, I'm using that merge function, because it's just a little bit more seamless, a little bit more intuitive. The join function can still get the job done, but as you can see, it takes a little bit more work. Now let's look at concatenate. Concatenating data frames can be really useful, and the distinction between a merge and join versus the concatenate is that the concatenate is kind of like putting one data frame on top of the other, rather than putting one data frame next to one another, which is like the merge and the join. So concatenating them is just a little bit different in how it'll operate. But let's actually write this out and see how this looks. Let's go up here and we'll say pd.concat. We'll do an open parentheses, and then we're going to concatenate data frame 1, data frame 2. That's all we have to write, and let's run this. And so just like I said, it literally took the first data frame 1, 2, 3, 4 and put it on top of the right data frame 1, 2, 6, 7, 8. So that is our left data frame. This is our right data frame, and they're literally just sitting one on top of the other. But just like when we merge either with a left or a right, when you have these skills and there aren't any values that populate for them, it is going to say not a number. And since we're not actually joining, we're not joining on 1 and 2, even though this 1 and this 1 is the same rows, it's not populating that value because, again, we're not joining these together. We're just concatenating and putting one on top of the other. Now, if we go into this concat, we say Shift Tab, there are a lot of different things that we can do, which if you remember, the 0 axis is the left-hand index, and the axis of 1 is the top index, which is the columns. So you can specify that. And we can also do joins. And this is the one that I'm going to take a look at, but there are other ones that you can look into as well. Let's look at join. Let's do comma, and we'll say join is equal to, and let's do an inner join. So let's see what happens with this. As you can see, it is only taking the columns that are the same. That's what this inner is doing. It's joining these columns together, and the ones that were different, they didn't take because, again, we weren't able to combine them. They aren't similar between both data frames. Let's do an outer. And now it's going to take all of them. And like I said, that's doing this on these columns right here, but we can also do it on this axis as well. So let's go ahead and say axis is equal to 1. And when we run this, now it's joining us on this index right here of 0, 1, 2, 3, 4. So now these ones are being joined together, and it's putting it side by side, much like a merge would. So that's how concatenate works. And I'm going to show you one more thing. And again, it's not up here in this title because it's not one that I recommend, but it's one called append. The append function is used to append rows from one data frame to the end of another data frame. And then we can return that new data frame. And so let's do data frame 1 dot append. We'll do an open parentheses and we'll say data frame 2. Very similar to how we've been doing other things. And let's run this. And as you can see, this is almost exactly like how the concatenate did when we first did it. But if we read kind of this warning, it's saying the frame.append method is deprecated and will be removed from pandas in the future version. Use pandas.concat instead. So it's literally warning us, append is on its way out. If you want to do exactly what you're doing right here, go and try concat or concatenate because that'll do the exact same thing. So I'm not really going to show you any other variations of append because there's no reason it's going to be on its way out in the next version. So that is our video on merge, join, and concatenate, and append as well, in pandas. And I hope that was helpful. I hope that you learned something. I mean, this stuff is really important because oftentimes you're not just working with one CSV or one JSON or one text file, you're working with multiple of them, and you need to combine them all into one data frame. And so this is a really, really important concept and thing to understand. With that being said, be sure to like and subscribe. Check out all my other videos on Python and pandas, and I will see you in the next video. Hello everybody. Today we're going to be building visualizations in pandas. In this video, we'll look at how we can build visualizations like line plots, scatter plots, bar charts, histograms, and more. I'll also show you some of the ways that you can customize these visualizations to make them just a little bit better. With that being said, let's go right over here, start importing our libraries, and we'll start with importing pandas as PD. And this one is really all you need to actually create the visualizations in pandas, but we may get a little bit crazy. And so we're going to do a few different ones as well, like import numpy as np. And then we're going to do import matplotlib.pyplot as plt. Now I may or may not use this. I just, when I get into visualizations, I may want to change some different things. So we're going to at least have them here in case we do want to use them. Let's go ahead and run this. So now let's get our data set that we're going to be using. So let's say data frames equal to pd.read_CSV. And let's get this in right here. Now we're going to be doing these ice cream ratings. Let's take a look at this really quickly. Now these values are completely randomly generated. They are not real in any way. But that's what we're going to be using because I just wanted something kind of generic, something that wouldn't be too crazy confusing, just something that we could use and you guys can understand that they're just numerical values. But let's also set that index really quick. So we'll say dataframe.set_index, and then we'll say date. And then we'll say that's equal to the data frame. And we have this date column right here as our index. So we have January 1st, 2nd, 3rd, 4th. And then we have our ratings right here. And again, these are all just integers and they're pretty easy or really easy to demonstrate how you can visualize these. So that's why we're using it today. So the way that we visualize something in pandas is we use something called plot. So let's just take our data frame. We'll do data frame.plot and we'll do our parentheses. Now let's go in here really quickly. Let's hit Shift Tab and this is going to come up, and this is pretty important because this kind of is going to tell us what we can do within this plot. And unfortunately, there isn't like a quick overview. We just have this doc string, but we have our parameters right here. These are what we can pass in to kind of customize our visualization. So the data is going to be our data frame. Then we have our X and Y labels. We can specify the kind, and this one's important because we can specify what kind of visualization do we want. We can do a line plot, horizontal, a vertical bar plot, histogram, box plot, and then a few others, including area, pie, density, all these other things. We can also specify if we want it to be a subplot. And a lot of these things that I'm specifying, I'm going to show you how to do. You can use different indexes. You can add titles, add grids, legends, styles, all these different things. And you can go through here because there are a lot. But you can specify and customize all of these things. We won't be going into all of them, but I will show you some of the ones that I probably use the most and that I think are the most useful to know right away. So let's get out of here. And we're just going to do df.plot. And when we run this, we'll get this right here. And that was super, super easy. We created a line plot by literally doing just about nothing. But by default, it's going to give us a line plot. So if we come up here, we say kind, and let me get that out of the way, is equal to line. And we run this. So by default, without us actually having to input anything, it's giving us that line plot as a default. So we can specify that it's a line plot. As you can see, we already have all of our data right here. We didn't have to specify anything. It kind of automatically took it in. It is visualizing all three of these columns. And it has this little legend right here. And we can specify where we want that. There is an argument to be able to do that. It also gave us these tick marks of 2, 4, 6, 8, 10. Again, it read in and said it's only going from 0.0 to 1.0. That is kind of the peak. And so it kind of automatically gave us these ticks for us. Again, that's another thing that you can specify. We make it go up to 2, 5, 10, 1,000, whatever you want it to be. And then we're doing this based off of this date value right here. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. If we wanted to break these out by the actual column, we could go in here and say subplot is equal to true. And it's actually subplots, whoops. And now we can run that. And then we can see each of those columns being broken out by themselves instead of them all being in one visualization. It's now 3 separate visualizations. Now let's go right over here. We're gonna get rid of the subplots. I wanna show you just some of the different arguments that you can use to make this look nice because I don't wanna do this on every single visualization. I just wanna show you what you can do. So we have this one right here. We can add a title. Notice there's no title or anything really telling us what that is. So we can say comma, title, and we'll say ice cream ratings. If we run this, we now have this nice title right here. Now we can also customize the labels or the titles for the X and Y axis. It automatically took this date, which is right here. This is our date index. It automatically took that for us, but we can customize that if we'd like to. All we have to do is comma, and then we'll say X label is equal to, and so our X is this date one right here. And we can say daily rating. And then we can do the Y label. We'll say Y label is equal to, and for this one, we can say scores. I hope you cannot hear my dog in the background because they are being insane. But let's go ahead and run this. And now we have these daily ratings on the X axis, and on the Y axis, we have scores. Now let's go right down here and start taking a look at our next kind of visualization, which is going to be a bar plot. So we'll do df.plot. We'll do kind is equal to, and for this one, we're going to say bar. Now this is what your typical bar plot will look like, and a lot of the arguments that we just did on the line plot, you can also apply to this bar plot. Something that's unique to the bar plot is that you can also make it a stacked bar plot. All we have to do is go in here, we'll say comma, and we'll say stacked is equal to true. So now it's going to make it a stacked bar chart instead of just, your regular bar chart. Let's go ahead and run this. And as you can see, this is now stacked on top of one another with each of these columns all representing the values that they have. Now we don't always have to do every single column. We can also specify the column that we want. So let's take the flavor rating, for example. We could do flavor rating. Good night. Flavor rating. And then it's only going to take in that flavor rating column. And if you notice, we don't have a legend. That's only when you have multiple values, which we are only looking at this one column. So all the values are right here. Now in this bar chart, it automatically defaults to a vertical bar chart, but you can change it to a horizontal bar chart. Let's go ahead and take a look at how to do that. Bring back all of them. We'll do df.plot dot, and then we'll say bar h. And I don't know if I can keep in that kind equals bar. Let me run this. Yeah, I need to get rid of that because the bar.h is its own, this is its own function. So now I'm going to run this. It should just have a stacked bar chart, except now it should be horizontal. So now you can see this worked properly. It's basically the exact same thing as a vertical bar chart, just now horizontal, which may look better, especially depending on if you have values like this, or something else that just looks better being horizontal. Now the next one that we're going to take a look at is the scatter plot. So we're going to say df.plot.scatter. And if we run this, we're going to get an error. What we need in order to run this properly is we need to specify the X and the Y axis in order for this scatter plot to work. So let's go here and we'll say X is equal to, and we can take any of our columns that we have up here. So we'll say X is equal to texture rating, and then Y is equal to, and we'll do overall rating. Now when we run this, it should work properly. Let's go ahead and take a look. Now if we go in here and we do Shift Tab, we can also see some other things that we can specify. So let's go right down here. So we have our X and we have our Y, and those are the ones that we just did. We can also pass through an S, which is going to tell us or change the size of the actual dots right here in our scatter plot. Then we can also do a C, which is the color of each point. Let's start with the S. Let's say S is equal to, and let's just do 100. Let's see what that looks like. So we have a much larger number. Let's do 500 and see what that looks like. So we can make these much larger on our visualization, depending on what you're looking for. We can also look at the color. Let's put comma C. So for color, we can say color is equal to, and let's do yellow. Let's see if this works. So now we've changed it to yellow. That looks absolutely terrible, but it does work. Now let's move on to the histogram. Histogram is always a good one. It's very similar to something like a bar chart. But what's great about a histogram is you can specify the bins. So let's go ahead and say df.plot.hist. Then we'll do an open parentheses, and let's go ahead and hit Shift Tab in here. Take a look at this one as well. So some of our parameters are the actual columns or the data frames that we want to pull in. We can choose the bins, and they have a default of 10 in here. And so let's take a look at how this works. So we'll just run this as it is. So this is by default what this histogram is going to look like. Let's go ahead and specify our bins. We'll just say it was 10 by default. Let's just do 20, see what that looks like. So there are smaller columns right off the bat. And remember, histograms are really good for showing distribution of variables. That's really what a histogram is for. But of course, since these are completely random numbers, this histogram isn't going to make any sense at all, but you can at least kind of see visually how it works. And if I didn't mention it before, which I should have, the bins represent how many kind of tick marks are down here. So if we just do 1, it's only going to be one very large, histogram. We could even go further down from 10 and do 5. So now there's only 1, 2, 3, 4, 5. So the distribution gets smaller and things get more compact. As you spread it out, again, like we did 100, it's going to spread it out a lot. And this is what it shows. It's showing the distribution of those bins across however many you want. So the 10 by default, it usually is pretty good for a lot of different things. Now let's go down here and look at the box plot. And the box plot is a pretty interesting one. Let's go ahead and visualize it really quickly, and then I'll kind of explain how this one works. Let's do df.boxplot. Let's run this. And really what we're looking at is some different markers within our data. This line right here is the minimum value within that column. We also have the bottom of the box, which is the 25th percentile of all the values within just this column. This is 50%, then we have 75%, and then up here, we have our maximum value. So I can take a glance at this and see that we have a low minimum, a high maximum, and it definitely skews towards the lower range. Whereas if I look over here, we have a lower minimum and a higher maximum. And you can see that this medium point is at 0.6 versus 0.4 over here. So this skews a lot higher. Now let's go down here and take a look at an area plot. We'll do df.plot.area, and let's just run this. This is what we're going to get by default. Now, something I wanted to show you earlier, I just haven't gotten around to. I want to show you something called figure size or fig size. So for this, it's just looks small, looks a little bit cramped. Let's say we want to increase the size of this. And we'll say fig size is equal to, and let's just do a parentheses and say 10, 5. That should be pretty large. And this is going to make it a lot larger. Just something I wanted to throw in there. I look at these area charts as pretty similar to like a line chart. If we went and compared those, this would be pretty similar. But they're different visually, and you absolutely can use these for different types of visualizations. But I don't use this one a lot, if I'm being honest. That's why it's kind of towards the end of the video, but you definitely can do it. Well, let's go on to our very last one of the video. That's going to be the beautiful pie chart. Let's say df.plot.pie. We'll do an open parentheses, and let's run it. We're going to get this error. That's because we need to specify what column we're working with here. So let's just say the Y, and that's what we need. Let me open this up for us. Right here, we have our Y, and this is our label or our column that we're going to plot. That's really all we need. So we can just say Y is equal to flavor rating. Flavor rating. And let's run this. And now we get this visualization right here. Let's make this one a little bit bigger. Fig size is equal to 10, 6. Now it's a little bit bigger. It definitely depends. So this legend is going to auto-populate. You can make this as big as you want. And obviously it's going to look a little bit better if you do it larger. And these colors auto-populate. Now you can customize these colors, although I found these ones to be just, when you have a lot of them, it's harder to customize them as easily. But, definitely look into it. These are things that everything in here is almost something that you can customize in some way. Although it does get a little bit tricky, you definitely have to do some research and some Googling around just to kind of figure out how to do those things. Now, one last thing that I wanted to show, and something, I could have probably done at the beginning, is you can actually change what visual this is. And we can do that pretty easily. Within Matplotlib, there are different styles. And so let's go right here. Let's add a new row, a new cell, and we'll say print, and we'll do PLT. So that's that Matplotlib right here. We'll do PLT.style.available. And what this is going to do, what this is going to do is show us all these different types of stylings that you can do to kind of change up this visualization. And then once we find the one that we like, we'll just do PLT.style.use. And then in the parentheses, we'll just specify which one we want. Now, there's all these Seaborn ones, and Seaborn is a really great library. Let's try Seaborn Deep. I haven't tried this one at all. Let's go ahead and try this. It just changes some of the colors, some of the visuals. We can try something like 538. Let's try this. That looks quite a bit different. And let's try something like classic. I don't know what this one looks like. Let's just try it. So you can try out all these different styles, find one that you like, find one that you think looks really nice, and you can run with it through all your visualizations. So this has been our video on visualizing data in pandas. I think it's a really good introduction on how you can visualize data within Python. And in future videos, we'll look at Matplotlib and Seaborn, which are some really great libraries for visualizing data, which I use a lot. So I hope that you enjoyed this video. If you did, be sure to check out all my other videos on Python and pandas, and I will see you in the next video. Hello everybody. Today we're going to be cleaning data using pandas. Now there are literally hundreds of ways that you can clean data within pandas, but I'm going to show you some of the ones that I use a lot and ones that I think are really good to know when you are cleaning your data sets. So we're going to start by saying import pandas as PD, and we're going to run that. And now we're going to import our file. So we're going to say data frame is equal to PD, so that's pandas dot read underscore, and we actually have this in an Excel file. So we'll say read Excel, do an open parentheses, and we'll do R, and then we'll paste the path right here. And now we're just going to call that variable. So we'll call data frame, and we'll actually read it in and look at the data. So let's scroll down here, and let's take a look at this data frame or this Excel file that we're reading in. So right off the bat, we have this customer ID that goes from 1001 all the way down to 1020. We have this first name, and everything looks pretty good here, except in this last name column, looks like we have some errors. We have some forward slashes, some dots, some null values. So definitely gonna have to clean that up because we don't want that in the data. We have a phone number, and it looks like we have a lot of different formats, as well as NAs, not a number, just lots of different stuff. So we're gonna need to standardize that. So clean it up and then standardize it to where it all looks the same. We also have address, and it looks like on some of these we just have a street address, but on some of the other ones we have like a street address and another location, as well as a zip code in some of them. So we'll probably want to split those out. We have a paying customer, which is yes and no's, and some of those are not the same, so I'll have to standardize that. We have a do not contact, kind of the same thing as the paying customer. And we have this not useful column, which we'll probably just want to get rid of. Okay, so the scenario is that we got handed this list of names, and we need to clean it up and hand it off to the people who are actually going to make these calls to this customer list. So they want all the data in here standardized and cleaned so that the people who are making those calls can just make those calls as quickly as possible. But they also don't want columns and rows that aren't useful to them. So things like this not useful column, we're probably going to get rid of. And then ones that say do not contact, if it says yes, we should not contact them, we probably will want to get rid of those somehow. So that's a lot of what we're going to be doing to clean this data set. Normally, the very first thing that I do when I'm working with a data set, most of the time, except very rare cases when you're actually supposed to have duplicates, is I actually go and drop the duplicates from the data set completely. All you have to do for that is say df.drop_duplicates. So they make it super easy for you. Let's just run it. And up here is our original data set. We have this 19 and 20, and those are obviously duplicates. They have the exact same data. It's just a duplicate row that we need to get rid of. If we look right down here, we no longer have that 20. We now just have one row of Anakin Skywalker. And of course, we want to save that. So we're just going to say df is equal to and df. So now it's going to save that to the data frame variable again. And now when we run this, our data frame now does not have any duplicates. That's definitely one of the easier steps that we're going to look at. Things are going to get quite a bit more complicated as we go, but I'm starting out, kind of simple so that we can kind of get a feel for it. And then we'll start getting into the really tough stuff. So the next thing that I want to do is remove any columns that we don't need. I don't want to clean data that we're not going to use. So if we're just looking through here, they may need, first name, last name, phone number for sure. Address might give them some information of where they're calling to or time zone, so we want that. This not useful column looks like a pretty good candidate to delete. And it's very easy to do that. We're gonna go right down here, and we're gonna say df.drop. We'll do an open parentheses. Drop just means we are dropping that column. And we can specify that by saying columns is equal to, and then we'll paste in that column that we want to delete. So let's run this and see what it looks like. And it literally just drops that column exactly like we were talking about. It no longer has that column. Again, we want to save that. We can always do in place equals true. If you follow this tutorial series, you can always do in place equals true, and that'll save it as well. But just for our workflow, most of the time, I'm going to assign it back to that variable just for keeping it the same. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. Now let's kind of go column by column and see what we need to fix. And we'll start on this left-hand side. This customer ID to me looks perfectly fine. I'm not going to mess with it at all. The first name at a glance also looks perfectly fine. I don't see anything wrong with it visually, which is a good thing. Although sometimes that can be deceiving and it can cause errors down the line, but we're not going to assume that there are errors in here. Now let's look at this last name. Now the last name, obviously, I'm seeing some obvious things that we talked about when we were first looking at this data set. We have this /, which we definitely need to get rid of. We have null values, so not a number right here. We have some periods as well as an underscore right here. So all those things, I think we should clean up and get rid of it so that when the person is making these calls, it's all cleaned up for them. So how are we going to do that? We can actually do this in several different ways, but let's just copy this last name. The first one I'm going to show you is strip, and we'll write it kind of like this. We'll say data frame, and then we'll specify the column that we're working with because we don't want to make these changes or strip all of these values from everywhere. We only want to do it on just this column. If we do this and we don't specify the column name, it will apply it to everywhere. So if we're trying to do these, let's say these underscores, maybe that would mess with something else in another column, and we don't want that. So we just want to specify just this last name. So let's go last name dot string dot strip. Now what strip does, and let's see if we can open this up really quickly. No, we can't. But what strip does, I was hitting Shift Tab in here to see if it could bring up, some of the notes on it. But what strip does is it takes either the left side or the right side. Well, L strip takes from the left side, R strip takes from the right side, and strip takes from both. But you can strip values off the left and the right hand side, and we can specify those values. Now, for what we're doing in this column, we can just use strip because as you can see, this /, these dots, as well as this underscore are all on the far sides. If there was a value like swan underscore son, the strip wouldn't work at all because it's not on the outside of the value or the word. So we can use strip. I'll also show you how to use replace. And replace is another really good option for things like this. But let's start with strip and just see what it looks like and see if we can get what we need done. So let's just run this for now and see what happens. So it looks like nothing has changed because again, we're not specifying any specific value. Just by default, it's only taking out white space. So like spaces that shouldn't be there. That's what it does by default. Now we can specify within this exactly what values we want to take out. So let's go ahead and do that. Let's say left strip, and let's try to take out these dots real quick. So we're just going to do a parentheses, ... Now let's run this and see what it looks like. For this one, Potter, it is now gone. So those 3 dots were there before. Let's just show it. So they were there. And then when I ran it like this, now they're gone. That's what the L strip does. It takes it only off the left-hand side. Now we can also do a /. So we'll do something like this, and it'll get rid of the white. But as you can see, now we aren't taking out these 3 dots, so they're still there. Now, is it possible to do something like this, where we put these values inside of a list? Let's try it. So we'll say just like this, 1, 2, 3. Let's run it. And no, it doesn't. This L strip actually sits within the realm of regular expression. So if you've ever worked with regular expression, you know it gets very complicated, very complex. So you want to keep it kind of simple, especially with these values where we're just taking a few out. So what we're going to do is we're going to do ... and we're going to take it out one by one. Now, in order to save this, because we want to save this, we want to take out that value. We don't just want to say data frame equals, because that would be very bad. What this would say is now this data frame is only equal to these values that we're seeing right here. We want to only apply it to this column. So we're going to go like this. So now when we do it, and then we call the entire data frame, it's only applying this to this one column, the last name column. So let's run it. And now when we go down to Potter right here, it's cleaned up. So we're going to do the same thing, but for those other values. And we'll do it just like this. We'll do a /, and it's a left strip. And then I'll do the left strip on this underscore just to show you that it won't work. And then we will go on from there. So it's not pulling it because we're looking at the left-hand side only. We need to use rstrip. So now let's use rstrip. And now that looks perfect. It has no underscore. So that's how you can use strip for either the left side, the right side, or just strip by itself, which covers both sides. Now I showed you all of that because I am going to show you a different way to do it. And I apologize because I somewhat lied to you earlier. Let's run this right here. Actually, we're just going to pull it in like this. We're going to remove the duplicates again. Bear with me. We're going to drop that column. And then now we're sitting with that data frame again with those exact same mistakes. I just wanted to reset it for a second. There is a way that you can do this, and I just wanted to, kind of show you how you can do it. You can do this right here. And we'll say, so we're just looking at this column, and we're using strip. And let's get rid of R because we want to apply it to everywhere. You can input all of those values individually, and it will clean it up. So let's say we want to get rid of numbers. We'll do 1, 2, 3. Then we could do the dot. So that's going to be for our period or for our ... Potter. We could also do the underscore, and we can do the /. So we put it all in one string right here. Now let's take a look at this. We'll get rid of this really quickly. Now let's take a look, and all of them were removed. I showed you how to do it before because that's at least how my mind would think about it. I'd think, oh, I can put it in a list and run it through this L strip or this right strip and it would work. But that's not how strip works. You have to kind of combine it all into one value. So yes, I deceived you. I apologize. But now when we call data frame and we assign it to that column, so the last name column, we're assigning what we just did to this last name column, everything should look perfect. And it does. So our customer ID, first name, last name are all cleaned up. Now we're going to come to a much more difficult one. This is probably, if I'm being honest, the hardest one. I said we were going to work up, but this is probably the hardest one of the whole video, working with phone numbers. And look at all these different types of formats. I mean, it is, it's not going to be fun. And imagine, there's 20,000 of these. You can't just go and manually clean those up. You need something to kind of automate that. So that is what we're going to do. So let's go right down here. We'll copy the data frame and I'm going to pull it right here. So now we need to clean up this phone number. What we want is it all to look exactly the same, unless it's blank, and we'll keep it blank. We don't want to populate that data, but we want all of them to look exactly like this one. And what we're going to do is right off the bat, we're going to take all of the non-numeric values and just completely get rid of them. Strip it down to just the numbers. So this 123-643 or / will just be the numbers. Same with these bars and these slashes and everything. All of these will just be numeric. Then we'll go back and reformat it how we want to format it, which will look exactly like this one. But we just want to do it for the entire column. So let's go right up here and we're going to try replace for the first time. So let's do phone number. Do it just, oops, that's not what I wanted. So we're going to do a bracket. Let's say phone number dot string dot replace, just like we did before. Now we're going to use some regular expression in here, and I'll kind of do a really high overview, although I'm not going to dive super deep into the regular expression. Then we're going to do a parentheses, and within there, we're going to do a bracket. I can't remember what this is called. Is it called a caret? I think it's called a caret. But I'm just going to call it that. It may not be correct, but I think it's an upper arrow. So it's an upper arrow, A-Z, A-Z, and then 0-9. Now at a super high level, what that caret or that first thing is doing, it's saying we're going to return any character except, and then we specify anything A to Z, upper or lowercase. And then actually, I think this should be like this, A to Z, and then 0 to 9. So any value like A, B, C, 1, 2, 3, those are not going to be matched. It's going to match all of them except these values. And then we're going to replace them by saying comma, and we're going to replace them with nothing. So this is just an empty string. So literally we're taking everything that is not an A, B, C, a 1, 2, 3, so a letter or a number. We're replacing all of that, and then we're replacing it with nothing. So let's run this and see what it looks like. And it looks like that worked properly. Now we do have this NA because we had an N-A for, I don't know, maybe that was Creed Breton. But it worked for basically everything else. We're going to go through the entire process, and then at the end, we'll remove any values. We want them to just be completely null. We don't want them to even see NaN and wonder what that is. We just want it to be blank. And we'll do that at the very end. So now that we know that that worked, let's assign it. We'll do df phone number is equal to, and then we'll say data frame. And this looks a lot more standardized than it did before already. But now what we want to do is try to format this. And I've done this many, many times. I always use a lambda. You can definitely use a for loop. I don't do it that way myself. So I'm going to show you how to do it using a lambda. Let's get rid of this. And we're going to say df phone number. We've already done that. I'm just going to get rid of it. Now we're going to say df phone number. Then we're going to say dot apply. We'll do an open parentheses. And then this is where we're going to build out our lambda. So we'll say lambda x colon. Now this is where we're going to kind of format it. So what I want to do is I want to take the first 3 strings, 1, 2, 3. Then I want to add a slash, and then the next 3 strings, add a slash or a dash, and then that be the value that's returned. So it's not super difficult. We're just going to do x, and then a bracket. Let me get rid of that. An x, and then a bracket. And then we want the 0 to 3. So it goes 0, 1, 2. So 0, 1, 2. It doesn't include the 3. It goes up to 3. So 0, 1, 2. That's our first 3 values. Then we'll do plus and do a quote and do a dash. So this is our first kind of sequence. And I'm just going to copy this. And we'll do plus. And instead of 3, we are going to start at 3 because now it's inclusive. So we're going to go from 3 and we're going to go all the way up to 6. So it should be 3, 4, 5, our next 3 values. And then we have a dash. And we'll copy this and we'll say plus. And now we go from 6 all the way to 10. Now let's try running this. And as you can see, we get an error. Now I already know what the error is. Float object is not subscriptable, which means we're trying to basically look at it like a string. Right now, it's not a string. It's actually a number. So let me get rid of this for just a second. I want to show you what it's talking about. So right now we have values that are floats and values that are strings or not even a number. So we have values that are strings or not a number. So if we want to actually look through it, like kind of like indexing, if we want to do that, they all have to be strings. So we need to change this entire column into strings before we can apply this formatting. Now, when I was creating this, if I'm being honest, my first thought when I was doing this was to do it like this: string df phone number. Let's just run that. This is what the values look like. And I don't remember why it was doing this. I can't remember, but I looked into it quite a bit and I was like, oh, I need to apply this string, converting it to a string on each value, not the entire row or not the entire column. So how we can do that is actually fairly easy because we've already done a lot of the heavy lifting. We're just going to copy this and we're going to say x, so string of x. And again, lambda is like a little anonymous function. So you could do this by saying for x in this column, we could do a for loop and then say for every x, it equals the string of x, and then it changes it to a string. But a lambda just does it a lot quicker. So we're going to say, so let's do that really quickly. And all of our values look exactly the same, and that's how we want it. So we're just going to copy this, apply it. Good. And now we're going to take this and we're going to run this again. Just ignore all my commented out stuff. Pretend I don't have that. So now when we run this, it should work. There we go. Now if we look at these numbers, 1, 2, 3, dash, 5, 4, 5, dash, 5, 4, 2, 1. And it does that for every single one where there's values. Even when there's NaN or NA, it's still adding those values. but we expected that. So let's apply it. Say is equal to, and then we'll look at the data frame. And this looks almost exactly what we're hoping for. We just need to get rid of these. So this NAN dash dash and this NA dash, we need to get rid of those. And that is super easy to do. We're just going to say, so now that we've done it, and we'll comment that out, we'll say df, and let's copy this. Ignore the messiness. I do apologize for that. It's very messy, but if you're following along with me, you get what we're doing. So df phone number, so only on the phone number, say dot string dot replace, and open parentheses. Now we can specify this value. So we want to take this exact value and replace it with nothing. And let's just see if that does work. It does. Now we have these NAs. And so let's actually, I'll paste that right down here. We're going to do this is equal to, and then we're just going to take this entire string, put it right here, and put this value as our what we're looking for and then replacing. And then when we call that data frame, it should work properly. And it is perfectly cleaned. So we have every single value, all the exact same. They don't have different characters or different, formatting. And we got rid of all the ones that we don't have or don't need. All the ones that were just random values. So this column is now completely cleaned up. Again, definitely one of the more difficult ones, ones that I've done 1,000 times. I've had to work with a lot of phone numbers and stuff like that. This one does get very tricky, especially if you have like a +1, which is like an area code. That can get tricky as well, but this is on a kind of a high level. This is how you can do that. And it's pretty neat how you can actually, clean up and standardize those phone numbers. So let's go right down here. Let's run it. The next thing that we're gonna look at is this address. Now let's just pretend that the people who are on the call center want all these separated into 3 different columns. They can read it easier, see what the zip code is, where they live, whatever they want it for. Let's just say we want to do that. And this is, again, for this use case, it may not make sense, but you have to do this. I do this all the time. You need to split those columns. Now, luckily, all of these things are separated by a comma. So we can specify that we're going to split on this column, and then we'll be able to create 3 separate columns based off of this one column, which is exactly what we want. And we can name it as well. And we can do that very easily by using this split. So we're going to say df, and we want to specify, oh geez, not again. So we want to specify that we're looking at the address. Then we're going to say dot string dot split. And we'll do an open parentheses. Now the very first value that we need to specify is what we're splitting on. So we want to split on the comma. So we want to specify that. And then we need to specify how many values from left to right it should look for. Now we'll just start with 1, and then we'll go from there. Let's just see what this looks like. So it doesn't really look like it did anything. Let's do 2. Well, let's go back to 1, and then let's say expand equals true. When we expand it, it's actually going to separate it, I believe. Okay, so we're expanding. We're only doing this with 1 comma. So we're only looking at the very first comma and splitting it. But in some of these, well, just in 1, there is an additional comma. So we should do it up to 2. Let's do this. Okay, so now we have 3 columns. If we just save it like this, it's going to give us these 0, 1, 2, basically these indexed values for these columns. And we don't want that. We want to specify what these actually are. And we can do that by saying df, and let me just do is equal to. We'll do bracket, and then within there, we're going to specify our list. So we have 3 of them that we have. So I'm going to do the first one. This is the street address. So we'll say street address. The next one is, it's Shire is not a state, but these all are states. So I'm just going to say state. And then for the very last one, that looks like a zip code. So we'll say zip, and we'll do underscore code. In fact, I also want to do street underscore address. So what this is now going to do is these 3 columns are going to be applied to these 3 names, and they'll basically be appended. It doesn't replace the address. We're not saying df address equals the df address. We're not replacing it. we're now creating different columns. So let's run it, and then let's also call it. So they're right over here on this right-hand side. I couldn't see them at first, but it did exactly what we needed it to do. So now if we wanted to, at the very end, if we want to, we're not going to, we could just delete this address and keep the street address, the state, and the zip code. Another really common thing that you can do, this happens often again with like first name, last name, where you'll have Alex Freeberg, but it's Alex comma Freeberg or Alex space Freeberg. And you can separate those out into different columns. Now the next one that we want to look at is this paying customer, and the paying customer and do not contact are very similar in the fact that it's yes, no, NY, yes, no, NY. And so let's go right on down here, and we're going to say df dot, and we want to just replace these values as all yeses or all nos, but just with the same formatting, just to keep it consistent. So let's make anything that's an N into a no, anything that's a Y into a yes. I like it spelled out. So let's change anything that's a yes into a Y, anything that's a no into an N. That's usually how I do it. Just saves on data because it's less strings, although it can be often very minimal. But let's specify the paying customer. We'll say df bracket paying customer. Then we'll do dot string dot replace. So now we're just going to look for those specific values. So if it's a Y, a capital Y, then we'll say yes. Now let's run it. And now we have no more Y's. We now just have yeses, although now these are yeses. Okay, we don't want to do that. Let's do, if we're looking, because it's taking, it's literally looking up here and saying, okay, here's a Y. Let's change that Y into a YES. So now it's doing YES, ES. We don't want that. So let's look for the yes and change it into a Y. Now when we run this, that looks a lot better. So we'll do df paying customers equal to, and then we'll copy this. We'll do the exact same thing. No, and N. And then let's call it. And now that entire column looks really good, except for that value right there. But I'm going to leave that because I'm just going to apply it to the entire thing all at once to get rid of those at the end instead of just going column by column. And then it's literally going to be the exact same thing. So I'm not even going to scroll down. Whoops. I'm just going to put it right up here because this is the exact same thing. I'm going to save us all some time. And when we run this, this looks exactly like what we're looking for. Again, some not a number of values, but we can get rid of that in just a second by doing a replace over the entire data frame. And that is basically the end of cleaning up individual columns. Now let's go right down here. We're going to say df.string.replace, and then we'll first do these values. Oops. So we'll do, oops, let me do that. There we go. And replace that with nothing. And let's just see what it looks like. Oops, data frame object has no value string. Well, that's because we were looking at columns before. Yeah, I think I just need to get rid of this string. We're not looking at it. We're just literally doing it across the entire data frame. Now let's try that. Okay, that worked appropriately. And we'll just say data frame is equal to, and then we'll copy this and we'll do the NaN as well. And we'll do, and now when we do this, it is not going to replace these because these aren't actually a value because we're looking for that string. We actually need to use, and I completely forgot this. I'm not going to lie to you. Let's get rid of this. To get rid of those values, because it's literally not a number. It is technically empty. I forgot we can do, or we could not even specify it. We'll do df.fillNA. So we're going to fill these values if there's nothing in them. We're going to fill it and we're going to say blank. And when we run that, every value that doesn't have something in it is going to show up blank. Even over here, where we only had a few, all of them throughout the data frame, if it doesn't have a value, it is now blank. So let's apply that. And we'll run this. And now all of our cleaning for actually cleaning up the individual columns is completely done. We've removed columns, we've split columns, we've formatted and cleaned up phone numbers. We've also taken values off of first name or this last name column. And then we formatted and just kind of standardized paying customer and do not contact. Now, they also asked us to only give them a list of phone numbers that they can call. So if we take a look, some of these do not contacts are Y, which means we cannot contact them. And then there are some that don't even have phone numbers. So we don't want to give the people, the call center, numbers that or people who don't have numbers. So we want to remove those. Now there's a few different ways that we can do this, but let's start with, and we'll just go by, do this do not contact. It seems like the most obvious one. Now, if it's blank, we want to give them a call. We only want to not call them if they've specifically said we cannot call them. So if it's Y, we're not going to call them. So what we need to do, and it's not anything like this, we probably need to loop through this column and then look at each row that has a value of this and drop that entire row. And we probably will need to do that based off this index instead of doing it based off just this column. That may not make sense, but let's actually start writing it. So we'll do 4x in, and we need to look at our index. So we're just going to let's do in df.index, and we'll do a colon, enter. And then we want to look at these indexes. How do we look at these indexes? We use lock. That's going to be df.loc. And then we need to look at the value, which is this x right here. So each time it looks at the index, it's looking at the value. But we want to look at the value of this column. Do not contact. I don't know if I copied this before. Let me copy it. We only want to look at the value in this one column. If we didn't, it would look at a different value. So we don't want that. So we're looking at just that value if it's equal to y. So if this value is equal to y, then we want to drop it. So we actually need to say if. So if this value, x, in this column is equal to y, then we want to do df.drop, and then we'll say x, and I think we have to say in place equals true here, otherwise it won't take effect. Otherwise you have to say like df is equal to df.ai, and I don't want to start messing with that. Let's just do in place equals true. And let's see if that works. I can't remember if this is going to work or not. Invalid syntax. Okay, need a colon. And now let's try to run this. Okay, yeah. If we look at our index, we can already tell that there are ones missing. The one is missing, the 3 is missing. Let's see. And the 18 is missing. So we already got rid of those values, and you can see that there's no y's in here anymore, which is really good. We can, if we want to, and we probably should. We should probably populate that really quickly. Let me just go up here really quick. I'll copy this. We probably should populate that, and I didn't plan on doing this. So if it's blank, oops. If it's blank, give it an N, and we want to attribute it to do not contact. Do not contact, whoops. Let's see if that works. And we probably need to do dot string. Let's just see if it works. So if it's blank, dude, okay, I don't know why it's giving us a triple N. Maybe I need to strip this or something. Okay, never mind. Let's not do that. But now we basically need to do the exact same thing for this phone number, because if it's blank, we don't want them calling it. So we can copy this entire thing, go right down here. But now we're looking at phone number. So now we're looking just at the values within phone number, and we only want to look at if it's blank. So if it literally has no value, we want to get rid of it. Let's run this and see if it works again. It should. Good. And now our list is getting much smaller. So you can see in our index, a lot of those rows were removed. And okay, good. Actually, this worked itself out because these all have ends. So right now we're sitting really good. Everything looks really standardized, cleaned. Everything looks great. I might drop this address. If you want to, you can drop this address. But besides that, this is all looking really good. This paying customer doesn't, the yes and no's aren't really anything. Now we could, and we probably should, before we hand this off to the client or the customer call list, we probably should reset this index because they might be confused as why there's numbers missing, or, they might use this index to show how many people they've called, or I don't know, something like that. So let's go right down here. We're going to say df dot, and then we'll do reset underscore index. And let's just see what this looks like. It does work, but as you can tell, it didn't get rid of that index completely. It actually took the index and saved that original one. We do not need to save that. Whoops, let's put it right in here. Now we're just going to do drop equals true. And when we do that, it just completely resets. It drops the original index and gives us a new index. And that is what we want. Let's do df equals. And this is our final product. Now, one thing that you definitely could have done here, and I made this a little probably more complicated than it needed to be. That was just how my brain was working at the time when I'm typing this out. We could have done df dot drop NA, which is literally going to look at these null values. Before, we couldn't do that with this one because we're not looking at NA, we're looking at Ys. So we couldn't do that. But because we're looking at null values, we could have also done drop NA and done subset is equal to, and then done it just on this phone number. And then done like this, and done in place equals true. So we could have also done this and then said df equals. I can run it. It's just not going to do anything. I can run it on the different column, but that'll mess everything up. But this is another way you can do it. And I'll just save it in case you want to. I'll say another way to drop null values. There you go. And that'll just be a note for us in the future. But this is our final product. It looks a lot different than when we first started. I mean, we had mistakes here, completely different formatting in the phone number, different address, everything that we just talked about. And this looks just a lot better. And you can tell why it's really important to do this process because, again, we're working on a very small data set. I purposely, created this data set with these mistakes because, when you're looking at data that has tens of thousands, 100,000, 1,000,000 rows, these are all things that are going to be applied to much larger scale, and you won't be able to as easily see them. You'll have to do some exploratory data analysis to find these mistakes. And then you're going to need to clean the data, or doing it at the same time when you're exploring the data. So you'll clean it up as you go. But these are a lot of the ways that I clean data, a lot of the things that you can do to make your data just a lot more standardized, a lot more visually better. And then it really helps later on with visualizations and your actual data analysis. So I hope that that was helpful. I know that this was a long video. I'm sure it was, but I hope that you got something out of this and you learned some of the techniques on how to actually clean data in Pandas. If you like this video, be sure to like and subscribe. Check out all my other videos on Pandas as well as Python, and I will see you in the next video. Hello everybody. Today we're going to be looking at exploratory data analysis using Pandas. Exploratory data analysis, or EDA for short, is basically just the first look at your data. During this process, we'll look at identifying patterns within the data, understanding the relationships between the features, and looking at outliers that may exist within your data set. During this process, you are looking for patterns and all these things, but you're also looking for mistakes and missing values that you need to clean up during your cleaning process in the future. Now, there are hundreds of ways to perform EDA on your data set, but we can't possibly look at every single thing. So I'm just going to show you what I think are some of the most popular and the best things that you can do when you're first looking at a data set. The first thing that we're going to do are import our libraries. So we'll do import pandas as PD. We're also going to import Seaborn and Matplotlib. Now, during this exploratory data analysis process, I often like to visualize things as I go because sometimes you just can't fully comprehend it unless you just visualize it, and it gives you a larger, broader glimpse of everything. So we're going to import, and let's do Seaborn, as SNS, and then we'll import matplotlib.pyplot as PLT. Let's run this. That should work. Okay, perfect. Now we need to bring in our data set. So we've worked with that world population data set. That is the exact one that we're going to use now. So we'll say data frame equals pd.read_CSV. We'll do R, and we'll paste in our CSV. And this is what it should look like, although your path may be different. Be sure to make sure that you have the correct file path. And then we'll read it in. Now this data set should look extremely familiar if you've done some of my previous pandas tutorials, but I did make some alterations to this one. Took out a little bit of data, put in a little bit of data here and there to change things up, because if it was just exactly how I pulled it, which I got this data set from Kaggle, if it was exactly how we pulled it, like we've looked at in the previous videos, it's too simple. You know, we wouldn't actually be able to do some of the things that I would like to show you. So be sure to actually download this exact data set for this video because it is a little bit different. But what we're going to do now is just try to get some high level information from this. Now, if yours looks just a little bit different, like your values are in scientific notation, I have applied this so many times. I think it's, still applied to this. You can do something, and we'll write it right down here. We're going to do pd.set_option. And we'll do an open parentheses, and we'll say display.float_format. And so we're going to change that float format by just saying lambda x : and then we're going to change basically how many decimal points we're looking at. So let's just do here. So we'll do a quote, %, 0.2f. So we're formatting it. Whoops, 0.2f. So we're going to format it, and we'll do %x. This is going to format it appropriately. I can run it, and actually it will change it because this is at 0.1, because I believe last time I did it. So let's run this, and then let's run this again. It'll change it to 0.2, so that's 2. I like it at 0.1. We don't really need it any, well, let's keep it at 0.2. Why not? We're going to keep it at 0.2, but that's how you change that. And I like looking at it like this a lot better than scientific notation. So just something to point out. Let's go down here. And let's just pull up data frame. So we have this data. One of the first things that I like to do when I get a data set is to just look at the info. So we're going to do .info. And this gives us just some really high level information. This is how many columns we have. Here are the column names. Here are how many values we have. And if you notice, this is where it kind of gets, so we have 234 in each of these. So in each of these columns, we have 234 until we get to this 2022 population. Once we get there, we start losing some values. And then at the world population percentage, we have all of our values, all 234 of them. The count tells us that it's non-null, so it does have values in it. And then we also have the data types. And these come in handy later. And these are really great to know. And we'll be able to kind of use those in a few different ways later on in this tutorial. Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video. The next thing that I really like to do, and this one is df.describe. This allows you to get really a high level overview of all of your columns very quickly. You can get the count, the mean, the standard deviation, the minimum value and the maximum value, as well as your 25, 50, and 75 percentiles of your values. So just at a super quick glance, there is a row somewhere in here, and this country, their population is 510 for 2022. And in fact, if you go back to 1970, it was higher. It was at 752. That's just interesting. Then if we look at the max population, one has 1.42 billion. I believe that's China. And then over here in 1970, we have 822 million. Again, I still believe that's China, but this gives you just a really nice high level of all of these values or all of these different calculations that you can run on it. And we can run all of these individually on even specific columns, but it's just a nice high level overview. One thing that we just talked about was the null values that we're seeing in here. I'd like to see how many values we're actually missing, because that is a problem. We don't want to have too many missing values or could really obscure or change the data set entirely. And so we don't want that. So we'll say df.isNull, and then we'll do a parentheses and we'll say .sum. And when we do this, whoops, .sum, there we go. When we do this, it's going to give us all the columns and how many values we're actually missing. Now we have 234 rows of data. So we have 41477555424. So we definitely have data missing. What we choose to do with it in the data cleaning process, maybe we want to populate it with a median value. Maybe we just want to delete those countries entirely if the data is missing. I don't think you're going to do that, but these are things that you need to think about when you're actually finding these missing values. This is what the EDA process is all about. We want to find different either outliers, missing values, things that are wrong with the data, or we can find insights into it while we're doing this as well. So this is definitely something that I would consider when I'm actually going through that data cleaning process. Really, really important information to know. Now let's go right down here, go to our next cell, say df.unique. And this is going to show us how many unique values, and it's actually n unique. This is going to show us how many unique values are actually in each of these columns. And this one makes the most sense for continent, because I think there's only 7 continents, right? But we have 6 right here. And for all of these, each of these ranks, countries, capitals should all be unique. That makes perfect sense. As well as these, these populations are such specific numbers and such large numbers. I would be shocked if any of these were similar. And then for these world population percentages, it's much lower. And again, that makes a lot of sense, because when we're looking at, and we'll pull it up right here, when we're looking at these world population percentages, a lot of them are really low, 0.00, 0.01, like this one, 0.2. There are a lot of really low values for those small countries. And so those are all, one unique value. Now, let's say we just have this data right here and we want to take a look at some of the largest countries. And we can easily do that. We could say max and take a look at the largest country, but I want to be a little bit more strategic. I want to be able to look at some of the top range of countries. And we can do that based off this 2022 population. So we'll say df.sort_values. This is how we sort and not filter, but order our data. So we'll do sort values, and then we'll do by is equal, and then we'll specify that we want this 2022 population. And then we're going to say comma, and we'll say, actually, let's just run this as is, but we'll do head, because we just want to look at the top values. So now we're just looking at the very top values. So what we're looking at is actually these 2022 population. That's what we're filtering on or sorting on, basically. And we're looking at the very bottom values because it's sorting ascending, so from lowest to highest. So this Vatican City in Europe is 510. That's the value that we were looking at earlier. Now we can do comma ascending equal to false, because it was by default true. We can do false, We can do false, and then it'll give us the very largest ones. So if we just take a look at the top 5 largest by population, we're looking at China, India, United States, Indonesia, and Pakistan. And we can even specify that we want the top 10 in this head. We can bring in the top 10, and we also have Nigeria, Brazil, Bangladesh, Russia, and Mexico. And you can do this for literally any of these columns, whether you want to look at continent, capital, country. You can sort on these and look at them, and you can even look at things like growth rate, world percentage. This one seems really interesting. Let's just look at this one really quickly before we move on to the next thing. If we look at this world percentage, just China alone, I believe, just China alone is 17.88% of the world. So 17.88 and 17.77 and that's China and India. And those are very large countries with a high population. That makes a lot of sense why that is the highest world population percentage. Again, just getting in here, looking around. That's all we're really doing. Now I want to look at something, and I have always liked doing this, which is looking at correlations. So correlation between usually only numeric values. We can do that by saying df.corr and in parentheses, and we'll run this. And what this is it is comparing every column to every other column and looking at how closely correlated they are. So this 2022 population, if we look across the board, it's very highly, I mean, this is a 1-to-1. This is highly correlated to each other. And that almost for all of these populations, they're very closely tied to each other, which makes perfect sense because for most countries, they're going to be steadily increasing. And so they're probably almost exactly correlated. But we can look at these populations, and if you look at the area, it's only somewhat correlated. And that's because in some countries, they have a very high population, but a small area, or vice versa, a small area and a very high population. So there isn't a 1-to-1 correlation there. But it's hard to really just glance at this and understand everything that's there. We could just visualize it and it would be a lot easier. So let's go ahead and do that. Let's go down here. We're just going to visualize this using a heat map, basically. So we're going to say sns.heatmap and an open parentheses. And the data that we're going to be looking at is df.core, correlation. And then we also want to say anote equals true. I'll kind of show you what that looks like in just a little bit. But let's do plt.show. And this will be our first look. And I need to say show, not shot. We can get a little glimpse of what it looks like, but this looks absolutely terrible. Let's change the figure size really quickly. So I want to make this much larger than it already is. We'll do plt.rc params, oops, right there. Do an open parentheses. And then right here, we're going to do in quotes, we'll do figure.fig size. This actually needs to be in brackets, I believe. Just like this, not parentheses. And we'll say fig size is equal to, and now we can specify the value that we want. Let's do 10,7 and see if this looks any better. No, that doesn't look good. Do 20. Okay, that looks a lot better. And, this is just a quick way because it gives you basically a color-coded system. Highly correlated is this tan, all the way down to basically no correlation or negative correlation even, which is black. So when we're looking at these 2022 populations, and these are our populations right down here on this axis, we can see that all of these are extremely highly correlated very quickly. Whereas the rank really has nothing to do. It's negatively correlated. It doesn't really have anything to do with it. Then for the population and the world population percentage, it again is quite correlated except for the area, density, and growth rate. So I find that really interesting that, the density, the growth rate, and the area aren't really all that associated or correlated with the population numbers. That is, I kind of would have assumed that on some level they went hand in hand. The area does, which, again, makes sense. Larger area, larger population, that kind of thing. But even density, I guess density and growth rate. Growth rate I can see because that's a percentile thing. That could be definitely not correlated. But I thought the density would be more correlated than it is. All that to say is this is one way that you can kind of look at your data, see how correlated it is to one another. That can definitely help you know what to analyze and look at later when you're actually doing your data analysis. Let's go right down here. Something that I do almost all the time when I'm doing any type of exploratory data analysis like this, I'm going to group together columns, start looking at the data a little bit closer. So let's go ahead and group on the continent. So let's look at it right here. Let's group on this continent because sometimes when you're doing this EDA, you already know kind of what the end goal of this data set is. You know kind of what you're looking for, what you're going to visualize at the end. That really comes in handy when doing this. But sometimes you don't. Sometimes you're just going in blind. And so far, we've really just been going in blind. We're just throwing things at the wind, kind of seeing some overviews, looking at correlation. That's all we've done. Now I kind of want to get more specific. I want to have like a use case, something I'm kind of looking for, not doing full data analysis, or not diving into the depths, but something we can kind of aim for. So the use case or the question for us is, are there certain continents that have grown faster than others, and in which ways? So we want to focus on these continents. We know that that's the most important column for this use case, this very fake use case. So we can group on this continent and we can look at these populations right here because we can't really see growth. You can see a growth rate, but the density per kilometer, we don't have multiple values for that. It's just a static one single value. Same for growth rate, same for world population percentage, but we have this over a long span, many, many years, 50 years of data here. So this, we can see which countries have really done well or which continents have really done well. So without, talking about it even more, let's do df group by, and then we'll say continent. Oops. Let me just copy this. I'm not good at spelling. We're going to say df group by, and then we'll do .mean. And we can just do it just like this. And now we have Africa, Asia, Europe, North America, Oceania, and South America. Okay, so if I'm being completely honest, I knew most of these. All right, I'm no geography expert, but I knew most of these. I don't know what this Oceania is. I genuinely don't know what that is. So let's just search for that value and see. We'll come back up here in just a second, but I want to kind of understand what this is. So we're going to df, and we'll say continent. Let me sound that out for you guys. Then we'll do .string.contains. Oops, contains. Good night. And then I want to look for Oceania. And let's run this. Oh, I need to do it like this. Now let's run this. So now we're looking at our data frame and we're seeing when the values have this continent as Oceania. Okay, so these look like islands, I'm guessing. So we have Fiji, Guam, New Zealand, Papua New Guinea. Yeah, these look like all, I'm guessing based off the continent Oceania. Oceania. Guys, this is tough for me. Okay, I'm doing my best. This is part of the EDA process. I don't know what that means. I don't know what Oceania. Jeez, I'm just gonna call it Oceania. That's so wrong, but it's so easy for me to say. I now am seeing this and it looks like islands, which would make sense because for their average, they have the highest average rank, and I'm guessing that's because they're just mostly small continents. So let's order this really quickly. We're gonna do .sort _ values, do an open parentheses, and I want to sort on the population. We're just doing the average population. We'll do by equal. So on the average population, and we'll do ascending equals false. So when we're looking at this average or the mean population, Asia has the highest population on average. Then we have South America, Africa, Europe, North America, and then Oceania at the very bottom, which makes perfect sense. Again, small islands. World population percentage. So each of those countries in Asia makes up about 1% on average. Really interesting to know and just kind of look at this. And the density in Asia is far higher than almost double every single other continent. Really, really interesting, actually, now that I'm looking at this. But, that's something that I would actually look into. And I would be like, what is this Oceania or Oceania? What does that mean? And, let me look into that. Let me explore that more because I want to know this data set. I'm trying to really understand this data set well. But what I want to do now is I want to visualize this because I just feel like looking at it, it's hard to visualize. And again, the use case that we're saying is which continent has grown the fastest. Like it could be percentage wise, it could be, as just a whole on average. Let's take a look. So we're going to take this and let's copy it like this. Let's bring this right down here. So let's look at this. So if I try to visualize this, and let's do that. Let's do df2 is equal to, because I already know it's not going to look good just based off how the data is sitting. We can do df2. Oops, what am I doing? I don't need to do that, but I will. Okay, df2, and we'll do df2 dot lot, and we'll run it just like this. As you can see, Asia, South America, Africa, Europe, North America, Oceania. We can kind of understand what's happening, but these are the actual values that are being visualized, not the continents, which is what I wanted. In order to switch it, and it's actually pretty easy, and this is something that is good to know. We can actually transpose it to where these continents become the columns and the columns become the index. And all you have to do is say df2 dot transpose, and we'll do this parenthesis right here. And let's just look at it, and then we'll save it. So now all of these columns are right here, and all of the indexes are the columns. So let's say df3 is equal to, and I'm just doing that so I don't, write over the df or my earlier data frames. So now we have this data frame 3. So now let's do data frame 3.plot, and it should look quite a bit different. Whoops, I didn't run this. Let's run this and run this. And as you can see, this does not look right at all. And the reason is because we're not only looking at the correct columns. We have this density in here, word population percentage, rank. We don't need any of those. The only ones that we want to keep are these ones right here, this population. Now we can do that, and we can just go right up here. This is where we created that data frame 2 that we transposed. We can go right up here, and we can specify within this, we actually only want specific values. Now we can go through and handwrite all of these, and by all means, go for it. But I am going to go down here. I'm going to say df.columns, and I'm going to run this. It's going to give us this list of all of our columns. And I'm just going to, you can just copy this, and you can put it right in here. I think I need a list with it. I think it needs to be like this. If I'm, let me try running this. Okay, so this worked properly. You can do it just like this, or a little shortcut if you want to do it like that. If you want to do a shortcut like, I would hope you would just do df.columns, just like how we looked at down here, except since this is an index, we can search through it. So we can just say 0, 1, 2, 3, 4. Okay, so we can do 5 up to 13, because I think it's 7. And we'll just, let's see if this works. It may not. I may actually need to go like this. Let's see. There we go. So you can just use, the indexing to save you some visual space, gives you the exact same output. So now we have this. This is our df2. Now let's go down and transpose it. So now we just have these populations, and we have our continents right here. And then now we're going to plot it. And this looks good, although it's backward. Okay, it's backward. So what I actually want to do is not this. That is a quick way to do it, although not the best way to do it. So I'm actually going to copy all of these, and although I said it would save us time, it did not at all. So I'm going to put a bracket right here. I'm going to paste this in here, and I'm literally going to change these up. I might speed this up, or I might just have you sit through this because, this is an interesting part of the process, and I want, you to get the full experience. You know what? Now that I'm talking about it, that is what we're going to do. You guys can hang out with me. This is a good time. We have 2010, 2015, 2020, and 2022. Now let's run it. What did I do? Oh, too many brackets. There we go. So now it's ordered appropriately. We have 1970 all the way up to 2022. This is how we want it. Let's transpose it appropriately. Let's run it. And now we basically have the inverted image of this. Now just at a glance, and we haven't done anything to this except for literally what we are looking at. At a glance, we can see that from 1970, China, Asia and China are already in the lead by quite a bit. And it continues to drastically go up, especially in the 2000s. Like right here, it explodes, like just straight up. Then kind of starts going up and just leveling off. Every other continent, especially Oceania, is just really low. It never has done a bunch. Let's see, look at green. Green has gone up from, let's say 0.1 up to about 0.2. So they've almost doubled in the last 50 years. And again, you can just get an overview, a high level overview of each of these, continents over the span of this time. So this is kind of one way that we can, look at that use case. We're not going to harp on that too long. I just wanted to give you an example. Like, when you're looking at this, sometimes you'll have something in mind of what you're looking for and you go exploring and just kind of find what's out there and find what you see. The next thing I want to look at is a box plot. Now, I personally, I love box plots. They're really good for finding outliers. And there's a lot of outliers. I already know this because the average, the 25th, 50th percentile are very low. And then there's some really just big outliers. But for your data set, it may not be that way. And those outliers may be something that you really need to look into. And box plots have been something that I've used a lot where I found those outliers that way and started to dig into the data to find those outliers and, came across some stuff that I'm like, oh, I have to clean this up. I have to go back to the source. Really, really powerful and useful to be able to find these. So all you have to do is df.boxplot. Yeah, let's take a look at it. And this already looks good as is. Maybe I'll make it a little bit wider. Let's do fig size. Oops. Sorry. Fig size is equal to, let's try 20 by 10. Okay, that didn't help at all. I apologize. Thought it would, but let's keep going. What this is showing us is that these little boxes down here, which are actually usually much larger because you have a more equal distribution of numbers or values. In the small value, this is where our averages lie. This number right here is the upper range. And then all these values, all these open circles, those actually stand for outliers. So we're looking at the 2022 population. There's a lot of outliers. Now, for our data set, knowing our data set is really important. Outliers are to be expected, especially when most countries or continents are small. So we're looking at, all of these little dots are outlier countries or outlier values, which each value corresponds to a country. So if this was a different data set, I would be, searching on these and trying to find these so that I can see what's wrong with them, if anything, or if they are real numbers. Like if this was revenue, everyone's revenue is way down here, and then there's one company that's making like $10 trillion, that'd be an outlier up here. And it would definitely be something that you want to look into. For our data set, knowing that, we're looking at population, this is more than acceptable and oddly enough. But that's what box plots are really good for, showing you some of those quartiles, the upper and the lower, as well as denoting these points that fall outside of those normal ranges for you to look into. So really, really useful. So now let's go down here, pull up our data frame again. And we've kind of just zoomed into the whole EDA process. There was one last thing that I wanted to show you. And this is the very last thing that we're going to look at. We're ending on really a low point, if I'm being honest, because the last kind of stuff was much more exciting. But there is something df.dtypes. Oops, let's do df.dtypes. And we'll run this. Now, just like info, it gave us these values, but we're actually able to search on these values now. So these object, float, and integer, we can search on those, which is really great because we can do include, equal, and we can do something like number. And none of these are numbers, right? Or none of them explicitly say number. But when we run it, I'm getting an error, series object not, oh, that's because I'm doing, dtypes is for a series. We need to do select underscore dtypes. Now let's run this. Now it's only returning the columns in this data frame where the data types are included in this number. So you won't see any, country or any of those text or the strings. If we wanted to do that, we go in here and say object and run that. And this is another really quick way where we can just filter those columns to look for specific, whether it's numeric, we could even do float in here. And so now it's not including that rank, which was an integer. So we can specify the type of data type and it'll filter all of the columns based off of that, which, when you're doing stuff like this, it is good to know what kind of data types you're working with and look at just those types of data types, because there might be some type of analysis you want to perform on just that, whether it's numeric or just the string or integer columns within your data set. So again, ending on a low note, I apologize. Everything else that we looked at, all those other things that we looked at are all things that I typically do in some way or another when I'm looking at a data set. Exploratory data analysis is really just the first look. You're looking at it, you're going to be cleaning it up, doing the data cleaning process, and then you're going to be doing your actual data analysis, actually finding those trends and patterns and then visualizing it in some way to find some kind of meaning or insight or value from that data. And again, there's 1,000 different ways you can go about this. It does typically depend on the data set, but these are a lot of the ways that you'll clean a lot of different data sets. And so, that's why I went into the things that we looked at in this video. So I hope that you guys liked it. I hope that you enjoyed something in this tutorial. If you like this video, be sure to like and subscribe, as well as check out all my other videos on pandas and Python, and I will see you in the next video. What's going on, everybody? Welcome back to another video. Today we are back with another data analyst portfolio project where we will be scraping data from Amazon using Python. Now you may be asking, do I need to know web scraping to become a data analyst? And the answer is no, you absolutely don't need to know it, but it is a very cool skill to learn. And in fact, I have used it in my job in the past. And so it is useful, but you really don't need to know it. Something that it is used for is kind of creating your own data sets. And we're going to be looking at one where you can create your own data set today. But there are a lot of other uses for web scraping, and I'm sure I'll talk a little bit more about that while we're actually walking through the project. One last thing I want to say before we get started is that this is most likely an intermediate project. So if you are just now learning the basics of Python, this might be a little bit challenging for you. But I still recommend going through it because I will do my best to walk through everything, every single step of the way, and kind of explain all of the concepts. And so you can still learn something even if you aren't super good at Python right now. With that being said, let's jump over to my screen and get started on the project. All right, so we are going to get started. And if you didn't watch the last project, I had people download Anaconda. We use Jupyter notebooks, and I'll show you how to get to that in just a second. But I'll leave this link in the description if you haven't done that already and you are just doing this project. But you'll download Anaconda, download it super easy. And you're going to open up Jupyter Notebooks. I'll launch it right now. I already have it open, but I'll open up another one just for, the purposes of demonstration. What we are going to do today and what people voted on, there was like 8,000 people that voted in the poll that I made of what data you wanted me to scrape. There was like Amazon, cryptocurrency, weather, something else, I don't remember. Overwhelmingly, like 70% of people, maybe even 80%, don't fact check me on that, voted for Amazon. And so I'm going to do it. Now, there are many things that you can scrape off of Amazon, just a ton of stuff. And I'm going to show you how to do it. I'm going to show you how to make it useful, how to make a data set. And it's going to be really interesting, but there are lots of other ways to do this. And so I think, and I have already kind of created it, I'm going to show you how to do it off of this page when you're actually in an item and you can scrape, basically anything in here. And I'll show you how to do that. Another thing that is a little bit more advanced, and that's why this first video is starting off, I think, on the more easy side. It's not easy, but it's easier. The next video that I'm going to make is how to actually do basically do multiple items, right? So this item, this item, this item, this item, and then traverse through the different pages. So there's 20 pages. You want all of that data. How do you get all of that? That'll be the next project. I don't know when I plan on doing that. I have it like 90% of the way done, but I had this one completed. And so I wanted to get that out to you guys now, but that'll probably be the next project. I think that is much more difficult. And so if you can understand this one and you get it and you understand it, then the next project you should be able to understand too. Is just a little bit more complicated. So with that being said, We are going to actually get into the project. I'm going to delete one of these. All we're going to do is go to new, do Python 3. It'll open up a new one. We'll call this Amazon Web Scraper project. That's what we'll call it. Did I spell it right? Perfect. The first thing that we need to do, or that we should do, is upload or import our libraries. So I'm going to say import. Oops, what am I doing? It's off to a terrible start. There we go. Import libraries. Now, I'm not going to write out all the libraries. I have some things that I'm going to be copying and pasting throughout this. There's only a few things that I'm copying and pasting. You can take a quick glance. Some of the things that I just don't want to waste time on, because this could be a long video. I don't know. I don't want to waste time on stuff like this. And so, I'm just going to copy and paste it. You guys are going to, there will be a link below if you haven't clicked it already that will go to the GitHub page where you can literally have all of this code already written. I do recommend writing it all yourself because you will learn it much better, I promise, because then you'll make mistakes and you'll figure it out and all that good stuff. But you will have that code available, so just go copy and paste it. That's what I would do. But what we are going to be using today is something called Beautiful Soup, requests. Then we're going to be using time and date time, and a potential one if you want to get, and I'm going to show you this at the end. This is not really part of the project. It goes above and beyond. But this library right here is for sending emails to yourself. And I'll show you how you can use it if you want to. I already have the whole code written out. You can just steal it and try it out yourself and see if you can get it to work. But this one is not as important. I'll put it down here. So let's move on. Now, one thing I want to say before we get too into it is that, well, give me a second, is that right here in front of me is a different laptop. Now, it took me a solid, I would say, 10 hours or so to write all of this. It took over the course of like 2 weeks in my free time. I'd pick it up. It took me a solid, 2 weeks on and off, an hour here, an hour there to finish this project. And I made a ton of mistakes and messed a bunch of things up, and I finally got it to work, after a bunch of revisions. That's typically how things go when I do projects. And so I'm about to give you a streamlined version of this because I have all the code right down here. And so I'm going to be glancing at this a lot, just so I don't make this video 20 hours of trying to remember all the code off the top of my head. I have it written out already. I already did the project. It works. It's beautiful. It's a good project. So I don't want to waste your time. And I just want you to know that, nobody should be able to do this off the top of their head in an hour. Most people won't. It takes time. You make mistakes. But let's get started on the project. Now, in this, what we're going to have to do is we are going to have to tell Beautiful Soup and requests where we are actually getting this data from. What website, what is our computer, some information from our computer. I'm going to, again, there's going to be a little copying and pasting in here because you will never, ever, ever need to know this. But right here, we're going to basically connect to the website. So I'm just going to say connect to website. And we're going to say URL is equal to, and let's go get our URL. So we have this right here. So literally just go up here, do, Control A, copy that. Oops, that's the actual project. Get rid of that. Paste it in here, and that is our URL. We will use that in just a second. What am I doing? Let me just get some room here. And then what we're going to need is something called headers. Now, again, you will never, ever, ever need to know this. So I'm just going to say headers. What I'm going to do is I'm going to copy this. I'm going to show you how to get this really quick, but it is something called headers. So let me show you how to get this and why you don't need to know any of this. So what this headers is this something called a user agent. You need to do this for your computer. And you can do that by going to this link right here. So I'm going to put this link in the description so that you can go and get that. And there's something right here called the user agent. So all you have to do is copy this, just like this. Do copy. I'm going to go back here and I'll show you that I'm going to copy it in. It'll be the exact same. So there you go. It's the exact same. All of this extra stuff, except encoding, except this HTML stuff, connection, close, all that. You don't need to know any of it. I promise you'll never come in handy ever in life. Actually, there'll be one person who that becomes in handy for, and then they'll message me. But we are now connecting using our computer, using this URL. And then what we want to write is we want to write page, and we're going to say equals, and this is where we start using these libraries. So we're going to use requests.get, and we are going to pull in that URL, and we're just going to say headers is equal to our headers right here. So we have this, and this is where we're going to actually start getting the data, bringing in the data. And it's not going to look like that at first, but I'll try to print some stuff out as we go along the way so that you can kind of see what it looks like and how we're going to kind of make it more useful, because it comes in very dirty when we first get it. And some of the things I'm going to show you will just help clean that up. And before we actually go any further, I don't want my head to be here for the entire time. I'm going to get rid of myself so you can just see the page. It's less distracting. I hate when I feel like people are always watching me, so I want people to just focus on the code. So I will see you in a little bit. Let's get back into it. All right, so what we are going to do is we are actually going to start using the beautiful soup library. All right, so we are going to say soup1 is equal to, and this is where we actually start bringing in beautiful soup, and you guessed it, you're going to say beautiful soup, and then in parentheses, we're going to do page.content. And again, these aren't really things that you need to remember or need to memorize. We're just pulling in the content from the page. That's really all we're doing right now. And it comes in as HTML. So we're gonna do html.parser. And let's see if I can print out, actually, let me just do soup1. I don't like doing upper caps on stuff. Let's see if anything prints out real quick. So we are literally pulling in all of the HTML. And let me go show you really quick, because we're going to get to this in a second anyways. If you come here, this is a static page basically written in HTML. If you have never seen HTML before, actually a lot of this is, just stuff that most people will never use. It's just good to know. Some of this stuff is good to know. So as you see, I'm scrolling on this right side. By the way, I did right click and inspect, or Control-Shift-I, whichever one works better for you. But as I'm scrolling over this, you should see it kind of highlighting different areas. It's hard to kind of get what you want. Let's say we want this title. What I can do is I can click select element, go right here, and then we can select like the header or the title of the page. Now, I just wanted to show you though of what we're pulling in. So we're pulling in this doc type HTML. All of this is coming in. So that's what this is right here. This doc type HTML, and we're pulling every single thing in. That is what we're doing right now. So let's go down a little bit. Let's do soup2. We're just going to do a very, an upgrade to soup1 basically. We'll do beautiful soup again. And then we're going to do soup1. So we're pulling in that content again. So that's soup1, and we're going to do .prettify. If you don't know what that is, it is common in a lot of different languages and a lot of different stuff. It just makes things look better. That's really all it is. I don't know why I'm using double quotes. I don't know why you can do single ones if you want. And now let's do beautiful soup 2. And it should just be better formatted. And let's see if that's true. And it is. So before, if you can tell, it didn't have basically any formatting. It has a little bit of formatting now. It'll help in a second, and you'll see that. But now what we want to do is go back, and we want to actually get the data that we want. Now you can get any data you want. I'm going to show you simple things, really, really easy, in my opinion. it gets more difficult the more complicated stuff you start pulling. And you'll understand that as we go into it. So what I'm going to do is I'm going to select this, and I'm going to select this, the title. I want that. And so if you do span ID, it's equal to product title. So we need to remember that. Class, we don't need to know class, I believe. We're going to be using that ID, this ID equals product title. So that's what we're going to be using. Class will come in the next video when we start looking at these, but not in this one. So let's remember ID equals product title. So let's go back over here. So we have this soup2. It's basically all of that HTML in it right down here. That is what we're pulling in. So we need to kind of specify what we actually want. So let's say title, that's what we're going to be getting. And we're going to do soup2. So taking all that content, and we're going to do find, and we're going to do open parentheses. And we're going to say we want to find that ID where it's equal to product title. And then we're going to do dot get underscore text, and then we're going to do open parentheses. So now let's let's print the title and see what we get. All right, so that is exactly what we're looking for. It's funny got data MIS t-shirt. That is what we're trying to pull in. So that's perfect. That's exactly what we want. We don't, let me just do this. Save me some time later on. We don't only want the title, we are also going to be pulling in the price. So if you can guess, we'll be doing a data set on the actual pricing. And so let's go back here. We're going to again use this right here, and we're going to go to this price. And it says, again, we're going to look at this ID. The ID equals price block underscore our price. So fairly easy. You can copy this. I'm just going to write it out. We're going to say price is equal to soup2 dot find. And then it's going to be, again, ID is equal to, and then it's going to be price block underscore our price. Did I spell that right? Excuse me. There we go. And the exact same thing, dot get underscore text, parentheses. And there's a get text, there's a get all, or get all text. So, that get text is a specific thing that we are using. We might use a different one later on, but that is what we have. So now let's print the title and print, why do I have all this? Too much space. So let's print the title and print the price. Now let's see what we get. Okay, so we have our title and we have our price. I mean, I don't know what all this white space is over here, but it looks like there's a lot of white space over here. We'll have to get rid of that in a little bit as we clean it up a little bit. You can, if you want, do things like you can get, and this is up to you. I'm not going to do this right now, but I'm just going to show you how to do it. You can get this where you're pulling in the ratings, which is, if you want to look at like how the ratings over time or what ratings are for specific products, that can be really useful. You can pull basically anything. You can go down to the product details and look at dimensions, anything you want on this page. It is static, so you can go in here and pull anything. You just have to pull it from the HTML, know where you're looking, pull it in. And now when we go back here, excuse me, I'm going to show you now kind of how to use this, right? Because we have this, but how are we going to use it? That's kind of the important part, I think. First thing we need to do is clean this up a little bit, because it just is, if we try to use this, it wouldn't be super useful because it's just a little bit dirty. It's not super clean. So what we want to do is let's start with the price. Why not? We're going to say price dot strip, and that's just going to take basically the junk off of either side. And so let's run that real quick. So this is what we have, but what we can also do is, I don't want that $sign. I just want the numeric value. Later on, we are going to be putting this, and we are going to be creating a process to put this into an Excel file. Again, we're trying to create a data set. I don't want you to have to copy and paste stuff. It's all going to be automated basically to input this data into an Excel file for you or a CSV file for you. So, think about making it useful in a CSV or in an Excel later on. So what we can do is do a bracket, and we're going to do 1 and then everything after that. So basically it's just going to take everything from the first position onward. So let's run that, and there we go. So let's just say price is equal to price.strip, and pull, just do everything after that first, not value. What am I saying? What's the word for that? I can't remember the word. The first space. That's not the right word, but all right, let's do the title. This is basically going to be the exact same thing. Super easy. So we're just going to do title.strip and open parentheses. And we can, if you want to do this exact same thing. So now we have it. It's a little bit cleaner. So this is what it originally looked like. And now this is what it looks like. So, nothing super crazy, but, something interesting to know. Now, we are about to, in the very next part, what we are going to do, and let me just add a few of these because it makes me feel better. What we are about to do is we're going to create our CSV to insert this data into the CSV. And then later on, what I'm going to do is show you kind of how to automate this process to pull this data, to create a data set, right? Just pulling this one time and putting it into a CSV really doesn't do anything. You can just copy and paste that and save yourself a lot of time. What I'm going to show you is basically doing it over time and just having it automated in the background. That is what I'm going to show you. I guess a spoiler. But what we need to do is we need to create the CSV, insert it into the CSV, and then create a process to append more data into that CSV. I'm doing a lot of talking. Let's do some writing. So what we need to do is we're going to use, I should have done this at the top. Maybe I'll go back and add that later on. We're going to do import CSV. Now, in a CSV, what you want is you want headers, and then you want the data, right? So for our headers, and we're going to call it header, we're going to do a bracket, and let's make the first one a title, because that's going to be, we can call it title, you can call it product, whatever you want. I'm just going to call it, because I've been using title, I'm going to call it title. And then we'll also have price. Now we need our data. So I'm going to say data is equal to, now this is important. Right now, how our data is, and I can do this right here, we're going to do type title, or no, let's do type price. So these are strings, and that's important to know. Again, I don't want to get too much into dictionaries and arrays and lists and strings and all these things, but this is a string, and you can't put that. Right now, it's not super usable. What we're going to do is make this a list. And so I'm doing an open bracket, and I'm going to say our data is title, comma, price. Oops. Price. Now, oops. If I do type, of data, I'll just run that. It's a list now. And this is important because you can run into a lot of issues with this stuff. It's really important to remember what type, how do I say this? How your data is. Is it a list? Is it an array? Is it a dictionary? What is it? These things are important. They do play a big impact, especially with this type of stuff. So just wanted to show you that really quick. But what we are now going to do is create a CSV. You're going to create an Excel. I call it an Excel CSV, whatever you want to call it. So what we are going to do is we are going to say with, and we're going to say open, and now we're going to name our file. You can name this whatever you want. I'm going to call it Amazon Web Scraper Dataset. That's real long, .csv. And then we're going to do underscore W, and that means write. Oh, whoops, that's not right. Just like I was wondering why that was in black. So we're going to do W, which means write. And then we're going to do new line. If you don't know what new line is, all that does is when we insert the data, it doesn't have a space in between each CSV. And then we are going to do encoding is equal to, UTF-8. And that is it. And we'll just say as, let's do F. So some of that stuff you don't need to know. Some of it's useful. This W you definitely need to know. This new line is good to know. And I'll take it. I might take it out just to show you what it actually does, because it's annoying if you don't have it, I promise. But you know, that new line is important. This encoding, you know, good to know. I think that's by default is it's like that. Anyways, what we're going to do now is we're going to, it's something within the CSV, library. So we're going to do something called CSV writer and CSV.writer. And we're going to do open parentheses, and that is that. And we'll just call that writer. And then we'll do, this is where we need to actually create the header. So we're going to do writer dot write row. And this is just for the initial import or not import, the initial insertion of the data into the CSV. This is what's important. The next one that we're going to write is for when we're actually appending the data, which is going to be a little bit different. But anyways, we're going to do write row, open parentheses, and this is where that header is going to go. So we're going to, these headers are going to be the title and the price. And then for our last one, we're going to actually write the data, which is this data right here. And we're going to say writer.write row, and we're going to do data. So this one, we are creating the CSV, and then we are inserting the header and inserting the data. So super easy. Yeah, I think that's fairly straightforward, right? Now let's do this and let's see what happens. So I just ran it. Let's go over here, in here somewhere, Amazon Web Scraper dataset. Let's open that up. And there we go. Oh, geez. This isn't good. Can't verify my my subscription. Why does it say $6.99? I'm going to go back and look, but I think I know the issue. But this is exactly what we want. Now, of course, we want more data and maybe a little bit more useful data. And I'll show you how to get that in just a second. But we just created that out of thin air. That was not, I didn't have that saved before. So we have this data set, and the issue is that I ran this multiple times. So now it's $6.99. If I do it again, it's $99. And if I did it again, it gets rid of everything. So I'm just going to run this again, now everything's back to normal. Okay, so now if we run this, it's going to overwrite this Amazon Web Scraper dataset.csv, and it will put the data in properly. So there we go. Oh, geez. Guys, this is embarrassing. I'm embarrassed. No, I don't want this. Okay, perfect. Yeah, guys, if you can't tell, I'm in need of some. I'm in need of some help here. But I'm just kidding. I'm doing fine. I don't know why that why I don't have my subscription activated. It's not going to matter for this video, I guess, but that's really random. So we got what we need. That's perfect. Now, what we want to do after this, I guess actually what is important is some more useful data. Something that I like to do a lot when I do this type of stuff is I like to have some type of date stamp or some type of time stamp to know when I collected this data. It usually comes in handy later on. I have never regretted putting it in there. I'll show you really quick how you can do it. You can do import date time. Jeez, I hate having to format stuff like that. And what you can do is you can do date. Let me get date time, and you do .date .today open parentheses. And that is going to give us this right here. And so we're just going to do today, that's what we'll call it, is equal to this. And we'll say print today. And there we go. So that is today's date, is the 21st of August in 2021. So today is now this. So actually, I'm going to get rid of that. I'm going to put it back up here. I'm going to put it right there. I'm going to run it again. Let's add this right here. We'll call it date, and then we'll add today. And we'll just run this again. And what we can do, just to check the data without having to open up the data every single time, which is super annoying, is we're going to use pandas. Again, I should have imported this at the top. I'm just kind of, I'm not doing this off the top of my head, but I didn't have it 100% planned. So import pandas, and we're just going to say pd.read_csv, and then we'll read it in. What you can do, or what I often do, is I go to properties and I go right here. And we'll say boom, boom, /, this right here. This I am doing off the top of my head. I don't do this often. I think I have this memorized by now. I hope. And then we'll do print. Oh no, we don't have to do print. We'll just do this. What do I do? Let's actually call this data frame, and we'll do print data frame. Let's see what happens. Perfect. Okay, so what we have now is our new header, our new data that we added in there. So we have our title, we have our price, and we have our date. Now, again, you can customize this, whatever you want to add. Go back here, find what you want. Do you want it to make sure that it has a men's option or different colors, or you want to pull in this information? Whatever you want. It really does not matter. Just matters that, you get what you need for whatever purpose, whatever you're making this for. This is more of an introductory video to how to scrape data from Amazon. The next video will probably be a little bit more difficult and in-depth, but this is kind of, let's get you guys started. So we now have this, and this is beautiful. Now, something that you want to do when you're scraping data and you're getting, data over time, and that's kind of what we're doing. It's going to be almost like a price tracker over time, is you want to then append data to this. So we can't only create it, and that's what this does, because if I run this 100 times, it'll only give me this first row. We need to now append data to this. So let's pull this down here. Again, I haven't added a bunch of notes. I'm going to say now we are appending data to the CSV. I haven't added a ton of notes. I'll try to go back maybe afterwards and add some notes for people who like to read notes. So what we are now going to do is we're going to change this W to an A+. Now this is going to be how we append the data. And we no longer need the header. So we aren't going to do the header anymore. And there we go. So now instead of creating that header again, creating that first row of data again, we are ignoring the data, and we're now going to the next nearest free row and appending data, which means to add on data to that. And so if I run this, which I'm not going to right now, why not? I can run it, and then we can read this in. So now there's our data. I'll run it a few more times. I ran it like 3 or 4 more times. I run that in, and there we go. Now it's all the exact same data, super boring, but very, very good to have. Now we don't want to have to come in here and run this every day. Let's say we're going to do this daily. We don't want to have to come and run this every single day, right? We want a way where it does it while we sleep. It does it in the background of our laptop, and is easy to do, right? I don't want to come in here every single morning set an alarm on my phone every single morning, come in here. I want to automate this. So how are we going to do that? Give me 1 second. If you didn't know, I have 3 kids and one of them is waking up. I'll be right back. All right, I think he is asleep. At least let's hope he's asleep. So now what we're going to do is we're going to put this all into this check underscore price. Now, you may never have used, oh geez, what are these things called? Oh my gosh, super used all the time. You'll know what it is. Not a function. I don't even remember what it's called. Maybe there's a function. I can't think. I'm having like writer's block or whatever that is. We're going to put it all in here, and then we're going to be able to use this price check later because we want to be able to automate this. So let's go back all the way up here. We are going to use this. So let's copy all of that in. And, oh, geez, I hate this. All right, everything just like that. So this pulls in our data, pulls in, pulls in all of our data down to the title and the price. We want to make it look right. So we're going to put it right here. So now we have it formatted properly. We want to add our date time. Do it just like that. I don't know if there's a better, I'm sure there's a better way to do this. Then we need this right here. And just like that, like that. So now we have our header and our data. And then we want to pull this in right here. Boom, boom, boom. Okay. So everything that we just wrote out, we are now putting into this check price. You can call it whatever you want. Doesn't matter. But let's run that, see if we get any errors. We don't. So this is now good to go, basically. What we are going to use this for, and what this is going to do is we are going to put this on a timer. You know, have you ever wanted to like check something once a day, once every 10 seconds, once a minute, whatever you want, and you don't want to have to actually pull up your phone and look at it? This is how we are going to do that. So we had something called, let's see, time, this library time right here. That's what we're going to use right now. So we're going to say while true, and go like this, do a colon. We're going to say check underscore price. That's what we just wrote out. And we're going to do time dot sleep. Now, this is completely up to you how much time you want to put in here. For the purposes of demonstration, I'm going to put 5 seconds, which means every 5 seconds, it is going to run through this entire process. And so let's run this really quick. And I'm going to run it for, let's say 30 seconds. And then I'm going to pull this in right here. So we just looked at it earlier. We had 5 rows of data, right? What we are going to do is in just a second, I'm going to stop this, maybe after 30 seconds or so, and we're going to see how much data is in there. And let's stop it right now. It's been going far enough. And now let's run it. So now we have 5, 6, 7, 8. So I guess I ran it for 20 seconds. We can, that was for demonstration purposes. I've never do anything every 5 seconds unless it was like Black Friday on Amazon. We can put this as long or as short as you want. You can run it every second if you want. That doesn't make sense to me, but you can. What we can do is do a little bit of math. And I don't know this off the top of my head, so I'm going to do the math with you live. Pretty exciting stuff. Got the calculator out. So there are 60 seconds in a minute. And this goes by seconds, by the way. And you could do, you can do some string up here of calculating this, but I'm just going to put in the number because it's easier. Maybe not easier. I'm just going to do it. There's 60 seconds in a minute. There are 60 minutes in an hour. So So that's 1 hour. And we can do 24 hours in a day. So that's 86,400. I believe. Did I read that right? Oops. Did I read that right? Yes. So this now, if I ran this, and I'm going to, this is going to check the price every single day. And this is the entire point of this of this project. Not the entire point, but this is a big part of this project is we want to create our own data set. Now, something that I personally really love is a data set that has, that I can do some type of time series with. Now, this is not exciting. It's probably not super exciting for this, right? But you get the idea that if this price were to change, we would then see that reflected in the data at some point. You can do this on any item you could ever imagine on Amazon. It's the exact same process. And some items change often. This t-shirt will most likely never change. And so, again, this is for demonstration purposes. The code itself will be nice to put in a project, although the data set that you get from this probably won't be the best, I would imagine. But notice that this is running. I can then minimize this, and this can run on my computer basically as long as my computer is working. One thing I will say before I go on to some more stuff, one thing that I will say is that I personally, when I did this when I created this, I did something similar, and I put this in Visual Studio Code, and I didn't put it in Jupyter Notebooks. That's a personal preference. I would look into that if that is something that you want. I think Visual Studio Code is a little bit easier for automating these types of tasks. But for illustrative purposes and for demonstration purposes, you cannot beat Jupyter Notebooks. That's why I did it. So with all that being said, that is basically the end of the project. Now, I'm not going to stop this and read it again, but you get the point. We now have a data set that, all this again, that now has data. I'm getting out of here. Oh, geez. It's hounding me. Let me get out of here. Oh, no. This is embarrassing, guys. I'm embarrassed. We now have a CSV file with data in it. Now, you run this in the background of your computer. You can do that. I have done it. I've ran it for weeks. I have ran it for months. If you restart your computer, just come back in here and restart running this process. It's the same for any automated process unless you start using some online automation service, which will run it regardless of your computer. They do it, either in the cloud or on some server. So, that this is a really good option. Again, if you restart your computer or something happens, you lose connection, just come in here, run this through the script again, except for the one where it deletes all your data. Don't run that one again. Only run that one time. And then you will, and in fact, what I would do is then I would just comment this out, right? I'd come in here and I would just comment this out, so that anytime I come back in here, I would never accidentally delete all my data. But that is what this project does. Now, something really interesting, something that I have done in the past that I thought was really cool, really useful. I actually did it for some watches that I was watching, especially on Black Friday. It's when I used it. I was interested in a price drop or a specific price change. And what I did is I said, and I don't know. So what I basically did is I said, if the price is lower than, let's say we wanted to drop below $14, it would then send an email. And I'm going to show you the script that I used. It still works. And if this is something that you are interested in, this could be a completely different project. I just think it's interesting and I wanted to show it to you. Although I wouldn't say this is part of the final project. Let me just come in here and we're going to create this. Super simple. Well, not super simple. We're sending a mail. We're connecting to a server. We're using Gmail. We're logging into our account. That is my email. You will not get my password. We're creating the subject, the body. We configure or just kind of create this message, and then we send a mail. So then I have this define or this send mail. I'm blanking on what this is called. I'm going to call it a function, but that's probably not right. So if that price drops below a certain point, it'll send me an email. I have used this, and I used it and was able to buy a watch that was like, let's say $140 for like $90 on a Black Friday sale. And I was really, really happy about that. So this can be used in that way as well. Not something you have to write into your project, just something I'm going to include down here. If you want to try it, I think it's super interesting, something really fun. Really fun to mess around with. I enjoyed this. So with that being said, this is the project. In the next one, and I promise you, this one is probably going to get a lot more difficult. If you thought this one was easy, which I hope you do, then that means you're pretty good at Python. In the next web scraping project, and I hope to do many of these. I might do even all the ones that I put in that poll, but I started with the one that was the most popular. If you were able to get through this, I think that is fantastic. I think this is a solid project to create a data set. And so use this how you will. You can copy my code exactly. I don't have a problem with that. Again, I don't think this is beginner. There are some a little bit more advanced things, and I'm not even advanced, just like intermediate level things that you kind of learn as you get into it. And so I hope that this was instructional. I hope that I explained it, well, and I hope that this is useful. Again, when you actually use this, you'll have 22, 23, 24, 25. You'll see a price change, a price change, a price change, a price change. Go use a product or go to something that you are interested in or that fluctuates often. And there are plenty of those on Amazon, I promise you. There's some that literally change almost every other day, like down $1, up $1. And then Black Friday just goes crazy with these price changes. So use this as you will. I hope that this was instructional. I hope that it's useful. I think I said that before. I'm doing this because I think it's really interesting. It's really useful. This to me, again, was a good introduction. A really good introduction to web scraping, because in this next one, it gets quite a bit more difficult. I would say on a scale of like difficulty, this is like maybe a 4, and it'll probably jump up to like a 7 on this next one. Just much more technical or coding heavy. So, look forward to that if that's something that you look forward to. With that being said, I'm going to go back over here for my send off. With that being said, I hope this was helpful. I hope that you learned something. Don't get mad at me if it was too easy. Don't get mad if it was too hard. I'm doing my best over here, so I appreciate your patience. Thank you so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I will see you in the next video. What's going on, everybody? Welcome back to another video. Today, we're going to be creating a script to automatically take data from a crypto API. Now, this project stems from an earlier video that I did where I walked through what an API was and how you can use it. And in that video, I showed you how to use CoinMarketCap's API so you can start pulling in their crypto data. And in this video, we're going to take it one step further and automate that process. And then we're going to do a little bit of transformation with the data. I'm going to show you some cool stuff on how you can use it. And maybe we'll do a little bit of visualization at the end, but that is not the main point of this video. It's mostly around the automation piece and a little bit of the data cleaning piece as well. Now, fair warning, this is not a beginner's level project. It's probably more like an intermediate project. And It's not even a complete project per se because we're not doing all the data cleaning, we're not doing all the visualizations. But if you follow along, we're going to cover a lot of different things, and you're really going to set yourself up to be able to do just about anything you want with this data or different APIs that you pull from. So with that being said, let's jump onto my screen and get started with the project. All right, so this is where we stopped in our last video. So if you haven't watched it, now is the time to go back and do that. I'll have a link in the description. Also, all the code that we're going to be looking at today and working through is going to be in a GitHub repo below. So you can go and get all the code and have it completely finished and just follow along, or you can code it from scratch along with me. I do recommend writing it from scratch if you can, because I think you'll learn more and you'll make mistakes and you'll learn from that as we go through it, but it is up to you. So let's get started. And as you can see, we have this script right here, and I'm starting basically from scratch. I have a completed one up here. I'm actually going to get rid of those. And what we're going to do is we're going to start from exactly where we started in our last one. I'm going to run the script. This is going to pull from our API, and we're going to look at the dictionary, set our option, and do our JSON normalize. So this is where we literally left off from the last video. So we have all of this data, and what we want to do with it is we want to kind of automate that process, right? Because we don't want to have to come in here, run this, and put into a CSV manually or something like that. We want to automate this data collection process so that we can just have the data ready for us to use, and it'll all be ready to go. So we're going to be using this script, but we might want to add a little bit more to it before we do that. The first thing that I want to do before anything is something that I like to do when I'm creating these automation scripts. As I like to add a timestamp, and the reason for that is because I want to know when I ran, or when each of those loops, you can say, runs through and does those automated runs, right? So if I do it every day, I want to know what time of day I ran it, making sure each run ran successfully. And so all I'm going to do is I'm going to add a new column at the end and just call it timestamp. So let's go right up here, and we're going to say PD dot, and there's something called to date time. So we're going to do to underscore date time, and then we're going to do now. And what this is literally going to do is take the date, the timestamp of right now when it's running, and it's going to show that. Now we need to, of course, add a new column for that. So all we're going to do is we're going to say data frame. Whoops, we're going to say data frame, and let me see real quick. So we just have the data. We need to create this data frame right here. So data frame equals, and then this JSON normalized, and we're going to say data frame, and then we're going to do a bracket, and we're going to say timestamp. And we'll do, well, are all these lowercase? We're going to keep with the lowercase, and we're going to say timestamp. And we'll do that bracket, and we'll say equals. So what this is going to do is first off, it's going to create this data or assign this DF as our data frame. And then we're going to add this timestamp and add this new column. And so let's run this really quickly. And let's go all the way to the right. And this is our timestamp. And this is the time that it is right now. This is the day that I'm running it. This is the time that I'm running it. And so this is working properly. Now, if you look really quickly, there is a last updated in here. And this is very close to this timestamp, but it is not the same thing. But if you looked through this data and you really dug into it a little bit, this last update is coming from CoinMarketCap's API. And this is when the actual cryptocurrency was updated in their system. And so it is going to be really close, but it's not going to be exact. And so I don't like to rely on built-in ones that are coming from an API or something. I want to make one myself that's running on the system where I'm creating the automated process, just something I do. So now we have this original data frame created, right? We now have what we need, but what we want to do is to keep adding data to this. We don't want it to just go to, create these 5,000 rows. We want it to create 5,000, 5,000, 5,000 over time, whether it's a day, an hour, a week, whatever you want to run it. So What I'm actually going to do is I'm going to limit this a lot. I just want to look at the top, let's say 15. So we're going to do that. We're going to run through all this again. So now I just have the top 15. It's going to be easier to see, and it won't take as much time to run our scripts. Again, you can keep as many as you'd like. If you want 100, 200, all 5,000, you do whatever you'd like. But what we're now going to do is we're going to create a function using this original script. So we have this data frame, and we are going to create an automated process that is going to a script to automate this, that is going to append data to this data frame right here. So that's kind of, the big thing that we're trying to accomplish in this project. So let's go up here, and we'll just take it from here all the way to here. I'm just going to copy this, and I'm going to paste it down here. Now, what we need to do is we need to create a function. So we're going to say def, and we're going to call this the API underscore runner, because this is going to run our API whenever we need it to run. Now, when you are formatting something for a function, it needs to be formatted properly. And so what we need to do is we need to go over here. I'm going to hit tab. We're going to do this all the way down. I'm just going to skip forward when it's all the way down. All right, so now we have this URL, and what we want to add, because this is going to run through kind of this automated process. We're going to run this this function there. What we want is to also add this right here. So we need to take this, and we're going to need to add this. We'll just put it down here. Okay. And let's do that. So what we have so far is really close to what we want our function to be. We have this function that we're going to be running through. It's going to call this function. It's going to call the API. We're going to use our key. We are going to test it, load it, format it right here. Then we're going to add this timestamp, and then we will have this. Now, right now, it's just going to print this data frame basically, but that's not what we want right now. What we want is to actually append this data. So when it gets to here, when it gets to this data, that's going to be right here. What we want to do now, since we already have the original data frame set up top, is we now want to say that this is going to be data frame 2, and we're going to say it's going to append it to data frame 2. And so the original data frame, we're going to say data frame 2 dot append, and we're going to say df2. All this does is this says this new data that's going to be coming in every time. Let's say it's a loop, and it's just looping through, pulling the data, pulling the data, pulling the data. We're going to create this data frame. We're going to add this timestamp like we want, and then we are going to append that to this original data frame. So as of right now, this looks good. We'll run it in a second. I'll create it. So I just created it. So now we need to actually create our script to automatically run this. So we're going to do something called import OS. And let me tell you, there's 1,000 different ways to do this, and there are better ways to do this, but they are much more complex, much more complicated, and some cost money in order to do it. I'm going to show you different options on how to do this in future videos on how to automate your Python scripts. But this one to me is one I've used a lot, many times for different projects, and it works. So I'm not going to show you the most complicated thing in the world. I'm going to show you something that I've just used a lot. And so we're going to say from time, import time, from time, import sleep. That one's important. And now we're going to create our loop. So what the time and the sleep and the OS, or your operating system, what these are going to do is they're going to give us the ability to track the time, and we're going to be able to run through and call this function in certain intervals that we want. So let's create our for loop. We're going to say for I in. Now, you can create this specific part in different ways, but what I'm going to do is I'm going to say range of let's say 333. And I say 333, and if you remember from the first video on the API, you only have 333 runs per day. And so if I ran this 333 times today, that would be our max. And so that's why I'm using that 333 just for reference. So now we're going to do API underscore runner. So in this loop, we're going to call this function up here. And then I'm going to say, I want to prove or show, have an output to show that this is running through successfully. So I'm just going to, and you can write anything here. We're just going to say API runner completed successfully. Successfully. How do you spell that? Successfully. That doesn't look right. I'm just going to say completed. All right. Forget that. I don't remember how to say spell successfully. If it spelled it right, you guys spell it that way, but I can't remember. Now we're going to use this sleep right here. Now this counts it in seconds. You can change it to minutes, hours, whatever. We're going to have it run every minute, which is every 60 seconds. And so this is going to, I'm just going to say it's going to sleep for 1 minute. And then we're going to say exit. So all this is going to do, and this is, again, fairly simple. It's just a simple for loop. And what it says is it's going to call this API. It's going to tell us that it ran successfully. And then it's going to wait for 60 seconds and it's going to run again. That's it. So let's run this and see what happens. See if what we did works. So it ran it the first time. Now, I'm not going to bore you because I'm doing this live. Exactly what we're about to get is what we're going to use. I didn't run it overnight or for a week so that we have a bunch of data. What you were going to work with, I'm going to work with as well. So I'm going to wait a few minutes. I'm going to let this run. I want you to do the same thing. I'm going to let this run for maybe like 5 minutes or so, and we'll work with what we have and we'll keep going with the project because again, the point of this project is not to create the final product or creating all the visualizations. That will most likely be in another video where we're taking all this data and doing all these things with it. The point of this video is to automate it, clean it up to where we have it to where we can really use it. And then I'm going to let you guys loose and you guys can do whatever you want with it. And I think it's really setting you up for a lot of successful projects in the future that you can do all by yourself without me having to walk you through it. So as you can see, it's already ran through twice. I'm going to pause for a second. I'm going to let that run through just a few more times, and then we will continue with the project. All right, we are back. And of course, it's only ran, 5 times. It has not reached the limit of 333, so we are perfectly fine. What I'm going to do is I'm just going to stop this by clicking this square up here, and it's going to give us some error. And then we're going to check it, and we will see what we have. I don't know why it's taking so long, if I'm being honest. All right, so I interrupted it. And let's run this. Let's see what we got. I hope we have more than 15, because if not, I'm going to be very upset. Okay. So, okay. Well, I made a mistake. I was supposed to put data frame right here. And I had data frame 2. So change your script. Do not do what I just did. We're supposed to be it's supposed to be data frame append. And we're supposed to be appending the original this data frame 2 to the original data frame. So I messed up on that one. Let's rerun that. Let's see. Local variable df reference before assignment. Okay, this is perfect because this happened to me before. We're running into all sorts of good stuff. I like to keep this stuff in my videos. I laugh because I hate running into mistakes. But everybody says they're happy that I do this. So I'm going to keep doing it. I'm not going to cut this out, I promise. But what we actually need to do is we need to go back up to this function, because what happened is we called this data frame. And now it's because it's in a function, it's in what they would call a local variable. What we need to do is we now need to state that this is a global. It's just called a global. That's all it is. And so what we're going to do is we're going to do tab, we're going to say global, and we're going to say df. And what this should do is this should declare it as a global variable, and it should let this run properly. Let's hope it does. All right, it's running. Again, I ran into mistakes. Let me tell you something while we're here for just a second. this project, I ran into probably 100 mistakes or 100 errors, issues that I had to research for hours and hours. I'm legitimately on Stack Overflow and just Googling and figuring these things out. There were a lot of new things that I had never run into before just on this project. And so everything that you're seeing is from after I went through all of those things or after I fixed all of those things and had to really work through them. It was very, it was frustrating at times. I couldn't figure it out. And so what you're looking at is kind of the polished version of that now that I have everything laid out, because I can't spend 10 hours on a project. Nobody would watch it. So just know that if you are running into some of these mistakes, or you run into mistakes later on when you're expanding this project, that's completely normal. So what we're going to do is we're going to let this run for a little bit. And then after maybe 3 or 4 minutes, we'll come back and we'll keep going with the project. All right, so let's run this and check and see if we have the data that we're looking for. And it looks like we do. Let's go actually back up here really quick. We want to set this to display max rows because I want to be able to see all the rows and not just a few of them. So, and that just, instead of, it gives us this scrolling instead of that ... that shows us just a few. So there's our original 15, and then we have the next loop, and then we have the next loop. And let me scroll over to the timestamps, and I'll show you what I mean. So this was ran on 5/26, 1501. Let's go down 5/26 at 2905. What did I say? 1501, 2905, and then the next one you can see was ran at 3006. 31. These are all the ones 1 minute after each other. My original one was from earlier. 32, 33. Yeah. So you can see 32, 31, 30, 30, or 30, 29. And this one was about 15 minutes ago when I first ran the original data frame, right? All right, guys, this is Alex from the future. I've actually completed this entire project in the video, and you're about to see all of that after this. But I wanted to show you one more thing that you can do in this function up here that I didn't show you originally, that I'm coming back to show you, and that's how to actually put it into a CSV. Now, all we've done in this one is we've kept it all enclosed in a data frame, and that's it. And that may be great, but a lot of you guys are going to want to automate this and put it into a CSV. And I want to show you how to do that. All right, so what I'm going to show you really quickly is right here in this folder right here, I have all these different API 3s and 4s. These were tests that I did before. But what you can do is, instead of just putting it into a data frame, you can actually append the data to a CSV and have that CSV sitting out there for you, instead of just keeping it all in a data frame. And there's a lot of different uses for that. You may want to have that file separately from here, just in case something times out or something breaks, which is a legitimate concern, or your computer shuts off or something like that. That is a legitimate concern. So what we're going to do is we're going to say, if not, and this is basically an if statement, we're going to say os.path.isFile. So what this is going to do is check if there's already a file under this name. And we're going to do r dot or r. If you have never done CSV stuff before, it's really important that you put that. You're going to get an error every time. So we're going to take this right here, and we're going to copy that, and we're going to put that right here, and then we're also going to do a slash, and then we're going to name it basically. Let's name this API, because I don't think I have that one in there. I think I deleted it. Yeah, so I don't have API, so I'm just going to keep it API.csv. And then I'm going to close that parentheses, and then we're going to add a colon right here. And we're going to say, if that does not exist, we are going to write this to it and create it. So we're going to say data frame. So that's this data frame right here. Data frame dot, and we're going to say to_CSV, and we're going to do that R, and then we're going to copy this. So oops, let's just replace it like that. And then we're going to say comma header is equal to column underscore names. So what this is going to do is if we run through this, and what we would have to do is, I'll talk about this in a little bit. We'll have to change this up a little bit. But what this is going to do is going to check to see if this file right here exists. If it does not, it is going to create it and create the column headers based off this data frame. That is what that does. Now, what we want to do is say else. And this next part that we're going to write is saying if there's already the API file there, we want to append the data. We don't want to overwrite it or anything like that. We want to append the data. So we're going to say, we're basically going to copy this. Maybe not the whole thing, but I already did it. So we're going to copy that. And we're going to say mode equals A. And A stands for append. And then we're going to say header. Oops, keep messing up header. And we're going to say false. Oops. We're going to say false, which means when it appends the data, it's not going to use those the column headers every time, which you don't want, because every time you append it, if you added the headers, every 15 rows, you're going to have another headers that you're going to have to like go out into that CSV and filter out and get rid of them. So we're going to say header equals false. Now, just a second ago, I said you would need to mess with this just a little bit, and you would, because every time you'd be putting in this data frame, which it's already appending it to this data frame. So every time you'd be creating a lot of duplicates if you kept it exactly as is. What you were going to need to do is basically take it back to its bones. So you need to kind of keep it like this. So what you need to do is just now run this, and it would work perfectly. Let's test it really quick to see if it works, because I'm promising you something. I want to make sure it actually works. Let's run it this time. Okay, so it just ran for the first time. So it should have created this file. Let's go see if that works properly. So now it just created that file. And now we're going to see if it actually appends the data. So let's wait just one time. And then I'm going to stop it. I'm going to see if it works. Again, I'm just verifying to make sure that what I'm telling you is actually working. Because if it doesn't, I would feel terrible. We don't want that. And while that's running, actually, I'm going to add this, because now I want to show you how to call it. Super easy. We're just going to do pd.read_CSV. We're going to do that. We're going to call this just like that. And then we're going to say data frame, and we're just going to do 72, something random, because I've already done this whole project. I don't want to mess anything up. So we're going to say data frame 72. So now let's stop this. And what we're going to do is once that stops, we're going to run this and see if it actually worked, and make sure that this actually pulled the data in. All right, so we interrupted it. The file is ready to be read in. So let's read it in. There's our file. Let's see. What did I mess up, or did I mess anything up? I didn't mess anything up. This is the index for this file, and we already had this in here. We'd probably be able to get rid of it. But if you see, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Then we have 0, 1, 2, 3, 4, 5, 7, 8, 19. And if we look at the timestamp, it should be 1 minute apart. So it's 1:19:45. It said 1:20:45. So this worked exactly as planned. Again, you have two different options. You can just keep it how it was before, and I'll leave both of those options, in the script, so that you can kind of choose which one you want. But that's how you do that. So then right here, you're appending it to a CSV file. And then if you just keep this and you get rid of all this, you're just appending it to a data frame. Now, please continue with the rest of the video that I already have done. But again, I'm Future Alex. So please continue with the rest of the video. Okay, so we have all this data. We have so many columns. We can do now, if you want to completely just go and do your own thing, you absolutely can do that. I'm going to mess around with a few things, kind of show you something that I did that I thought was really interesting in order to visualize this data a little bit and transform it a little bit to make it more usable. But we're not doing a full data cleaning. That's not what this project is. We're not doing a full data cleaning of this data. That would be a very large undertaking because honestly, this needs a lot of work. One thing that I do want to clean up really quick is this right here. The math will be fine. It's just the way that it's shown on here is in the scientific notation, and I don't like it. So what I'm going to do really quickly is just get rid of that. So we're going to say PD dot set, and we're going to do underscore option, and this is going to be do parentheses. I'm going to say display. This is just how this is formatted. So we're going to display dot float underscore format, and we're going to say comma, and now we're going to use this lambda. We're going to say x colon, and we're going to say percent 0.5 f, and that right there, and we're going to say percent x. Now, if you don't know what lambdas are, I highly recommend looking those up. Again, this is not a beginner tutorial. Whoops. No such keys, display floor format. That makes sense. This is float. Yeah, guys, this is not a beginner's level, all right? You can't use the floor format. This is the float format. All right, so now let's take a look at this this DF, this data frame that we have. So we're just going to hit DF, click enter. And now our numbers are a little bit more easily readable. I prefer it this way. You do not have to do this. I'm doing this just because this is what I prefer. So let's jump right into it. Something that when I saw this data, I was like, something that I really thought was interesting is this percent change of 1 hour, percent change 24 hours, 7 days, 30 days, 60 days, 90 days. If you're not in crypto or you don't do investing or anything like that, what this is going to show us is it's pretty obvious, how much the price of this coin has changed over the last hour, 24 hours, 7 days. So as you can see, it's barely fluctuated over the past 24 hours, a little bit over the past 7 days, a lot over the last 30 days, 60 days, and 90 days, minus 26%, minus 33%. We're in May. We just had a kind of a crash in crypto a couple weeks ago. So, this tracks, right? But I want to visualize this, see this, and kind of see, how this is going to look and if I can gain any insight from that information and just having it all displayed for me. But in its current state, we really cannot do that. Now, another issue, not an issue, but another thing that we have to take into consideration is we have Bitcoin net right here. We have Bitcoin right here after different polls. Now, we just did it a minute after each other, but for your project, you may do it a run each day, a run every hour, or something like that, right? And if you did that, your data could be very different. And so you may just want to take this first one, but what I'm going to do for the sake of this project, I'm going to group them. So let's go down here and we're going to say df.group by. And so if you've ever done something like SQL, this is how you group by in pandas, basically. We're going to group by the name. So on Bitcoin, Ethereum, Tether. So we're gonna do that on name. And I'm going to say sort is equal to false. Oops. I'm not going to sort it. You could say true there, but we're not going to. And I guess you'll see why later. We're going to do an open bracket. And now we need to choose what we're going to group by, or what columns we're going to have. So I'm going to do another open bracket, and I'm just going to copy and paste these. So I'm going to start right here at quote percent 1 hour. So I'm going to do boom, and then go over 1, and we're going to take 24 hours. Paste that, comma. Then we have the 7-day, 30-day, and we're going to do like that. And I'm just going to do comma. I'm going to do the same one, but I'm just going to manually change it to 30-day, rid of that at the end. I don't know what that is. Then we're going to do 60 days and comma, and we're going to do our last one, which is 90 days. And let's see what that gives us. Doesn't give us anything. Okay, I know what's wrong here. We forgot to add basically we're grouping by something. We need to have like an average, a mean, a mode, or something like that, right? So all we have to do is go to the end right here, and let's just do mean. We're going to do an average. And so we're taking this number. So let's say this is for Bitcoin. So we're going to take this number in this 1 hour. For every time it's Bitcoin, it's going to group them all together. And then it's going to average them. So in the past 5 minutes where it's been running, we're going to take the average or the mean of that. So let's run this again. And so now this is our output. Let's take a look. Oops, I meant down here. Let's run this. Now what we have is all of these cryptos. These are all 15 that we have. And this is the average for this 1 hour, 24, 7 days, 30 days, 60 days, and 90 days. So now we have all of our cryptocurrencies over here. We have our percent changes up top, and then our averages here as well. And so now what we're going to do is, if you try to visualize this as is, it doesn't really work because these percent changes are up here as columns, and we don't really want them as columns because it just doesn't work for actually creating the visualizations. We really need these to be rows. And so my initial thought when I was doing this was of course I need a pivot. If you've ever used a pivot like in Excel or Power BI or something like that, that was my first thought. And I tried everything and I could not get it to work. And I almost gave up until I ran across something called stacking or a stack. And so this was not something that I think I have used it before, but I couldn't remember, if I'm being completely frank, I couldn't remember how to do this. So I just did, once I saw what it was, I did stack. And let's make that data frame 4. You don't have to do this. You can keep this all the original data frame. I like for visual purposes, you can see like the progression that we're making. But I like to, create its new data frame, and I can always go back and look at this data frame 3 as we go, but you don't have to do that. That's just what I'm doing. So now let's take a look at this. Now, up here, we had Bitcoin and we had all these columns and we had these numbers as rows, but now we have all of these as rows as well. How we have this is much, much more usable. And if you've ever done something like pivot or the stacking before, you'll know that you kind of have to do it if you really want to visualize this well. But because we just stacked it, it kind of changed it. So if we look at, let's look at the type of data frame 3. This is before we stacked it. This was in a data frame. But now let's go and look at data frame 4. So this is a series. This is no longer a data frame. And so we have to remember that. That's really important because we can no longer treat it as a data frame. It's now a series. So we want to get it back to a data frame. We don't want it to be like that because you can't really use it in this series. So what we're going to do, and let me just create a few of these so it can be up here better. So now what we're going to do is we're going to say data frame 4 dot, and then something called 2_frame. So we're going to make this into a frame. And now we're going to specify the name. And it doesn't mean the name like right here. We actually mean the name of these values right here. This is part of the stacking process in these columns, or these 2 columns. So let's go right here, and we're going to call it, let's just say values. And let's make this data frame 5. And let's see the output, for data frame 5. And now, so there's that values. And now this already looks a lot better, right? So it's in this more, this is already a data frame. So this is a data frame. So let's look at type, data frame 5. So now it's in a data frame, but The issue is that this name is kind of acting like an index, which we don't want because we want to be able to use this. So it doesn't really have an index at the moment. So we need to give it an index. But typically when you give an index, you'll do something like, we'll say data frame.5, we'll do set underscore index, and then you'll do something like name. So let's just do data frame 6 is equal to. We'll see what happens here. It's going to give us an error. Oops, what I meant is we're going to do data frame 5 bracket name. And that's a column, right? We're going to do that. And it's basically going to say that that's not going to work. And what we need to do is or at least what I want to do and what we're going to do in this video is I'm going to create numbers. I really would just want it to be numbered 1, 2, 3, 4, 5. That's what I want. But we don't have that right now. I can't just will it into existence. So now what we're going to do is kind of create an index basically out of thin air. So we're going to do pd.index. And we're going to say, we basically want how many rows are in here. That's what we want our index to be. We want it to count how many are in here. Now you can make this dynamic, and it probably wouldn't be that hard, but I'm going to take this super lazy route, and I'm just going to say, let's do df.5 or df5.count, and there's 90 values in here. So what I'm going to do is I'm going to do a range of 90. And this is not, I would definitely make this dynamic, but I'm just being a little bit lazy. We're going to call this index is equal to, and I'm going to put this index right here. So now this is a number. So now it's going to literally index this for us. Now, I've ran into this issue many times. And so what I need to actually do is to reset this index and then do it properly the first time. So let's do let's get rid of this. Let's reset this index. And it actually fixed itself. So what was happening is we were indexing something that was already indexed and we were causing issues in a nutshell. So we reset the index and now this is what it looks like. And this is exactly what we want. This is really how we wanted it formatted in order for our visualizations. We have multiple rows for the Bitcoin. Each of these columns is now a row with the value attached to it. Exactly what we wanted. So really quick, for whatever reason, it makes that level 1. I don't know why, but we're just going to rename that column really quickly. So we're going to do data frame 6 dot rename. And then we're going to do an open parenthesis. We're going to say columns equal to, and we're going to do one of these bad boys. Oops. One of these bad boys, this type of bracket. And we're going to say level _1. And we do a colon. And then, and then a colon. And then we want to change it to, and I'm just going to call this the %_change. So let's call this data frame 7. Again, you don't have to do that. I'm just doing it. So now this looks much, much better. Now let's try to visualize this one because we haven't done any visualizations yet. We've just been messing with the data a little bit. I kind of want to see how we can use this. This is something that I personally am interested in. So I kind of wanted to visualize how these changed over these time periods. But we need to import some stuff in order to be able to visualize this. So we're going to import Seaborn as SNS. And if we need to, we're going to import matplotlib as well. I don't know if we'll use it right now or at all, but we're gonna add it in here either way. So now those are added. And so what we're going to do is come right here. We're going to do sns.catplot. And we're going to, we're going to say the x-axis is equal to, and we want to do this as the %change, %_change. And then we have the y-axis. Now we want the y-axis to be these values right here. We're going to say comma y is is equal to, and then we're going to say values. Oops. And then we're going to say comma, and we'll say we want to basically create a legend, I guess you could call it. We're going to say hue is equal to name. I'll show you what it looks like without it, and then you can see that we need that. And we're going to say the data is equal to this data frame 7. Data frame 7. And then we are going to say the kind is equal to point. Now let's run this and see what we get. And super quickly with just, limited inputs, here's what we have. Now, this looks really good. We can narrow this down if we wanted to a few less because there's a lot here, and there's a lot of colors. But again, that's just because we have a lot of different stuff. But there's a few that are doing really well. I think this is Tron. And then we have a few that are not doing so well. But it's really hard to see. If you look down here, it's really hard to see this. And that's just because of the column names. And so I actually want to change these column names or these values so that when we visualize it right down here, it doesn't look like that. I kind of want this to be, at least one good visualization you can take out of here. Now, this is definitely not perfect or complete by any means, but you can take that away from here. So let's, I did Alt Enter, which adds another row. I could have just pushed plus. That's kind of the lazy way. What I'm going to do is I'm going to change these values in here. So how I'm going to do that is I'm going to do data frame 7, and we only want to look at this one column. So we'll do that right there. And we want to say dot replace. And we're going to do an open parentheses and then a bracket. Now, what we need to do is just to show you one of them is I'm going to say this 1 hour. Do that. Oops. And then what I need to do is a comma, another bracket. And this is what it's going to change to. I'm just going to say 1 hour. 1 hour. And we'll do this one really quick. And then I don't want you to have to watch me type all this out, but I'm going to go through and basically do all of this for those. But let's see this really quick. And so now, as you can see that originally it said quote.usd.percent change 1 hour is now only 1 hour. Now, this didn't actually do anything. We need to apply it to this right here. So I'm going to say data frame 7 is equal to, and then we'll run data frame 7 again. So now that has actually changed that value. Now I'm going to go through and I'm going to update that for every single one. All right, so I basically just put the other ones in here that we wanted to change with commas underneath. So I have 24 hours, comma, with the 7 days, 30 days, 60 days, 90 days, and then this bracket over here, which tells it what to change it to: 24, 7 days, 30 days, 6 days, 90 days. So let's run this. I haven't even tried it yet. And it looks like it obviously worked properly. So now let's go back down here and let's run this again. And look at that. It looks so much cleaner, so much nicer. And all of them with that 1 hour change has very little change. And then you can look back. So we can see back within 90 days, a lot of these have gone down, which again, if you're following crypto, there's a big crash recently, especially with all these altcoins that you're seeing right here, went down a ton. So I think this is, Avalanche or Die or whatever. These ones are, went down dramatically. Whereas there's one up here, this lone wolf, that's just doing really well for whatever reason. So it's really interesting to see. Now, this is a pretty specific visualization that I personally wanted to see and I thought was interesting. You can do absolutely whatever you want to do with this data. I mean, there's so much here. You can do a lot. A lot with this data, especially depending on how long you track it, right? I only did this over the course of like 5 minutes, but if you set this up and you can track it over a longer time. Now, let's say you wanted to do something much simpler. You just want to look at like Bitcoin over that time that you took the data in. That's going to be a lot simpler than what we just did, and I'll show you how to do that really quickly. So we're going to look at the data frame, and we are going to say, or we're going to take specific columns. We just want a few columns that we want to keep or pull from. So we're going to take, we're going to take the name column. We're going to do, might be easier if I copy them, but I'm just going to write them out. Quote.usd.price. This is the price of the actual cryptocurrency. Then we're going to do timestamp. And let's make this data frame, and we're just going to do 10 for absolutely no reason. Maybe I should have made it 9. It would have been easier. So now we just have these columns, and we have all of these separate columns. So what we can do, and the reason I want to show you this is you can just query this really quickly and just take the columns that you want. So let's say we just wanted to look at Bitcoin. So we're going to say data frame 10 dot query, do open parentheses, and we're going to say name is equal, and equal is not like that when you're doing it like this. You need to say equal to, oops, ignore that, is equal to Bitcoin. And we're going to do it just like that. And we're going to say data frame 10 is equal to, let's try running that. I think something's wrong with it. Try it like this. Oops. All right, let's try that. There we go. It was just I needed a double quotation instead of a single quotation. That was the issue. So now we have Bitcoin, we have the price, and we have these timestamps. So this is the actual time when we ran it. So this is the original data frame, and then in the this project, it took me 15 more minutes to get this one, and then we had it running properly for the next 5 minutes. So that's actually what we have. Now, if we want to just visualize this really simply, what we can do is we're going to say we're going to do SNS dot line plot, and that's going to be like a little line chart or line graph, whatever you want to call it. And then we're going to say X is equal to, and we'll say quote. No, actually, we want the timestamp to be on the x-axis. And then we'll do Y is equal to quote.usd.price. And let's see if that works. Could not interpret timestamp for the parameter. That's because it's not understanding that the data equals data frame 10. Now let's try this. All right, so this is looks terrible. Let me just say sns.set_theme and open parentheses. We'll do style is equal to dark grid. This looks a little better. Now, again, we are looking just at a very, very short time series, but we can look at just Bitcoin, or we can look at multiple, and we're showing this, this line that's showing us this trajectory over time. So you can get really creative with this. You can run this for a long time. You can show Bitcoin over days, weeks, or months, however long you run this. And so that's really all I've got. Honestly, like I said, this is not I wouldn't say this is a complete full project, but I'm showing you how to do something to enable you to kind of run with it and run with the ball and do basically whatever you want with this. You can pull it from, data from a different API. You can use this exact API and data, but I wanted to show you just a few things that I initially saw that I might do with the data. And you have so much. Let me go back to this original data frame. Right. We'll use this one right here. This one right here. Look at all this data. I mean, you have so much data. Actually, let's go to this one. This one's better. You have so much data, so many numbers here, so many columns that we didn't even look at that you can use. And so, there's a lot that you can use here. And I'm really trying to just set you up so that you can run with it and do whatever you want. I could have done 1,000 different things here, but I tried to just show you 2 things that you can do with the data that I thought were pretty interesting or simple to do. And, I want you guys to go out and do something way, way better than what I did. So I hope that this was helpful. I hope that this showed you how to automate that process so you don't have to sit there and click it and append it and do all these different things, that it can show you how to kind of automate this process. And hopefully that will be helpful in your future projects. So with that being said, thank you so much for watching. If you made it all the way to the end, you guys are fantastic. If you like this video, be sure to like and subscribe below, and I'll see you in the next video. What's going on, everybody? Welcome back to another video. Today, I'm going to be walking you through how to create your very own portfolio website. Now, we just completed our Data Analyst Portfolio Project series where we walked through 4 projects in SQL, Tableau, and Python. And so if you have completed those projects, you now want to share them with potential employers. And I think the best way to do that is to create your own website. In just a little bit, I'm going to show you 2 options on how you can actually create your own website. The first one is a website builder like Wix.com, and the second one is hosting your own website through something called GitHub Pages. Now, if you have never created your own website before, it can sound a little bit daunting, but don't worry. I'm going to walk you through every single step of the way from the very start to the very end, and once you reach the end, you will have a complete Data Analyst Portfolio website. So without further ado, let's jump on my screen and let's get started. All right, so the website that you're looking at right now is the actual website that we are going to build in this video. It is hosted on GitHub Pages or github.io. So this is actually being hosted right now by GitHub Pages. So if you type this in, I'll leave a link in the description. If you type this in, you will get this page and you can check it out for yourself if you don't want to just watch me look at it. So it has this little header and you can write a little bit about yourself. And then these are our actual projects. So this is our data cleaning in SQL project. And then there's the COVID data exploration, Tableau dashboards, movie correlation with Python. This is a future video. I plan on doing a few more of these projects because I just really enjoy them. So, and then there's this contact information at the bottom. So it's a really simple website and it gets the point across. And I have something similar to this for my own personal one. I use a different variation, but this all comes from this website, HTML5 Up. There are lots of templates, lots of options that you can use. Again, the one we're going to be working with is this one, but I use a different one for mine and they are really good. And super easy to build and customize yourself. And I will say again, I have no experience doing this. I just watched a YouTube video that showed me how to do this. And now I am creating my own YouTube video to show you how to do this. So it's coming pretty much full circle. So like I said, there's no real narrative to it. It just clicks to your project. If you click on this and let's just open it in a new tab, it'll take you right to the GitHub project. And then whoever's checking this out, like an employer or a recruiter, can see your code. So super simple. Another way that you can do this is kind of creating your own website through like a template or something like that, almost like a blog style. So I imagine it being something very similar to this, where there's this introduction and you can talk about, where you got the data set, how you got the data. And then you can kind of have a more narrative approach with screenshots and with some code as well. So, this person included screenshots. And then there's the code right here that I can actually copy and paste that. And it just walks through the logic of how the project was done. There's a story to it, really. And so that might be something that you're interested in. Now, I have done something like this in the past and I used Wix, and you can do this completely for free. The one we're doing today is completely free as well. But, if you want the customized URL, you do have to pay for it on Wix, but you can get a free Wix website with the Wix in the URL. So, try this out. These are super easy and you can find thousands of templates and a million tutorials on how to do them. So that's not the one we're going to be working on today. So with that being said, the very, very first thing that we need to do before we do anything is actually download Visual Studio Code. This is where we're going to download that HTML and we're going to be working with it in there. Again, I don't know if I said this before, but it seems a little bit intimidating at first, but once we actually start looking at it, it's a lot easier than it looks. I promise you. So if you are me and you have a Windows computer, you'll just go right here. You'll install it. Super easy to install. I'm not going to walk you through how to do that. Of course, I already have it up and running down here. So once you have that installed, what you're going to do is you're going to come to this website. A link should be in the description. We are going to download this. All you have to click is the free download. It's going to pop up. I'm going to put it in my downloads. I'm going to click save. Fantastic. So let's go to the downloads, and it should be right here. Now, if we open this up, it has a few different things in it. Okay, so I'm using the Brave browser, so that's going to be right here. So that's just the symbol. But for you, if you're using Google Chrome, that should be the symbol there as well. But this is everything that you should be seeing. And what we want to do is we want to take it out of this zip folder, because it's there are things that can read into it with Visual Studio Code, but I want to make this as user-friendly as I possibly can. So what we're going to do is we're going to create a new folder. I'm just going to call it Massively, or you can call it Port Website, whatever you want to call it. I'm just going to do Port Website. And we're just going to, I'm going to copy this in. I'm not going to cut it in just in case I make a mistake. So I'm going to put all of those things in here. And now what we're going to do is we're going to go to Visual Studio Code right here. And you should be greeted with this, this right here. And we're just going to click Open Folder. And we're going to go to Port Website. And we're going to go Select Folder. And you're going to say, yes, I trust this one. And right over here is all of the documents that we were just looking at. Now, the only one really that we're going to be working in, we'll work a little bit in the images, because I'll show you how to add your own images. Really the only one we're going to be working in is this index. So again, it looks complicated. If you've never looked at HTML before, it does look a little bit complicated, but HTML to me is one of the more easily understood languages. Once you start kind of getting into it, which we're about to, we're going to walk through the entire process. It actually makes a lot of sense, and it is pretty simple. Something that you're going to want is you're going to want something called a live view. So like if I click right here and I click open with live server, you don't have that yet, I'm guessing, unless you've done this before. It's going to open up this website, and this is what we're looking at right now. So it has a bunch of gibberish or some language that I do not know. And so we can view this live. In just a second, I'm going to take myself off screen. But before I do that, let's download, or let's search for that live, I think it's called live server. Let me see what this is called. Yeah, live server. So come right here. It's called this live server. There it is. Yeah, that's the one. So this is our live server. You just need to click install. It takes like 5 seconds and it should be completely installed. What this does is it just hosts a local website. It's not something that anybody can access, but it connects to your code. And when we make updates, it'll make a lot. You can see it live. You can see those updates live. So I'll show you all that in a second. Just be sure to download that or install that. With that being said, let's get out of this. Let's go back right here. With that being said, I am going to take myself off screen so that you can see everything that I am seeing as well. It's been really great seeing you. Have lots of different videos coming up, lots of new projects. I really enjoyed this project series. I think I'm just going to do more of them. So, all right, I'm going to get myself off screen. So let's look at what we actually need to do. So I'm going to, so let me see. Okay, so we're already connected to the live. Actually, I got rid of it. Whoops. Let's pull this over and let's pull that. And we're going to open in live server. So if we look right over here, and I know this is going to be a little bit squish, and I'm sorry about that. But if we look right over here, this says this is massively. So you can change that. That's this right here. And you can say, we're going to say Alex, the analyst portfolio. And we'll get rid of this massively. I'm going to hit Control Save. You can also go up here and hit Save, but I'm going to hit Control S. So I hit Control S, and just like that, it updates on the website. Now, again, this is just a local, so it's nothing that anybody can see, so don't worry. But what we're going to do is I'm going to walk you through the entire process of creating this. And then at the end, I will show you how to host it on GitHub. And it's honestly, it's a fairly easy process. It just takes a little bit of time to customize it all. So let's get into it. So we have this, you may not be able to see it. Let me actually pull this up. So it says massively by HTTP. We're going to customize that as well. Whoops, I don't want to do that every single time. I'm going to try not to go full and go back and everything like that. So we're just going to say Alex, the analyst portfolio. Control S, and right up here it changed it. You may not be able to see. Yeah, don't ask me that again. Thank you. Right up here, you probably can't see at the moment. We'll see that later. But it customizes this tab, which is really cool. So let's go right down here. Now this is where it says a free, fully responsive HTML5 template. We can customize that, and I highly encourage that you do. So what you can do, and they actually included their Twitter handle right here, and you can do the same. If you look at this one right here, I included my Alex the Analyst handle, and that goes to my YouTube channel. And you can do the exact same thing, include your LinkedIn or your GitHub profile or whatever you want to include in there. And so, be aware that you can do that. So let's say, oops, I need to click back in here. So we're going to say data analyst skilled in, and then again, don't write what I'm writing. You can. I'm just going to make it really simple. But this part is meant to be a little bit about you as who you are. So I'm going to say data analyst skilled in SQL, Tableau, and Python. And then I'm just going to get rid of all of this. Yep. Everything from here over. And Control S. And so super simple. Actually, let me where was that for? Here it is. We don't need that. Actually, we don't need anything from here over. Probably here, honestly. Let's see what that looks like. And yeah, and I can, again, you can use any website right here that you want, and you can customize what it looks like. So I'm going to say Alex, the analyst, and then whatever URL you want to include in there, that's what you need to put. So now if I save, if I hit Control S, so now it says Alex, the analyst. So pretty easy. Now we're going to go down, and you can use this however you want to use it. You can even make this, you can make this like one of your readmes like about you and put the link for that. I decided to include, again, on this one, I decided to include the project that I thought that we've done that was like the most impressive or the coolest one. I don't know if you consider data cleaning in SQL cool, but I do. I think it's cool. So I included that one as my very first one. So that's what we're going to do right here. So we're going to go down, and it's going to say, let's say it says this is massively. That's not it. Cool. So let's see what, okay. I know what that is. We'll come back to this up here in just a little bit. I'm going to go full screen. I'll show you what this is, and then we'll come back to it. But if we go right down here, this is what they're calling a featured post. And then the ones below this are posts. So in our featured post, I'm going to get rid of the date. I don't want them to know that I just created it like, I don't know. Oops. I keep doing Control A, selecting everything. Whoops. So we're going to say data cleaning in SQL. And we'll get rid of this. And Control S. Again, I'm just updating it a lot so that you see what I'm doing and where it's going. And we're going to get rid of basically all of this and go back. And we're just going to say, in this project, we clean data in SQL. We clean housing data in SQL Server. and Control S. So super easy again. Give a little bit more description. I did in my other one, and you can see that website. So go check it out. And then we'll have an image, and I'm going to show you at the end. We're going to go back and redo all the images, but I'm not going to do that at this very moment. So now you can have this full story. I chose to do view project. And if I hit Control S, it says view project. I think that just looks better, especially if you're displaying a project. I think it is nice. Now we go into all the individual posts. Actually, no, wait. What I want to show you really quick is how you actually link it to this. So let's go right over here. This is our COVID. That's our COVID one. Here's a data cleaning project. So all you have to do is take this website. So that's the URL, and you're going to put it right here. Now there's 3 different places. This href is are places where you can put a link to a website. And on here it references this right here. So they can click on this data cleaning in SQL. They can click on the image because this href is right next to this image. They can also click on the view project button. So you can put it in all 3, and you'll just go like this. You'll stick the URL right where that hashtag or pound sign is. And then we're going to save that. Oops. Oh, this is embarrassing. I am not a website. I am not a web developer, as you can see. But then if I go in here and I right click and I say open link, it is going to take me to that project. So super simple. And we're going to do basically that for all of these. I'm only going to show you 3, and then you can do the rest. But I want to show you how to also do the put the Tableau. It's the exact same thing, but it's different. So I wanted to show it to you. So the next one that we're going to do is go down to posts. And again, I'm going to get rid of this date. You can keep that in there if you want. Excuse me. And that's totally fine. Just update the date. This is that said Magna. Again, I think this might be like some language that I just don't know about. The next one is data exploration in SQL. And I'm going to get rid of this. And we'll save that. Perfect. And we'll do view project. Cool. And yeah, so now we need to customize this summary. And so I'm just going to say something really simple. Data exploration of COVID-19 data set in SQL Server. There we go. Let's save that. We have view project. Now let's go get our project. So this is the data exploration. We're going to take this, we're going to copy it, and we're going to put it right in here. And right in here as well. And if you want to, you can also include it right up here. So we have it in all 3 places. Again, once you click on these, they will come up. Let's go to the next one. We're going to get rid of this. This one is going to be our Tableau projects. So actually, let me just copy that while we're here. This is going to be our Tableau projects. So if you have one specific project that you want to include, what you would need to do is actually go in here, click view, grab that URL. What I am doing is I am just sharing my Tableau public page. So if you have tons of projects in here and you want to display all of them, then, or you want them to be able to see all of them and go and pick and see and choose what they want to look at, then just choose this URL that we're choosing right here. So in here or in the HTML, I'm going to put Tableau projects, and let's go like this. And then we will get rid of that hashtag, pound sign, whatever you want to call it. And we'll hit Control S. And oh, we got to do the this as well. This is my, this is going to be a terrible, don't use this. This is my Tableau. This holds, this is bad. This holds all of my Tableau dashboards. Please don't do this. I am doing this because I don't want to take forever in a video to make it perfect. And then, you're going to do the exact same thing. So in this one right here, I included 4. So I'm going to keep 4. Let me do the last. No, I'm just going to do these 3. I'm not going to take up more of our time. So we did those. I'm just going to keep these 3 in for visual purposes. But once you get down here, what we're going to do is delete some of this, right? So this is our data exploration. And where's our Tableau? This is our Tableau right here. So Tableau projects, they're separated by these articles. So what we're going to do is go down right here, and we're going to go down, 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 down to right here. This is going to get rid of all these other articles or all these other, what they're calling posts. So we're going to get rid of those, and we're going to hit save. And now, as you can see, we have our header, we have our first project, and we have our second and our third. I would include those other projects that we've done in here so that it looks good. This is this footer right here. We don't need that because we don't have anything else in there. So we're going to get rid of that as well. And now we just have this information. Now, I don't have anything where they can do the name, email, message, or you can keep that in there if you'd like. But I am going to get rid of this. So we're going to go right here. That's the section. So don't delete this section. We want that. I'm going to delete this footer section is what they're calling it. And now we have this address, phone, email, social. And I'm going to get to the social in just a second. It's, again, super easy. But for the address, I just put location. I don't want to give somebody my address or put it on a website anywhere. It's not something I want to do. So what we're going to do is just I'm going to put Dallas and Texas, and we can keep it like that. And we'll hit save, and it'll have Dallas, Texas. I hate the look of the zeros, 67890. So we're going to do that. Phone number 123567890. And then email, and we'll put Alex the Analyst 95@gmail.com. If you have issues with this, you can email me, but I will try to respond to all your emails. I get a lot. So I will do my best, but that is my actual email if you were curious. Now that we have this, we also have this social media. Now I want to display my LinkedIn, and I also want to display my GitHub. So what I'm going to do right here is I'm going to go over here and do LinkedIn. Perfect. Let's go to this. So I'm going to take my LinkedIn URL, and I am going to get rid of these first 2 because I'm only going to include 2. And for this one, I'm going to do LinkedIn. LinkedIn. And then for right here, I'm going to replace that with LinkedIn. And what you're going to do is put this link right here. And then we're going to go get the GitHub. So let's do GitHub. Oh, whose is this? Sign up. What is going on? There. Let's just go back here. I don't know. That was something I was viewing a while back or something. So we're going to take the GitHub, and we're going to put that right here. So it already has it as the GitHub. Is this supposed to be lowercase? I think it is. Let me see if this is lowercase as well. Yeah. So do it like that. Do it lowercase. I forgot that was how they did it. And that's the label. That doesn't matter as much. But this right here is the class is actually the important part, because then when we go back here, there is no LinkedIn image, but when we save it, when we save it, it has the LinkedIn image because it's already a class that was created in this HTML template. So we have that. And let me bring this full screen really quick, because there are a few things that we couldn't see in that screen. These right here are things that we could not see before, and these as well. So what we can do is we're going to go down here. We're just going to copy these social. We're going to replace them right here so they can have those. And then we're going to get rid of these two right here. And this says this is massively, and we're going to change that as well. Let's make this full screen for the first time. Feels good. I hate doing split screen, but I do it for you guys. So this is massively, and we're just going to get rid of these two. This is, it's called the navigator, the different tabs. We're going to get rid of those two tabs. And then for this, I'm just going to call it projects. And once we go back and update all of this, then you'll see those changes. So let's see. So we made those changes. Here's our social, or the social media stuff. We're going to go and copy these two. And we're going to replace all of these with this. And let's save that. And let's go back. So now, as you can see, those two are gone. This says projects. There's only two right here. And if you click on it, it's going to go to my LinkedIn, or your LinkedIn when you do it. And this will take you to the GitHub. So it is all working as intended. This is great. When you scroll down and it says massively, we can change that as well, and we should. Let's do that really quick. We'll just say Alex the Analyst. And we'll update that. And there we go. So in a nutshell, this is a lot of it. We need images, and I don't think I set this up for this video. So I'm gonna like cut myself off for like 2 seconds, go pull those images in, because it could take like a few minutes. I don't want to waste your time, and then I'll come back. So I'll see you in 2 seconds. All right, so I just pulled over the images that we are going to use. Let's go to the downloads. They're right here. They're the housing, Tableau, and COVID. If I open up this COVID one, this is what the image looks like. This is what we're going to use for that COVID project. So I'm going to copy these. I'm going to go into the port website that we just had. I'm going to go to images, and I'm going to insert these in here. So now that we have those images in here, let's go back and let's see what we got. So we just put these images in this, you'll have this folder right here, and you can open it up and you can see all of these that we have. So all we're going to do is go and replace the images, these temporary images that they had for us, and we should be golden. And then we're going to actually upload it to GitHub and then create our website for free. So let's go right down here. This is our very first one. This is our data cleaning in SQL. This is with the housing data. So this image right over here, it says images/pic01.jpg. So JPEG, I don't know why I said it like that. So this is the housing. So what we're going to do right here is do housing, and it'll autocomplete for us. So that housing should be in there now. Next one is the data exploration in SQL. That was with the COVID. So we're going to get rid of this. We're going to say COVID because that is the image that I have right over here. And then the last one is, Tableau. So let's go right over here. Let's do Tableau. Let's get rid. Oh, I got to save that. Control S. Perfect. And now let's look at it. There you go. There you go. Oh, this one still says full story. Go change that. I'm going to go change it. It just doesn't feel right. View project. Ooh, that's not how you spell it. Okay. Control S. Perfect. Okay. So now this looks a lot better. And when we host it through GitHub Pages or github.io, this is going to be what it looks like. I mean, it is, and you can add a lot more to it. You can take away from it. You can add as many projects as you want. You can keep adding, or you can copy those articles or those posts, and you can just keep adding them. So this is kind of what it's going to look like. And it was not that hard. I hope this was not too difficult. I really don't think it is. It's really just using a template and kind of understanding a little basics of HTML. So we are going to take this, and we have this saved already. We have this all saved. What we are going to do now is upload this to GitHub. So let's go right over here. Let's go to here and let's go to repositories. And where's the new one? Oh, I need to sign in. Okay, I'm going to get rid of this part so you can't see it. So we are going to say a new repository. We're going to call it Alex the Analyst 2.github.io. So we're going to write it just like that. If your name's Alex Jimmy, I don't know why I said Jimmy. AlexJimmy.github.io. You can always go back after the fact and change this. So it's not a big deal whether you change it or not. And we're going to create this repository. We're going to say upload an existing file. And instead of choosing them, what we're going to do is just go right over here, go to this, and we're just going to copy this in. Or not copy it in, but drag it in. Okay, so we're going to take this, drag it in right here, and it'll take a little bit. It says 75, but it shouldn't take that long. And let's just wait for it. I was taking a sip of water, I apologize. But it is literally uploading just everything that we had in there. So all the updates and all the changes and all the stuff that we had, and it looks like it's done. So let's just write initial commit changes. It is processing it. All right, and it should be done very, very soon. As long as I have a good internet connection. We shall see. Stick with me. It's taking its time. While it's loading, let's go over to, there it is. So perfect. So here's everything that we have, has this README that it generated. Let's go over to settings. And we have this github.io. And if we go right down here to GitHub pages settings now has its own dedicated tab. Let's check it out here. So it is, it's currently disabled, but we're going to say we want it to pull from the main. I think it's the docs. We'll see. I'm going to save this. Your site is ready to be published. Let's open this up. Okay, site not found. Maybe it's from the root. Save. Your site is having a problem. Let me see if I can actually change the name. I already have an Alex the Analyst, but I'm going to see it's already taken. I'm just going to try this one more time. Oh, and now it's working. I have no idea why it didn't work before, but this is fantastic. It was giving me all this. I was just reading too much into that. I had never tried to create another .io or GitHub pages on this. So anyways, thanks for sticking with me through all that stuff. So now we have our actual website. It doesn't look the same up here because of that thing that we were just looking at. It should just be this part right here. But this is an actual website now. It's being hosted through GitHub and it's completely free. If you want to pay, you can hide this from your GitHub. Your repository has to be public. Something I didn't mention, when you're doing this, your repository has to be public. If I change the visibility to private, you will not be able to see it anymore. You'll have to then pay if you want to make this repository private. You have to then pay, I think it's like $4 a month or something like that. So worth looking into if you don't want to display that on your GitHub. Worth looking into, but this is our final product. I mean, it looks pretty fantastic and you can use any of these templates, right? There are lots of different templates that are fantastic. I mean, they look amazing. They look professional. It's really up to your style. Like this one looks kind of cool, a little bit edgy for my taste, but this one looks really good too. Might be able to add some more narrative to that one. So again, go through it. Make a good choice in it and then update it how we updated it. I will include the, let's see. I will include everything that's in here and I'll keep this on on this GitHub so that you can go in there. And if you want to download these images, you can download the images that I used, or you can go find your own. Just, try to get like HD images on Google. Just type in Google Images and search for whatever image you want to search. Try to get an HD image. With that being said, that is the entire project. I hope this didn't go too long. This may have gone, like 30, 45 minutes. But in the end of it, at the end, which is where we are now, we have an entire website. It was completely free. And I hope that you can now host the projects and you can create more projects. I will be coming out with more projects myself that hopefully will be interesting to you in the future. So with that being said, thank you guys for joining me. For you who stuck it out to the very end, you are fantastic. Send me a post to your website on LinkedIn and tag me in it because I love seeing you guys do these projects and this stuff. So I'm super excited to see all of these that you guys tag me on LinkedIn and whatnot. So with that being said, this is it. I hope you learned something. I hope that it worked for you. And I appreciate you watching. Be sure to like and subscribe below, and I will see you in the next video. Goodbye.
What's going on, everybody? Welcome back to another video. Today, I'm going to help you create a data analyst resume. Now, when I say data analyst resume, it's not that much different than a regular resume, except that it's going to be catered for a data analyst job. In just a second, we're going to take a look on my screen at a sample resume. I'll have the template in the description so you can just go and download it and fill in your information, but it's a fantastic starting place to actually creating your resume. When we're looking at this resume, we'll take a look at each section, kind of dissect each part of it. And then at the very end, I'll give some extra tips on what you should include and how to actually write your resume as well. So without further ado, let's jump onto my screen, take a look at the resume and see how you can create your own data analyst resume. So here's our sample resume. I'm just going to walk through the entire thing super quick, and then we'll break down each section individually. I'll give my thoughts and some tips on each section. And remember, you can download this exact thing in the description below. I'll have a link. I'll probably put it on my GitHub or somewhere else, but it'll be free to download. So you can go ahead and do that. But let's zoom in just a little bit. So at the very top, we have our header. We have some just basic contact information. Then we have skills. Then we have projects, and notice the projects are up here at the top, and we'll get to that later about the order of where you should be putting your things. Then we have work experience, and then we have education. So really quickly, I'm gonna zoom out, and I hope you can still see it. The order is actually quite important. Now there is one piece that is not in here right now, and that is a summary section. I don't have a summary section on my real resume. I don't think it's useful or helpful. I don't have one. You can include one, and it would be right up here at the very top. Now, why do we have the skills and projects at the top? Well, it's because that most people who are trying to break into data analytics don't have any experience in data analytics. If I am reading this resume as a hiring manager, and the first thing that I look up here and I see is experience, and it's not analyst, it's a teacher or a nurse or something, I'm going to be like, this person doesn't have any experience. I don't want to hire them. The first thing that you want to have in your resume is something that is good for the hiring manager to see. The first several things. You should put all your best stuff at the top. That's my what I believe. So I think that these skills are really strong. A lot of great skills. And then these projects are all really good projects. Now this is just a sample. These aren't all real projects. Or they are real projects. They're just not, ones that I built myself. It's just a sample. So then right here, we have our work experience. Now, if you're, like I said, a nurse or a teacher or a lawyer or something that's not relevant to data analytics, you want that at the bottom. And then you're going to want to tie in some things in these descriptions and then the education at the bottom. My education was terrible. Okay, I had a bachelor's in recreational therapy, which had nothing to do with data analytics. So for a tech job, was not good. I always had mine at the bottom. So let's start at the very top and walk through each section. So at the very top, you want to have maybe a title, but for sure your full name. You definitely want to include your phone number if you're okay with them calling you, but definitely an email. For sure include things like a LinkedIn profile or a GitHub profile. You can also put your portfolio. In fact, I highly recommend putting your portfolio because it just looks good, or if they check it out, that's a really good thing. And then your location, because sometimes your job is going to be location-based, whether you're in Dallas or another metropolitan city. It's just nice to have that on there. This should be the simplest one to fill out. unless you haven't built out something like a portfolio, you just don't include it. But this one should be the simplest one, right? You're just putting contact information, maybe a link to a website. Next, we have the skills section. And this one on my own personal resume, I have at the very top. I typically recommend anyone who does not have experience, who is trying to break into data analytics, to put this at the top as well and have these skills and know these skills. That's important. But when the hiring manager first initially sees this, it's just going to be a mental check. Okay, they have the skills that we're looking for. Let's move on to the rest of the resume. But you want as many mental checks for what they're looking for at the beginning. I'm gonna keep repeating that. This is how I personally write my skills. So I write something like SQL, and then I'll say SQL Server, MySQL, PostgreSQL. Now, I have used all these different types of SQL in my actual job. If you haven't done that and you're just starting out, maybe you put something like, subqueries, store procedures, joins, whatever, the actual things within SQL. I don't recommend that as much because typically people know what SQL is. Like if they use SQL, they know what SQL is. So they're just going to expect that you know those things. Now, for something like Python, it's different because there are packages. Something like R, there are packages and libraries within them. So you can specify, I have worked with pandas in my actual job, and I look for people who know pandas as well because, we use it. So actually specifying these packages or libraries is really helpful. So this is how I would put these things on a resume. Now this is another resume. This is our sample 2. I'm gonna maybe include this one down below, although I don't like this format as much, but if you like it, you can. But here's another way that you can show these skills, just a different way to do it. I wanna show you both ways. We have like Python and the libraries underneath it. I've even seen it to where people will write out almost like, let me go down here. They'll write out like a narrative. They'll do Python, and then they'll have like a colon, and then they'll say used to manipulate data, and I'm not spelling that right, in pandas, ... And they write it out. You can do that as well. Again, I like bullet points because it's to the point. It's exactly what you need. Let's get rid of this one real quick. So this is the one that I like. So that's the skill section. Let's move down to the projects. Now, the project section is almost primarily for people who are just starting out. Once you get experience, typically you maybe have one project on there or no projects at all. But the project section is used as kind of in lieu of actual experience, right? I've always said that you need to build projects, not just for your resume, but also for the interviews. So then when you get into an interview, you can point to these projects and say, yes, I've used SQL. I did it in this project, and they may have seen it. And you can walk them through how you actually used it. It gives you more credibility than just saying you know how to use SQL. So within the project section, we're gonna have a project. This one says Data Science Job Market Exploratory Data Analysis. So this is a personal project, and then within it, they did some really great stuff. Here's usually what I recommend, and this is in here, which is you specify what you did. You say, I used Python, and what did you do to analyze this and gain insights in the job market? Then you walk through some of the things that you actually did. Things like regex techniques. You used pandas, matplotlib. You built a word cloud. These are keywords that somebody will look for. And they even highlighted them, which I personally like and do as myself. They highlighted these things so that the viewer or the hiring manager is actually seeing them, making sure that they're bold so that they are catching their eye. So I personally do this and I recommend this. That's all it needs to be. It just needs to be, I built a Tableau dashboard doing this from this data set. I cleaned it in SQL, and you show those skills. Something that's important in both the skills section and the project section is using and highlighting your skills as much as possible, especially if you don't have any experience, if you've never had a job before. Once you have a job and you come down to like the work experience, then it kind of speaks for you. But if you don't, you want the projects and the skills to speak towards your skills and credibility. So we have this right here. Now, one thing that's not in here that I actually do recommend is a hyperlink, maybe right here, or actually this being a hyperlink to the project. Because they might read this and be like, we work with, data science job market data. I don't know. And then they'll click on this link and they can see your work. That is the one thing that I would change in this. Other than that, this is exactly how I would have it. Very, very, very similar to my own. And a lot of this that I did, I actually took from other resumes and formatted it how I prefer and like it. So again, some of this is personal preference and you can change it however you want. That's just how I like it. So that is the project section. Now we're gonna go down to the work experience section. Now this person does have a little bit of analyst experience. So, if you don't, that's okay. But you put your previous experience. Now here's what I recommend. If you've been a teacher for 15 years, you've been a nurse for 10 years, you've had 10 different jobs, don't put all your experience on here. Maybe put your last 2 jobs, going back maybe 3 years. I don't recommend you filling it up because it's not going to be super relevant unless you're applying for a healthcare data analyst position and you have a nursing degree. Then it's relevant and that experience is super helpful because it's domain experience, right? Then you may go back 5 years. Just, use your discretion. But what do you need to include? Of course, your title, where you worked, your location, and the times. That's standard for almost any resume. But within here, what you really want to do is highlight again the skills. If you can. If you can't, that'll change. But in here, he says implemented a new reporting using Excel Pivot and VBA, which reduced processing time by 50%. These types of quantitative information, I reduced time, I saved the company money, I did something quantitative. Putting that in here is always helpful, always highly recommended, although it can be tough to measure these things, right? Typically what I recommend, especially if you're first starting out, is to highlight skills. If you're a teacher, you've probably used Excel, and you've probably used Excel for closer to data analytics than you'd think, just in a teacher way and not a data analytics way. But you can reword these things and make them sound good. If you are a nurse, like I was saying, you've used Excel. You've used a health information system. You've used some type of database. Talk to that. Include that in here. And it can be hard to write these out. And I'm going to show you a way in just a little bit about how you can write these out and think about these things or have a way to help you write them or give you ideas. We'll get to that in a second. Lastly, we have the education piece. This is, again, really simple. At the very bottom, education, what your degree was, where you went, and if you have, some helpful things to include, you can do that. And then when you actually went. Now, you can include other things in here as well, like boot camps, if you went to a boot camp. Or you could also include things like a GPA, although I don't personally recommend it. GPA has never been anything that I've ever cared about or I've seen anyone care about, ever. So you don't normally have to include it. One other thing that you can include at the very bottom is something like certifications. I personally don't put a lot of stock in certifications unless it is one that I have recommended in previous video, like the Tableau certification or Tableau desktop certification. If you're applying to a job that uses Tableau, that actually could be really good. So definitely include that. But one's on Udemy, one's on Coursera, or like my Alex the Analyst bootcamp that I have on my channel. I wouldn't really include that in your resume. It's mostly for learning. If you get something like the Tableau one or the AWS Cloud one or the Azure Cloud one, those are all actual certifications that can help you and give you credibility towards a certain skill. Now, really quickly, let's just take a glance at the other resume. This is resume 2. So we have the education at the top. Doesn't have to be at the top unless it's relevant, which you could put at the top. We have a skills section. This is the project, same projects. And then work experience. This is just a little bit different order. So you can do it like this as well. In different way you can write the skills, and you can also include a summary section as well. So that's the meat and potatoes of how I would create a data analyst resume. Now, writing it is actually a different beast, right? You have to actually write it out, get something on the resume, and then apply using that resume. But it can be hard to come up with these ideas. So I just want to show you something that a lot of people have been using. I personally haven't written a resume in a little while, so I don't use it for my own resume or haven't used it, but I will. And that's using ChatGPT or some variation, whether it's on Bing or you get some different version or some new product that's out there at the moment. I'm just going to show you how to do it in ChatGPT, some of the things that you can prompt it to do, and that'll be it. I'm just going to show you kind of some ideas that it can generate for you to help you write these things. All right, so here on my screen, we're on ChatGPT. If you haven't used it, I'll leave a link in the description. I also have a whole video on how to use ChatGPT for data analysis. So I like ChatGPT. Now, I've already written out these questions, so I don't want to wait for the responses, but here's what I asked it to do. And you can do some variation of this, whether you're a nurse or a lawyer or a teacher or whatever. I said, I'm a math high school teacher trying to become a data analyst. How can I use my experience on my resume to help me get a job? This is just to help provoke some ideas. And it says, you most likely have some skills. Emphasize your quantitative skills. So those are some of the things you can focus on. Showcase your ability to commute complex concepts, which is really important in data analytics, being able to present information, which teachers have. Highlight your experience with technology. Hopefully you're using some type of database for students or, Excel or something like that, and you can highlight that. And showcase your ability to solve problems. Now, the next thing that I asked it was, I built a COVID Tableau dashboard using Tableau. How can I add this to my resume? And then it's going to tell you exactly how you can do that. It's going to say, include the link to your dashboard, which I also recommend. Provide a brief description, highlight your data visualization skills, include screenshots or images, which that's what I would be putting in the project itself, not on your resume. And then provide context for the data. All really good stuff. Really great. Now, the last thing is kind of what I'm trying to get at as a whole. It can help you write things. So I'm going to say write two sentences highlighting my COVID Tableau dashboard to add to my resume. And it's going to say, developed a COVID Tableau dashboard to visualize pandemic trends using real-time data sources, demonstrating strong data visualization and analysis skills. So this can help you generate those descriptions in your work experience. It can help you generate the descriptions in your projects. And this can be really helpful to just generate some ideas, because I personally really struggle with highlighting my skills and descriptions within those things. This can be a way to kind of help you do that. So don't, just copy and paste, but let it prompt you, let it give you ideas. Now, the last thing that I want to mention is just your overall resume as a whole. The template that I use, the template that I recommend, is very, very friendly to these automated systems that check your resume. If you did not know, most companies, especially big companies, use these automated systems that scan your resume, see if it has what they're looking for, and then that resume, if it gets through that system, gets passed on to a recruiter or hiring manager. Typically, most companies don't go straight to the hiring manager. So you need a resume that can pass through those initial systems and pass those tests. The resumes that I've shown you today will do that. They have bullet points, they have the keywords, they have everything you need. That's why I recommend, or partially why I recommend, this type of resume. Other ones that have images and different fonts and different stylings can cause issues with these automated systems where it just doesn't read it properly, or it doesn't read the right words that you want it to read. So just know that these types of resumes have different uses, right? You're not just handing it off to somebody to where they can read it and it needs to be visually stimulating. Really what you need is it to get through those initial systems, which these resumes, if you write them well, you have good, skills and the right things on your resume, they will pass through that first layer to get to those hiring managers. So again, be sure to download those. Those are completely free. I highly recommend using them. I think they're really good. So be sure to download those, use those, just put in your own information. Be sure to build out your own projects. Don't just keep the ones that are on there, because you'll need to be able to speak to them. Sometimes recruiters or hiring managers are going to ask you about them, how you built it, what you did, and you can also point to those projects in your actual interview. So I hope that this was helpful. I hope that your resume is ready to go. I hope that you're ready to start applying for those data analyst jobs. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video.
What's going on, everybody? My name is Alex Freeberg, and today we're going to be walking through my top 3 tips on how to use LinkedIn to land a job. LinkedIn is a fantastic place to look for a job. It's its own little ecosystem where career-driven people can connect and talk with one another and help each other find jobs. I personally have landed jobs through LinkedIn, and so I know how effective it can be. Let's jump over to my screen, and I'm going to show you my top 3 strategies that I have found to be the most successful to actually finding a job. So I'm logged into my completely anonymous account here, and I'm going to show you the very first tip, which is you shouldn't be just applying to a position. You should be actually reaching out to the recruiter, and I'm going to show you exactly how to do that. So the first thing that we have to do is to actually find a job that we want to apply to. So let's go to the job section right over here, and let's search for data analyst. And let's do that in Let's do Chicago, because why not? So it's going to search for data analyst positions in Chicago. We have one right here. Let's see what it looks like, because I don't want to apply to jobs that I'm not extremely qualified for. So this is a job that I want to apply for. And before I actually go and apply to the job, I want to see if I can reach out to a recruiter and talk to them beforehand. So let me show you how to do that. So what we're going to do is actually click on the company right here. And it's going to take us to basically their LinkedIn profile page for their entire company. And we're going to scroll down. We're going to go over to people. And then we're going to search for recruiter. So if we scroll down all the way to the bottom, we can see that there are recruiters that actually work in-house for this company. And so now would be a time where I actually reach out to some of these recruiters and I say, hey, I see a job that I really like, I think I'm really qualified for, and I would love to talk more about it with you. You can ask them things about the job to make sure that it is a good fit for you. And then I highly recommend you asking them what they think is the best way to apply for this job to make sure that your resume gets noticed and you get an interview. Since they are a recruiter who works at this company, they may be the one who's actually going to be looking at these resumes. And so they may give you a tip on the best way to actually apply. They may also just ask you to send them your resume directly so that they can look at it. Or maybe later on down the line, this actually is a person who's reviewing resumes. And so if they come across your resume, they may be able to put a face to the name, and that may give you bonus points. I'm going to leave a template script in the description in case you don't know exactly what you want to say to this recruiter, and it'll give you just a baseline of some of the things that you might want to say. Number 2 is to actually ask for a referral. Now, if you don't know what a referral is, it is where somebody who already works at the company can refer you to a specific job, and it might get you a little bit higher on the list for interviews. So I highly recommend reaching out to somebody who already works at that company and ask if they're willing to be a referral for you. I get people reaching out to me all the time asking to be a referral for them for my company, and 9 times out of 10, I say yes. I always ask to see their resume first just to make sure that their resume aligns with the position at least a little bit. But there's basically no harm in me being a referral for somebody. In fact, I may actually get a bonus if that person ends up getting hired. And so for the most part, there's almost no risk for the employee to actually being a referral. And so a lot of times they will say yes. Now let me show you how to do that. And it is very similar to finding a recruiter. So we're going to stay on this people section, but instead of searching for a recruiter, we're going to search for a job title that is similar to yours. So let's actually see if they do already have any data analysts. And if they do, that is the person that we're going to reach out to, because that is the person we'll probably have the best connection with. So it looks like we have 6 employees, and let's scroll down. And so it looks like all of these people have data related jobs. And so I would reach out to these people and say, I saw an open data analyst position at your company. I would love to know more about your company as a whole. And then you can talk to them a little bit. And then in the end, your goal is to ask them for a referral. And if that happens, that is fantastic. And then you can go ahead and apply for the job and mark them as a referral for you. Now, my third tip on how to get a job through LinkedIn is to actually have recruiters reach out to you. So let me show you how to do that. The first thing we're going to do is actually go over to my profile here, and we'll click view profile. Now, there's a few things that we want to make sure that we have on here so that recruiters can reach out to us. The first thing that I want to do is to actually come to this section right here, which is show recruiters you're open to work. And when I click on this, I can actually choose some job titles and some locations where I actually want to apply and have recruiters reach out to me. And so right now I have data analyst, I have in the DFW area, which is where I live. I can also add titles like business analyst, and then maybe junior data analyst, entry-level data analyst, or things like that that could potentially have recruiters reach out to me for positions that I'm interested in. And then you can say that you're immediately and actively applying. And you can also say that you're only looking for full-time positions or contract positions. And then you can actually add this to your profile. And I only want recruiters to see that because I do currently have a job at McDonald's. And so I don't want McDonald's firing me because I'm looking for employment elsewhere. So let's save that. And it looks like it was updated. And so now when recruiters are searching for candidates for a specific position, you will be on that list so that they can find you and reach out to you. Something else I should mention is on your profile page, I would try to have some type of professional photo so that you look really good. I would also try to include data analyst somewhere in your title. If you already have a data analyst job and you're looking for another one, you can just have your previous company. But if you're looking for a data analyst job, you can always put seeking data analyst position or something like that. Another thing that I think is really important is having really good descriptions for your previous work. I don't currently have this, but I would go a little bit into the work that I actually do. Make sure that the experience matches kind of what you're looking for if you do have previous experience. If not, that's totally fine. The next section on your profile page that I would recommend looking at and updating is your skills section. And so you want to go in there and make sure that you have all of your relevant, really data analyst heavy skills on there, specifically hard skills, because soft skills aren't going to translate too much into this section. I would definitely stick to things like SQL, Python, Tableau, Excel, things that data analysts are going to use, because this is where they're going to actually look and see if you have the skills that they are looking for that position. When I was applying to jobs and only applying to job postings and not using any of these strategies, my success rate was 0.04, which means out of 1,000 applications that I filled out and sent my resume to, I only heard back from 4 of them to actually get an interview. But with these strategies, I was able to get that up to 10%, and at my best, I was able to get that up to 15%. But that's because I was applying to a lot less positions and I was targeting jobs that I really wanted to work for. And so I put in more effort in order to contact people and work with recruiters in order to get that job. I genuinely hope that these strategies can be helpful for you, especially if you're trying to apply for jobs right now. Thank you guys so much for watching. I really appreciate it. If you liked this video and got anything out of it at all, be sure to like and subscribe below, and I'll see you in the next video.
Hello, everybody. Congratulations. If you are watching this, that means that you completed the Data Analyst Bootcamp. If you haven't, don't keep watching. This is only for people who have completed the Data Analyst Bootcamp playlist on my YouTube channel. Woo! All right, now that we filtered those people out, I'm going to show you how you can download your certificate and your certification now that you've completed the Data Analyst Bootcamp. I will leave a link in the description, but let's go onto my screen. I'm going to show you how to actually access this and download your certification. All right, guys, don't go around telling people this or sharing this, but this is our Data Analytics Bootcamp on the Alex the Analyst GitHub right up here. I will have this link in the description. What you can go ahead and do is you can come right here and you can download this. You'll just right click or click download and just do something like save image as, or you can come to this one. This is the one that I think is the real money maker here. This is the certificate of completion for the Data Analytics Bootcamp. I have my, not signature, but my name as well as my position with a blank space right here to fill in your name. Feel free to put this on LinkedIn or Twitter or Instagram and tag me in that, because I would love to just say congratulations, because honestly, it's a lot of work to go through all those videos and learn all of those skills. So congratulations. I hope that you learned something along this journey, a new skill, a new thought, a new idea. And I'm proud of you. I'm proud of you for putting in the work. It's not easy, but you did it. And I hope that you came out on the other side better for it. So congrats. I'll see you in the next video.